Hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I'm here to give something very important to all of you, and that is one session, one class. It might be a little long, but which will cover up every single chapter in your PU2 syllabus, and we're gonna solve all the PYQs, whether it is 1 marker, 2 marker, 3 marker, 5 marker, based upon different chapters, based upon blueprint. We're gonna solve all the PYQs for the last 5 years alongside the important questions from your question bank. I'm going to repeat, in this class for all 13 chapters we will solve all PYQs and all important questions from the question bank, and these questions are of all the categories based upon the blueprint that we have from the board. We're going to take those questions like whether it is MCQ, whether it is 2 marker, 3 marker, 4 marker, 5 marker, 6 marker. Clear what we're going to do? Again, this will be a recorded session, so if you're thinking you're watching live, I might not be able to take your comments and your doubts at that point of time in this session itself, but you can certainly put your comments below. I will take those comments and reply to them. I'll be watching with you. I'll be helping you to get the real-time answers. Whatever I can do, the best I'll do for all of you. Okay, and even if I'm a little late, I will answer all of your queries. So do not forget to leave your doubts and queries in the comment section. Okay, so with this clear, let's start our one session where we're going to cover everything for our PU2 syllabus for entire chapters, all PYQs, all 1 markers. Okay, so starting the class right now. Okay guys, relation and function. How many marks of questions are coming, sir? Check here. 1 mark from MCQ, 1 is a 3 marker, 1 is a 5 marker. Add them. 5 plus 3 plus 1. 5 plus 3 plus 1 is how much? It's going to be 8 marks. Sorry, 9 marks, right? 1 plus 3 plus 5, total is what? 9 marks over here. Then sir, it is an optional row. I can choose to release it or not do it. Why would you do that? If you solve this easy chapter and you get 9 marks, why won't you select these 9 marks? Okay, so basically this is very important. Okay, 9 marks from the chapter, the first chapter, relation and function only. So do not skip it, do not take it lightly. Okay, so same way I'll give the analysis for every particular chapter, how many questions are coming, why to do it, what type of questions to do it. Okay, because we are aiming for 90-95 plus marks in our mathematics, and I'm going to make that happen for you. Just trust on me, keep working hard with me. If you do that, that's it. Okay, so this is your blueprint. I hope this is clear. 1 3 5, total is 9. I already written over there. Total 3 questions will come. Yes, there will be options. In the other category, MCQ is a mandatory section. It's a compulsory section, so that has to be done from all of you. I hope the clarity is there for the blueprint side. Okay, again, this is as per your 2026 examination by your board. Okay, next, what is next, sir? So in the session today, what I have brought for all of you, how are we going to conquer this particular chapter, relation and function? What are the the ingredients of this particular session is, start from here, the revision. Yes, the concept which is there for your syllabus, I'm gonna revise that as well. So first will be your revision. Later on, next comes your question practice. What questions the category was? 1 marker, 3 marker, 5 marker. Check here. MCQ, SA3 and LA5. Short answer 3 marker, long answer 5 marker. So I've taken questions like this only. Total I have taken 24 questions actually, but I'm going to solve 23 only. Check here. 12 plus this and this, if you add them, will become 24. But I'm going to solve only till question number 23 because I'm going to give you homework as well. Even it's one question but carries 5 marks. I want to know how many of you are actually attempting that question and how many of you are actually interested in getting that 95% marks in maths. Okay, so I'll give you one question as homework today. So do wait till that end and solve that question as well from your side. So I'm going to discuss total of 23 questions from my side, one question as homework. Next, I'll also let you know the most important topics of this particular chapter, relation and function. Okay, so for this chapter actually not much is there. We have only the definitions of reflexive, symmetric and transitive. Then we move on to 1 and on to functions. But still, for other chapters to come, I'll let you know from where you can expect the questions. That's why most important topics. Okay, so let's move on to the session itself now. I hope this is very much clear, starting with your first thing, which is revision. Okay, let's start. So complete revision of the concepts. First thing is, so there are more than these 3 definitions, but this is about exam point of view. So if you understand only exam point of view, these are the 3 which is very important: reflexive, symmetric and transitive relation.
check here. If you have any, again, to write a relation you need what? You need something that is called a set. So let's say I have a set A. I have a set A defined like this: 1, 2 and 3. 1, 2 and 3. I have taken a set for a reason that I'm going to give you examples also. Okay, sir. All right, sir. Accepted. Check here. For the set 1, 2, 3 are the elements in the set. If I have to define a reflexive relation in the set A or on the set A, I have to consider what? An ordered pair. Relation will always have an ordered pair. Okay. So let's say the ordered pair is A comma A. In case of reflexive, it becomes A R A. The ordered pair is what? A comma A. If you have, for every element, listen to me, for every element in the given set A, if you have the A comma A ordered pair present, then what will happen? Then that relation can be called as reflexive relation. For example, for the set A, for this set A, the relation R1 will be reflexive only if it has 1 comma 1, 2 comma 2 and 3 comma 3 and 3 comma 3. If even one of them are missing, it will be no longer reflexive relation. Okay, so sir, isn't this same as identity relation? Yes, it is. So far this is same as identity relation. Then you might have a question, so then what is the difference between reflexive and identity? Are they the same thing? No, they are not the same thing. Identity is what I've written over here on the screen. Reflexive has a definition that apart from these three has to be there. We can also have other ordered pairs. I can have 1, 2, 2, 3. I hope this is clear. Okay, let's understand reflexive properly. AA should be present for any set given like this. Moving on to symmetric now. Okay, so with reflexive clear, let's understand symmetric. Very simple. So in this we had a case of every single element in the given set where you're defining the relation R1 on A. Okay, in this case you'll not have a case of all the elements. Whatever element follows the ordered pair AB. Okay, so this will mean ordered pair AB. ARB means ordered pair AB. Then if this is the if condition, this is my if condition, means for the relation R1, if AB is present, I should also have BRA present. So ordered pair should be B comma A. So example, if I have to take, check here. So if I write a relation R1, if I have 1, 2 present over here, and I want to call this relation to be symmetric, I must have even 2, 1 the ordered pair also present. So 1, 2 ordered pair is present, so as 2, 1 also should be present in the case of this symmetric relation. Are the first two clear? Moving on to the next one, which is transitive relation. This is important and this is where student gets stuck on it. Now before I move on to transitive, I want to say one statement. So whenever you have a question in examination on this property, do not look for the values of X or whatever is ABC, the ordered pair, where these relations are symmetric or transitive or reflexive. Look for those values where it is not reflexive, not transitive and not symmetric, because even if you can find one such ordered pair, then the given statement or given functions or relation can never be that particular type. I'll repeat myself. Try to look for those examples, those values where the given relation is not transitive, not symmetric, not reflexive. It's easier to identify that way. Okay, clear? Let's move on then. Yeah, so for transitive relation now, what is the condition? We have two if statement over here. So you'll have two if statements, which is ARB, means the ordered pair is A comma B. Next is what? BRC. The ordered pair is B comma C. These two are both if statements. Then statement comes over here as ARC. So what it means is basically, if in a relation I have AB, for example, relation R1 has AB means 1, 2, and I have, let's say, 2, 3. I have 1, 2 and 2, 3. Then for the given relation R1 to be transitive, I must have 1, 3 also. Check here. AB, BC, then AC should also be there. If there is 1, 2, if there is 2, 3, then I also should have 1, 3 as well. Okay. Now I want to say one more thing over here about all of these. So one second. Especially about transitive relation. Especially about transitive relation whenever you have this combination. Okay, whenever you have AA combination and BB, if you have in a relation ABB, and they're asking you to check whether if you add AB, will it be transitive or not? Always. If ABB and AB is there, always transitive. Never check for it. If ABB, AB is there, never check for transitivity. It'll be always transitive. Okay. Other condition, if you have ABB and you're looking for, let's say, BA. This is AB, this is BA. If they're saying this combination ABB, BA, even that will be always transitive. So whatever, if you have the that identical wala ordered pair available and you're looking for AB and BA, don't check, it will be always transitive. So if you have ABB, then AB will be always making a transitive relation. Okay, let's move on. I hope this is clear. So that's what I'm going to do for your relations part. This is the end of your relation. I will not drag it anymore. Okay, so concept, I've explained everything with the help of these three classifications only. I hope this makes sense. Let's move on to next part. Next part is functions. This is another name for functions. Do you all know it? It's also called as mappings. It's also called as mappings. Okay, so function definition I'm not going to write, is there in your NCERT. Do check it. So but I'll tell you. Okay, what is it? It always involves two sets over here. The set will be from, let's say it can be A to A, but we'll write two different sets. Let's say defined from A to B. From A to B. Okay, this set A is called as domain. This set A is called as domain, and this set B is called as codomain. It's called as codomain. Okay, sir, that much is clear, sir. This is domain, this is codomain. What next? The next thing is, for every element in the set A, listen to me, for every element in the set A, there should be a unique element in the set B. Okay, for example, I said mapping, right? Let's do a mapping. This is my set A per se, and this is my set B. I've written the domain and codomain. So if I have, let's say, elements 1, 2, 3 and 5. Here I have, let's say I have A, F, E, T, A, F, E, T. Okay, this is 5 I've written. So what I meant when I said that for every element in set A, there should be unique, means for one element, it cannot go to two options. Means the same element will not be mapped to two different elements in the codomain. If there's a mapping like this, it will not be a function. Listen to me, if there is a mapping like this, it will be not a function. Okay, so basically for one x, there will be no two values of y. But the opposite is true. Check here. If I write like this, what about this, sir? Yes, it is true. For one x, I have one value of y. For another x, I have a different value of y. Basically, that is same. But for one value of x, for one element in the domain, I don't have two different values because it's going to be unique. So one A is also A. So A is uniquely with 1 and 2 related. Okay. So this kind of relation is called as function. Clear? Let's move on. Now let me tell you, we can understand the same mapping with the help of example also. Basically example of graph also. Okay, so if I draw a graph like this, for example, this over here, for one value of y, for one value of y, I have two different value of x. For one value of y, I have two different value of x. Means if I take this y value to be 1, I can have here -1, and here I can have +1. So either x is -1 or +1. It's both leading to what? It's both leading to 1 only. So this will be a function. But if I take this case, then for one value of x, I have two different value of y. This will be not a function anymore. Okay. So basically, how to test whether a given relation is a function? Just simply, if you can draw the graph of it, draw the graph and check whether it's able to satisfy the vertical test or not. What is the vertical line test? If you draw a straight line, you should have only one intersection. For example, for this graph, you check. For this graph, if I draw at any point a straight line, I'll have a unique intersection. Okay, so basically, this is going to be a case of functions. If I write here, function, yes sir, function, no sir. Getting my point? So this is the understanding with the help of graph. What is the meaning of mapping? What is a function? Function is when every element in the domain should be uniquely related to a value or an element in the codomain. Mapping part is clear. The test part of vertical line test is also clear. How to understand two type of cases when you have for one y two different value of x, and for one x we have two different value of y. Why this is not a function and why this is a function. So basics of the function is clear. Now we'll move on to the range. We have still not discussed the range, and then we'll go to one onto functions as well. So what is range now? What is range now? Let me try to write it for you. Over here you check. 3 is going to E, let's say, and F5 is going to T. So if you see this mapping over here, I can write an ordered pair, right? I can write an ordered pair. Let me erase these things. Okay, I don't need to erase, I'll just use this space, okay? I'll just use this space. Write the ordered pairs. 1 comma A, sir. 2 comma also A. 3 comma E, and 5 comma T. This is my ordered pair. This is my ordered pair after the mapping. So the y coordinate of the ordered pair, if you check, will be having A and then E and then T. There is no repetition, only AET is there. Only AET is there. Don't write A, E, T. Only write AET. Now this value here is called as range. This value here is called as range. Okay, check this carefully. First write the, after mapping is done, write the ordered pair. Not always you have to draw the mapping, okay, just to understand the concept that I'm telling you over here. After the ordered pair is done, after the mapping is done, write the ordered pair and check the y coordinate. That will be your range. Now check carefully. Range is not always equal to the codomain. What is the codomain over here? AFET. What's the range over here? AET. So are the range and codomain equal? No. So indirectly I've told you that whenever you have, I'll tell you an example. Whenever you have that codomain and range not equal, that is basically onto function. We'll get to that, no problem. But right now, just understand this. This B represents codomain, and this represents your domain. Written over here only. This is your domain. I hope this is clear now. I hope things are getting clearer. So I'll tell you what is my expectation from this slide. You should know what is function. Function is a mapping from element of domain to codomain. It should be unique mapping. Unique mapping 1 to A and 2 to A. They are unique in nature. For 1, I don't have two different values in Y. Okay. Vertical line test I have done for different type of functions. If you draw a vertical line, I should get only one intersection in the graph. That's vertical line test. Here it is disapproved. So that's why this is not a function. This is a function. Okay. Mapping part is clear. Now what is range? Only the y coordinate of your ordered pair is called as range. So this is what my expectation from this particular side is. Next we're going to move on to 1 and onto function. I hope this made sense to you. Moving on. Now it's time to learn the types of function that we have to deal with and from where the questions will come. So we have 4 categories. We have 1 function. Okay. Then we have, of course, many one function. Okay, then we have onto, and the last is into. The last is into. Understand this very clearly. 1 and many one are just opposite each other. What's the meaning of 1 function? So this is where every value of x will relate to only one value in y. So I showed you mapping now over here like this, that from this value I was going to 2 different values. Okay, sorry. This is not even a function, right? This is not even a function. Okay, I showed that I had 2 different value of x going to the same value of y. Is this a function? Yes. Is this a 1 function? No. For 1 function, what will happen? You'll have for every distinct value of x, distinct element of domain will have distinct image. The mapping, what you get after mapping is called as image in codomain. Okay, check here. So if I write an order pair A comma B, let's say A comma B, so this B is called as the image of the point A. B is called as image of the point A. Okay, so distinct element of the domain will have distinct image in the codomain or the set B. Okay, so basically the mapping will become like this. So if this is, let's say, A, this will be B. If let's say this is 1, this will be, let's say, something like K, and so on. Whatever it is, the mapping will be like this, always unique in nature. This is the case of 1 function. Okay, this is the case of 1 function. What about many one? Many one will be just opposite. This will be just opposite. For this, the mapping will be many to 1. Check here. So I have, let's say, 1, 2, and this is A. So both of these are mapped to the same element A. Same element A. Okay. Now onto function. Onto function is again, I'm going to explain you everything with the help of mapping. Then I'll teach you how to identify this using 2 approaches, algebraic as well as graphical. Okay. Now onto function. Check here with the mapping. So this here works with something called as range and codomain. Whenever you have range and codomain equal, that type of function is called as onto function. Okay. We have 1, 2, 3, and we have EF, let's say K. EF K. 1 to E and EF K. 1 to E, F2 2, and this is mapped. Okay. Check the ordered pair here. We have 1 comma E. If I write here directly, okay, let me write 1, 2 comma F and 3 comma K. What is my range? My range directly is over here as EFK. EFK is my range actually. What is the codomain? Codomain is also EFK. The set B is called as codomain. No, this itself is called as codomain. This is my set A and this is set B. Set B is codomain. Check here. EFK means the range is equal to codomain. The range is equal to codomain. That becomes onto function. If I write into, it will be just opposite. Let's say if I have E, F, K, I have also O. 1, 2, 3. So E, like this mapped, but we have one element O left out. Okay. So your codomain is what? EFKO, and your range is what? EFK. Not equal. When the codomain and range are not equal, it is called as what is it? It's called as into function. So I hope it is clear. 1, 1, many one, onto, into. Okay. 1, 1, many one is opposite to each other. Again, onto, into are opposite to each other. Okay, let's move on to the finding algebraic and graphical approach. Okay, so what is the discussion now? We're going to discuss how to identify a given function to be 1, 1 or onto. Let's start with the first one, which is fx is 1, 1 function. Fx is 1, 1 function. 2 ways. One of the ways, the most important one, the algebraic method. Other is the graphical approach. Useful in some questions, but not all. Okay. So let's start with the method number 1, which is going to be your algebraic approach. Okay, sir. Algebraic method works. Clear? Now what you do in this, you check for the condition that if f of x1 and f of x2 means the function value at 2 different points are equal. The function value at 2 different points are equal, then always x1 will be equal to x2. Then always x1 will be equal to x2. So you try from here, and if you get this actually the case, then you will say the given function is 1, 1. Other way also is there. Okay, other way is there, that if you have x1 not equal to x2, means the 2 different values, basically x1 and x2 are not equal. They are the different values. Okay, then f of x1 must not be equal to f of x2. This is the algebraic method. Is that it, sir? Yes, is that it? Sir, I did not get this, what you're telling me over here. Some of you might feel that way. It's okay, don't worry. I have taken so many questions when I'm going to discuss this method one by one. Okay, so works. So whenever you have, there are 2 situations. Whenever you have f of x1 equals to f of x2, you say that x1 must be equal to x2. And when you obtain this condition, you'll say that the given function is 1, 1 function. Okay, now the method 1 is over. Method 2, my personal favorite, graphical approach or graphical method. Method 2 is the graphical method. Okay, okay, sir. How to deal with this? Very simple. Do remember when I explained you the function definition, I said do a vertical line test. If you get two intersections, that's going to be not a function. The given relation will not be a function in that particular case. In this case, you're gonna do what? You're gonna do a horizontal line test. Okay, check here. I'll take example. My favorite example, modulus function. Another favorite example, a constant function y equal to 2. Okay. Another example, okay, let's take a linear function now. Few more examples we'll take to understand this better. Okay, I'll take few more examples. What happened? Okay, it's here. Example number 1, example number 2, example number 3, and example number 4. Example 3 would be y equal to x cube, let's say. Or we can go with sine function. Let's take sine function, but only in this domain. What is this domain called as? Minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2. This is a sine function. I hope you know that. Usually what happens if you take y equal to sine x, I can take what is the domain of y equal to sine x? What is the domain of y equal to sine x? Let me know in the comment section right now. I am watching your comments. What is it? All real numbers. Yes, but if I have given the restriction that it is from only minus pi by 2 to pi by 2, then we'll see the case. Okay, I've taken that example. And the last one, our all favorite parabola. Okay, parabola. 4 cases. What did I say? Do a horizontal line test. Do a horizontal line test. What do we do in that? Simply draw a straight line parallel to x-axis. Anywhere. Here, sir. But it should, touching the curve. Actually, cannot go like and draw it here. If you draw it here, sir, no intersection. No, you have to make sure that there's an intersection with the curve. Okay, over here you have to go and draw on the line. Okay, if over here, anywhere you draw, here or up also, you draw it over here. Okay, now check carefully. Whenever you have only one point of intersection, whenever you have one point of intersection, whenever you have only one point of intersection, then that given function will be 1 1. Here, is it 1 1, sir? No. So right here, not 1 1 means many 1. Opposite of 1 1 is many 1. So not 1 1 means many 1. Is it 1 1, sir? No. There is infinite number of intersections, sir. There is infinite number of intersection. Every point is a intersection. Again, many 1. Again, many 1. What about this one? Sir, only one intersection. This will be your 1 1. How about this? Sir, 2 point of intersection. This will be your again many 1. Please check. Now, there are different ways to make even these two functions 1 1. How do we do it? I know few of you might also already know. If you change the domain, if I say what is the domain of this function right now? All real. If I make only positive value from here to here, then it will become 1 1. For example, same condition. If I make only for positive value, it will become 1 1. So I hope the graphical part as well as the algebraic part is clear for 1 1 function. Let's move on to now. Okay. Now we are dealing with onto function. First thing is very important. Algebraic method. Now graphical method over here will vary with respect to your question to question. You have to check the domain and codomain, all of that. Okay, but for onto function the mapping is important and the algebraic method is important. And what is that? So method 1 or only important method will be algebraic method. Okay, so what you do in this? Simply you find the range. Find the range and put it equal to codomain. If it is there means it will be onto. That's it. Okay. And other way to understand this will be using mappings. If this is your codomain and this is your domain, okay, and you have elements over here, 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 1 2 3, okay, then this will be this is left out, right? Not onto. Okay, getting it? Let's move on then. Okay. The last is concept will be inverse of a function. So when can you say invertible function are there? When can you say given function is invertible? If a given function fx for any domain to codomain, of course, set A to B you can write. If in this set A to B, if the given function is both 1 1 and also onto. So if the given function is both 1 and onto, then it becomes called as bijective. Then it becomes basically, there's a given name for it, bijective. Okay, individually this is called as injective and this is called as surjective. This is called as surjective. So basically, if a given function is injective and surjective both, it's called as bijective. And if a function is bijective, you can simply say the given function fx will be invertible. Now it's time to solve some questions. Let's start. So the concepts are clear. We are moving on to the solving of the 23 questions that we have taken, starting from the MCQ. First one, the relation R in the set 1, 2, 3 given by R1, 2, 2, 1 is what? Simply symmetric. It's going to be symmetric only, right? So here's the answer, option B, symmetric. Yeah, 1 to 2, 1 is there. It's a PYQ also from your board. So it's 1 to 2, 1 means it's going to be only symmetric. Okay. Moving on, question number 2. Both the empty relation and universal relation is what? They are both trivial relation. It's a definition based questions. You have to know all these definitions. Where you will find these definitions? I have not discussed them. They're very simple. You can simply go ahead and check your summary of NCERT. You'll find everything for this chapter. Okay, the definition part. 2C. Next, 3. A relation R in a set A if each element of A is related to every element of A. Each element of A related to every element of A. Simply definition of universal relation. Definition of universal relation. Yes? Clear, right? Yeah. Question number 4. Let R be the relation in set N given by, okay, so basically B should be more than 6. So we have these 3 options here, 8, 8, 7, and difference of A and B should be 2. Correct, na? If I move A on this side, I'll get 2 equals to B minus A. Difference of B and A should be 2. Only possible in the option C. So option is C. Be logical in the approach, okay? Be logical. You don't have to solve it, right? Simply logic will get you the answer quicker. Fifth one. Consider the non-empty set consisting of children in a family and relation R defined as, okay? So your ARB represents A is brother of B. Okay. So if I say A is brother of B, will B be a brother of A? Not necessary, right? Because B can be a sister as well, right? So B can be a girl child, A can be a boy child. So A is a brother of B, correct? If we have this person A as boy and B as girl, then A is a brother of B, correct? Okay, but B is a brother of A? No, B can be a sister as well. So not symmetric. Symmetric? No. Okay, let's look for transitive now. So transitive will be 2 cases. This is dealt with. We'll have A, B and C. So A is a brother of B means it has to be a boy child because it has to be given, right? These are the if statement. AB is give statement. A is a brother of B means A has to be a boy, a male child. If B is a brother of C means even B has to be a boy. C can be either boy or can be a girl also. Can be a girl also. The transitive relation says that if ARB is true, BRC is true, ARC should also be true. From here you write ARC. Basically AC. A was boy. Let's take this case to be of girl only. Even that case is there. A is a brother of C. That's true. Okay. So it will be only transitive, not symmetric. Option B is true. So transitive, yes. Symmetric, no. Clarity is there, logic we're gonna use and get the question done very quickly. Question number 6. If n function defined from where to where? Now from here onwards, no. Whenever you have bijection 1 1 onto function defined, please be careful with the domain and codomain. Here it is natural number set. Now what are they saying? Y equal to x square. y equal to x square is the function. Check for 1 1 on 2. Okay, what is the way to check for 1 1? Check here, x1 square equals to x2 square, so x1 will be equal to plus minus x2. As I said, if I take f of x1 equal to f of x2, I should get only one value, but I'm getting two different values, so not possible, so not 1 1. What about on 2? Check here, x is root of y, right? Yes, so sorry, I'm having a little cold, so got a cough. Okay, let's continue now. X equals to root of y. What are you gonna get? Check. So from here, y is a natural number, right? Y is a natural number. So if you take a natural number like this, what will be this? I can take y value as, let's say, 3. So this answer can never be a natural number. Root 3 is 1.732, which is a real number but not a natural number. So for example, my point is, if I check here the mapping, so this is natural number means 1, 2, 3, 4 and so on, and over here also I'll have 1, 2, 3 and 4 so on. Okay, but this 3 will not be mapped, this will be left out. For 1 it will be what? 1. 2 will also be left out actually. 2 will also be left out. For 2 will be 4 and so on. So you can see some of the elements of the codomain is left out. It means not onto. Not. So answer is what? Option D. Answer is option D. Okay, fair enough. Question number 7 now. Let f z to z, we have fx equals to x cube. Okay, why? How are we going to go about this? x1 cube equals to x2 cube from f of x1 equals to f of x2, and from here if you take cube root, we all know it's going to be unique, so they're equal, so means true. Correct, na? Started with what? This is nothing but f of x1 equals to f of x2, and we're getting this. If somebody is thinking why can't we have plus minus sign, it doesn't work like that. In cube root we will have unique value. Okay, so please check. In that case it's going to be fx is 1 1 1 1. Now since it is an integer, okay, we'll continue for the onto part. Y equals to x cube I have, so I'll have x equals to cube root of y. So check here, if I put the value of y as 4, can you find cube root of 4? No. So this can never be equal to an integer. This will be some decimal value, right? So this will never be equal to integer. It will be a real number, rational number, but never a irrational number, but never a integer. Okay, so in this case what happens, basically the given f is not onto. So combination you check, 1 1 but not onto. Option C. Option C. Question number 8 now. Let a equals to 1 2 3 all the way till n, the number of surjections from a to a. Whenever you write a to a, no, whenever you write a function, whenever you write a to a function defined like this, means codomain is a as well as domain is also a. Then understand this, if the function is defined like this, okay, then if f is 1 1, then it will also be onto. If f is onto, then it will always be 1 1. That's the combination. So basically, if the function is defined on the same set as domain and codomain, if 1 1, always be onto, if always be 1 1 also. Okay, so if it is surjections, so basically surjections in this case will imply number of bijections, because 1 1 onto means number of bijections, and for that we have a formula as n factorial. Basically number of surjections here, no, will be equal to number of bijections in this case, which is nothing but n factorial. Answer is B. Getting my point? Yes? Okay, moving on. Alright, this is a question from your latest question bank given by your board. So question bank 2026. Okay, let's see the problem. The maximum number of equivalence relation on the set A, 1 2 3. Now if you know something called as Bell number, what is Bell number? Is the number of ways you can create a partition of a set with non-empty relations. Okay, So with non-empty, very important, the word is non-empty. So if you have 0 element, it will be 1. If you have 1 element, basically, so Bell number with 0 element of set will be 1. Bell number of a 1 element set will be, of course, 1 only. And same way, B3, in this case we have 3, it will be 5. It will be 5. So if you know B3 as 5, answer is what? Option D. Answer is option D. But for many of you who don't know Bell number concept, don't worry, I'll tell you. So for this case, no, we're looking for equivalence relation, right? So don't worry, we'll start from where? First is this only, no? 1, 2, 3. What is this 1, 2, 3 means? Basically the combination of all 1s, all 2s, all 3. 1, 1, 2, 2, 3, 3. Okay. So basically that is there. Then we'll have combination of 1, 2 and we'll have 3 also. Basically, so combination of 3 will be 3, 3. 1, 1, 2, 2, 1, 2, 2, 1. Right? 1, 1, 2, 2, 1, 2, 2, 1. Like that if you go, so you'll have a case another like this, no? You'll have same thing go with 1, 3 also. And you'll have 2, 3 also. And the last will be all. Okay? The all relation. So one more will be there. Answer is 5 in that case. 1, 2, 3, 4, 5. Okay? Next one. Okay, question number 10 now. Let FR to be defined like this. Okay. Domain. Domain is all real, but not possible. Because function is given as 1 by x. If I take 1 by 0, it will be undefined. Right, no? Because 0 is a real number. Am I right? Yes. If I take 0, then it will be undefined. Answer is option D. Answer is option D. Next, FR2R, fx2x plus 6, they are given bijective, means they have given invertible. They have given invertible. Now we are looking for inverse. Check. Inverse will be what? Simply y equals to 2x plus 6. Right here, y minus 6 equals to 2x, and then divide by 2. Y minus 6 by 2 equals to x. So I'm getting x value as y by 2 minus 3. Now change the variable to x and y. Okay, so this x will become y and this will be x by 2 minus 3. Okay, so basically what you do in finding the inverse of a function, simply make x subject and then change the variable from x to y. Okay, you get the answer as option A. Option clear. Next question. A contains 5 elements and the B contains 6 elements. Number of onto mappings 0. This has to be either more or equal to this, not less, not less. So number of onto mapping will be 0. This has to be more, not less. Okay, so basically NA has to be more than or equal to NB. The cardinal number of the set A has to be more. Next one. Okay, now we are moving to the 3 marker category. As I said, this chapter is going to be asking the question on 1, 3 and 5 marker. That's why here it is 3 mark category. Okay, let's solve the first one. Relation R on the set A. Again, this is a question from the question bank 2026 paper as per boards. So they are given a set A, R equals to x comma y, 3x minus y is given. From here what I can write is y equal to 3x. We are checking for reflexive, symmetric and transitive. Okay, check reflexive, though I don't think it's possible. I cannot have A over here. If you take x as 1, I cannot get y as 1, right? Y will be 3, so it's not possible. Okay, if I use y equal to 3x, no, I'll use x as A, I will get y as 3a, which is not equal to A. So given relation is not reflexive. Is not reflexive. Is it clear? Okay. Next will be what? Next will be your case of symmetric. Check here. Case of symmetric. For that I can take another case. I can take x as 1. X as 1, y will be what? 3. This is basically ordered pair is 1 comma 3. If I take ordered pair as 3 comma 1, it should also be there. So take this value y equal to 3 times of 3. I'm taking x as 3, no? 3, 9. So this is not possible, right? It means not symmetric. What about transitive? Let's check a combination. I take 1 3 3 9, right? They are defined. Y equal to 3x is defined over here, and over here also 3 into 3 is 9 and 3 into 1 is 3. But if I take the combination of 1 9, is it defined? Y equal to 3 into 1 is 3, not equal to 9. It means this is not possible. Hence, not transitive also. Not transitive also. Please check. Not transitive as well. So given relation is neither of one of them. Okay, let's start. Next one. Clear? 14th one. Okay. R1, R2 are two equivalence relations. Okay. I'm going to take an example and solve this. I can solve it with A, B, B also. Okay. Like AB and BA, like that we can solve. But let me do one thing. I'll take a simplest example. For example, I take this relation R1, let's say has, for it to be equivalence, let's say it has AA, it has BB. Okay, A, BB, that's enough. A, BB, and I should have, what is it? AB, and I should have BA. This is the equivalence relation. We all know that R1 is equivalence. Yes. So for R1 and R2 to be both equivalence relation, okay, let's say R2 is only defined with this. R2 should be only defined with this A, okay, or forget about that also. Forget about that also. I'll take another combination. I'll take this as, let's say R1 and R2 are two equivalence relation on a set. Okay, on the same set, right? On the same set, it has to be, of course, having the same condition, no? Having the same condition. Okay, this will be same like this. So if you take the union, you will have the same things, right? Without repetition. If you take the union, you will have the same result without repetition. Without repetition, that's how you take union. So basically you're going to end up with the same combination. If I take for all of them, okay, I'll take the same combination. If you want, you can take the combination of a set like this, 1 2 or 3. Okay, make a equivalence relation on this. I can make two type of relation. For example, I can make this 1 1 2 2 3 3. This is my, let's say, relation R1, and let's write a relation R2 also. 1 1 2 2 3 3. Okay, this is incomplete. Okay, all right, and we can write here 1 2 2 1. This also is an equivalence relation. If you take union of both, what is the answer? Simply R2. Correct, no? Because you won't copy anything, you won't repeat anything. So R1 and R2 union will be, in this case, R2. Now if R1 and R2 are both equivalence, the union is also coming as equivalence relation only, no? Check. Yes. So even the union will come as equivalence relation. I've taken both the cases of the variables and the numbers to show you that. Question number 15, let's solve now. So that the function fn to n, fx is 2x is 1 1 but not onto. Let's try for 1 1. F of x1 equals to this. Okay, 2 2 cancels. So yes, fx is 1 1. Fx is 1 1. What about onto? Let's try. Y equal to 2x if we have, I get x value as y by 2. Defined on codomain as natural number. I can take y as 3. I can take y as 3. Is 3 by 2 a natural number? It's never going to be equal to a natural number. It means there is some value of y for which there is no pre-image in the domain. Okay. So this number 3 over here, 1, 3, 5, these will be left out. So if you write here 3, 4, 1 will map to what? 2, 2 will map to what? 4, and 3 will be to 6, and so on. So basically some elements of this set will be left out. For that reason, it will be not onto. Not onto, right? So basically into. Not onto. Is it clear? Question number 16 now. Okay. Okay. If f r2 are defined by, all right, so that it is neither 1 1 nor onto. Let's start with the first one. f of x1 equals to f of x2. F of x1 equals to f of x2. So 1 plus x1 square, 1 plus x2 square, 1 and 1 is cancelled. This explained to this will be not 1 1. Okay, because for one value of x I'm getting two different values of x2. Okay, but they should have been equal. Actually I'm getting two different values, so not possible. Hence fx is not 1 1. Now check, I have y equals to 1 plus x square. What is the range then? What is the range? Range is nothing but 1 to infinity. Can you go below 1? You cannot go. X square can be minimum 0. X square can be minimum 0. If it is 0, I'll get 1. Any other value of x you're gonna take will be more than 1. Range is 1 to infinity. What is the codomain? You check. Codomain is all real number. Simply the codomain is not equal to the range. Therefore, the given f is not onto 1 1. Moving on to question number 17 now. So that the modulus of function f r2r is neither 1 1 nor onto. Approach will be same. Okay, graphical approach will be same. F of x1 equals to f of x2. So mod of x1 equals to mod of x2. So x1 equals to plus minus x2. Okay, so f is not 1 1. And for onto you want to check. For onto method, what is the range? Range is 0 and positive, means basically from all real number remove the negative real numbers. From all real number remove the negative real numbers. I can have 0 also, right? So from all real I've removed the negative real number. That's my range. And what is the codomain? Codomain is given as all real, which implies that they are not equal. So your codomain is not equal to the range. Hence it is going to be what? Not onto function. Not onto function. If you want to use the graphical approach to understand the same thing, let's do that. Check here. This is your modulus function. We are getting two intersections, means not 1 1. Okay. And what about this? This is all left out. Okay. This is left out. Means we have only positive values. So range is only positive or 0. This is left out. These values are left out in the codomain. Left out in codomain. Okay. Hence it will be not onto as well. 17th is done. Question number 18 now. So that the relation R in the set A given by this condition, relation A minus B is even, is an equivalence relation. Okay. So for reflexive, actually I don't need even the elements over here, because if I take reflexive relation, check here. Okay, I have to go like this. ARA, which makes the ordered pair to be A comma A. So if you write over here A minus A, you'll end up with 0, which is even. I can divide by 2, no? Can be divided by 2. Right here. Can be divided by 2. Can be divided by 2. Cool. Okay, next one, which is your symmetric. Symmetric, you check now. I'll have to go what? 1 2 2 1. In this case, we cannot have 1 2, we can have 1 3 3 1. Okay. So 1 3 3 1, and we have 2 4 is there, of course. 2 4 4 2, 2 4 4 2, and the last combination is 3 5 and 5 3. Also we have 1 5 and 5 1. These combinations are possible. Please check. Symmetric, right? 1 3 3 1, 2 4 2 4 2, 1 minus 3 is minus 2. Again we have 3 minus 1 is 2. If you take modulus, it will be even only, right? This will become 2. This will also become 2. Here also is difference is 2. Here also difference is 4. It means it will be even only. Okay. So this is symmetric. Please check. Okay. Basically, idea is that if A minus B is even, then of course B minus A will also be even. Will also be even. Okay, that's your idea for symmetric part. Moving on to the last case of transitive. Okay, last case of transitive. So for that you'll have 1, 3, 5. That's it. 1, 2, 3 and 3 to 5. 1, 3 and 5 in this particular set. Anything else possible? No. 1, 3 and 5 only. So for 1, 3 difference is 2, 3, 5 difference is 2, and 1, 5 difference is 4. So 1, 3 difference is 2, 3 minus 5 difference is also 2. So both of these are even, and 1 minus 5 difference is 4, also even. So basically what is the case here? Transitive relation as well. Now combination of all the three, if the given relation is reflexive, symmetric as well as transitive, it means it becomes simply equivalence relation. Clear? Simple question, right? Okay, question number 19 now. Let's move on to 19th. Prove that the greatest integer function is going to be what? Neither on 1 nor on 2. Of course you check. If you check here, what's the domain? Domain will be all real number, no? Here, domain and codomain are all real numbers. So if I take f of 1.5, what is the answer? It's going to be 1. F of 1.8. What's the answer? 1. So basically f of 1.5 is equals to f of 1.8. But 1.5 is not equal to 1.8. For two different values of f, I'm getting the same value of different values of x, I'm getting the same value in the function. It means the given function f is not, is not 1, 1. Is not 1, 1. Not injective. Moving on to the range side. Range, you check. Range of this function is always an integer. Whatever value you put, you're going to get always integer, which is not equal to the codomain. Hence, f is not onto. Done? Okay? Yes. Next question. Question number 20. F n to n be defined by fn equals to n plus 1 by 2 when n is odd, n by 2 when n is even. For all n belongs to natural number, then justify this whether a function is bijective or not. Okay, let's try. First we're gonna go about your 1 1 part. So let's find f of 1. 1 is odd, I'll use this 1. So 1 plus 1 by 2, which is going to be 2 by 2, hence 1. Let's try f of 2. N is even, we're going to use this. So 2 by 2, again 1. So I'm getting f of 1 equals to f of 2, but 1 is not equal to 2. Therefore, f is not 1, 1. F is not 1, 1. Okay. And what about onto function? Let's try the range as well. I'll take both the cases individually. N plus 1 by 2. I'll get here 2y equals to n plus 1. So I get n equals to 2y minus 1. Check. For all value of y from where? From the codomain. What is it? For all value of y here, codomain natural number. Check here. 2 into a natural number minus 1. 2 into a natural number minus 1. 2 into 5 minus 1. 10 minus 1 is 9. N will also belong to a natural number set. So means both of these are true. For all value of y from natural number set here, there will be an image in the domain. Okay, so every element in the codomain is mapped. Same way. Next one. Okay. N equals to 2y. Check here. For all values of y from the again codomain, any value you put, 2 into y will also be a natural number, so n will also be a natural number. So basically all the elements in the codomain has a pre-image in the domain. Okay, so it implies that codomain is equal to range because none of the element in codomain are left out. It's very important statement. I know it feels very silly, but it's gonna help you understand this whole thing very easily. None of the element in the codomain is left out. For that reason, the given codomain and range are equal. Hence, the function is onto. F is onto function. F is onto function. Clear? Okay. So this is the end of your 3 marker. We're gonna move on to the 5 marker now. What is this? 21. Consider f n to y. So domain is all natural number, no problem. Codomain. Codomain is actually this particular relation. Here. So let's write the codomain first. When x is what? X belongs to natural number. So x is 1, y will be 7. First element is 7. 4 into 1 plus 3 is 7. X is 2. So we'll have 4 into 2 is 8 plus 3 is 11. Okay. X is 3. 4 3s are 12 plus 3 is 15. X is 4. 16 plus 3 so 19. And we have again 23 and so on. Right? 7, 11, 15, 19, 23 so on. This is my codomain. This much is clear. Domain, you know, it is natural number. Now we'll move on to proving it invertible and find inverse. First step will be to do what? This. Let's find it. 4x2 plus 3, 3 cancels. Then we'll have 4x1 equals to 4x2 left. 4 cancels. x1 equals to x2. We all know the combination over here. If f of x1 equals to f of x2 and x1 equals to x2, it means the given f is 1, 1. The given function is 1, 1. Okay. Now moving to onto part. Now for this, you check here. Y equal to 4x plus 3 I have. Y minus 3 equals to 4 of x. From here I get y minus 3 upon 4. Now check carefully. When you put y as 7, you'll get 7 minus 3. How much is that? 4. 4 by 4 is 1. So when y is 7, I'm getting the x value as 1. When y you put 11, 11 minus 3 will be 8. 8 by 4 is 2. Okay. So basically for every element in the codomain, there exists a natural number which is part of your domain. So basically, if you check over here, your codomain becomes equal to the range. Hence, the given function f is onto as well. Now check the last step, finding the inverse of the function. So we have y equal to 4x plus 3. Make x subject, so we get y minus 3 by 4 equals to x. Interchange the value of the variable, y equal to x minus 3 by 4. This is your inverse. This is your f inverse of x. Check carefully. Question number 21 is done, complete. Next we are going to move on to question number 22. Now another question on the same rational function. X minus 2 upon x minus 3 is the function. We are going to look for 1, 1 onto. Let's try that. First condition is this only. F of x1 equals to f of x2. So x1 minus 2 upon x2 minus 3. Excuse me, my bad, it's wrong. x1 minus 3 and x2 minus 2 upon x2 minus 3. That's alright. F of x1 and f of x2 cross multiply. We get here x1 x2 minus 3x1 minus 2x2 plus 6. The first part, this two cross multiplication. Over here you check. Again you're gonna get x1 x2 minus 2x1 and minus 3x2 plus 6. Okay, check now. X and x2 is cancelled, plus 6 is also cancelled. So what I'm left with is minus 3x1 minus 2x2 equals to minus 2x1 minus 3x2. Just keep the like terms on one side. Okay. So I'll get here minus 2x2 plus 3x2. Am I right? Yes. Equals to minus 2x1 plus 3x1. Check here. This is going to be x2. This here going to be x1. Started with this, reaching over here. It means f is 1 1, sir. F is 1 1. Okay. Super. Now we're gonna find what? The range value. What did I tell you about that? Very simple, sir. Start the subject with y, make the subject x. Y equal to x minus 2 upon x minus 3. Cross multiply. I'll get xy minus 3y equal to x minus 2. Put the x terms on one side, y terms on one side, will get xy minus x equals to 3y minus 2. X is common, y minus 1 equals to 3y minus 2. So x equals to 3y minus 2 upon y minus 1. Now from here, find the range. Find the range. Check the range means the restriction on the y. Okay. So basically y can be anything but not 1. Because it's going to be undefined in that case. If you put y as 1, it will become 1 minus 1, which is 0. So y can be anything but 1. So basically, my range here will be, check, my range will be y belongs to all real except for 1. Check carefully, this is same as the set B. This is equals to set B. So what I'm getting here, my codomain is equal to the range. So the answer is what? Given f is onto. The given f is onto and 1 1. Okay, so we have the last question now. R1 and R2 are equivalence relation. They're saying that R1 and R2 is intersection will also be equivalence relation. We have to find out that. Okay. Alright, and they should be having one more statement here, that they are not disjoint. And R1 and R2 are not disjoint. It means R1 intersection R2 is not equal to null set. Okay, this is a statement given in the question. Okay, it's typing mistake. R1 and R2 are not disjoint means R1 and R2 intersection is not a null set. Okay, is not equal to a null set. Something is common. Okay, so let's say I am going to take common as the ordered pair AB. Let's say AB is the common ordered pair of R1 and R2. So I'm going to include this ordered pair AB in all the relations R1 and R2. Write the relation R1 then. So we'll have AB. It should be what? It should be a equivalence relation. So it should mean that it should have BA. Okay. AB is there means it must have BA also, transitive. And it should have AA and BB. Others are there, I'm not sure, but this, at least this must be there. Because I'm taking, let's say there's only one intersection possible, which is AB. For that case, R1 has to be this, right? Same goes with R2 also. R2 can be other things also, but minimum this has to be there. The minimum this has to be there. So AB, BA has to be there, and of course this has to be there. Even this has to be there, this has to be there. There can be more than this also. There can be CC, AC, BC and CA, all that be there. It's okay, doesn't matter. I'm saying have CC here, BC, CB, AC, CA, all that should be there. Whatever it requires to make R2 equivalence, do that, have it, okay? But now if you take the intersection of R1 and R2, what are you gonna get? You'll get actually the relation like this only, no? AB, BA, AA and BB. So basically whatever is the combination, the intersection will be at least this much. In that case what happens? In that case what happens? Even this will be a equivalence relation. So I have dealt with a question like this using union. Okay, this is another very beautiful question, so do solve it. If you want, try another taking another set 1 2 3 and solve like that. Okay, solve like that, because I said no relation in the set A. Define the set A. Okay, define a set A, and for that you write the reflexive relation R1 and R2. So not reflexive, equivalence relation R1 and R2, and continue. Okay, this is clear. Let's move on. Now last one, as I said already, I'm gonna give you one question as homework, and it's a very good question. Okay, it's a very good question. Now one more thing, I will discuss this question in your next session before I start the continuation. Okay, so I'll discuss it. I want to know if, but I'll discuss only when if you have solved it. If you won't solve, if you won't give me the answer, I'll not discuss this. Okay, so please make sure that you have solved this question. This is a 5 marker. This is a 5 marker. Solve this question and let me know how you got it. Next one. So next what we have is the last important information from my side, important topics. So basically what type of questions are expected. So 3 categories are there: 1, 3 and 5 mark. In 1 mark you can be coming on definition based, definition of the basics of relations, whether it is reflexive, whether it is symmetric transitive or universal relation or null set and all those things. Okay, so that can be asked in definition side for 1 mark. For 3 marker there can be a question on the reflexive basically equivalence relation. There can be a question, even 1 marker can be a question on number of relations, number of bijections, and those questions can also be asked. Okay, 2 categories. Number of, in the 3 marker we can have equivalence relation, or we can have your 1 onto function. Both can be asked. So this is given here, please check. And number 5 will be of course on the inverse of the function most likely, or they can sometime ask you relation to be equivalence or like that. Okay, what I chose the example, no, R1 R2 example that can be asked. And very important thing will be MCQ. From here you cannot lose marks. MCQ cannot be lost marks in it. Very simple. Reason is you have learned a chapter, right? MCQ is based upon the very basics concept of the chapter. It means MCQ has to be scored well in. So 20 marks, 1 marker are there, you have to score 18, 17 plus in the 20 marks minimum. If you can score 20, very good, but 18 plus 18, 17 you have to score in all the MCQ examination of mathematics. Okay, for your boards thing. So I hope this is clear. Chapter is inverse trigonometric function, and we have here the latest weightage from the blueprint. Okay, so we have 3 categories of questions coming from this particular chapter, which makes total of 3 questions and total marks of 6. 1 question from the single 1 marker, 1 question from the short answer 2 marker, other question 1 marker from short answer 3 marker. Total 3 questions, 1, 2, 3 is the total marks, and it becomes 6 in total. That's your weightage. Now what I have brought for all of you in this session is very simple. What are they expecting? We're gonna solve just that. Okay, so I brought 8 MCQs. Okay, then I brought next is 4 2 marker questions and 5 3 marker question. Okay, and apart from that I'm gonna do the revision for all of you. Revision, yes, I'll do the revision part as well, and then we'll do some, I'll give you some homework. I have a, I'm a little bit disappointed. I'm still to receive the answers for the homework question of relation and function. Do give me the answers of that, and I'm here to give you 3 more questions for homework of the inverse trigonometric function. Okay, and last I'll tell you the most important topics from where the questions can be expected directly even this year in the examination. Okay, and do trust me, in all the process that I'm giving you, all the stats that I'm giving you are very important. All the questions that I'm giving you are extremely important questions, means these are the must solve questions. If you skip this, you lose marks. These are the must solve questions in your chapter in the examination of PU2. If you will skip this, you lose marks, because these questions are taken from, these problems right here are taken from your model question paper, from NCERT and from your PYQs. Okay, so becomes very important to understand and solve it. First thing first, so we know that if we talk about the concept part, the revision of inverse trigonometric function, what all is there, sir? Starting my favorite, graphical part. The graph of the top 3 functions are very important: sine inverse, cos inverse, tan inverse. Others are not that important for our board's point of view, but yes, the first 3 are very important. Next comes your domain and range. Yes, and afterwards, after that domain and range part will be your properties based questions. So we'll see all of that. Properties, when I say negative angle and all of that I'll teach you with the help of questions only. But right now we'll discuss graph and the domain and range. Now graph. So we know that there's a name to this. What is the name of the chapter? The name is IPF. If I break it down, we get 2 parts to it, which is inverse is the first part and trigonometric function is the second part. Trigonometric functions have been learnt or not? Yes, we have, sir. Where have we learnt it? We have learnt in PU1. Yes, some of it we have learnt as entities in grade 10 also, but majorly we have learnt the trigonometric functions and equations in our PU1. All of you agree? Okay. Inverse, so that we have learnt in PU2 only, inverse of a function. So we're gonna apply them together in this particular chapter. Okay, so we have trigonometric functions, for example sine, cos, tan and so on. Inverse, we'll try to find their inverse. What is inverse? Inverse of function is basically the mirror image. If you draw the graph of the function, the mirror image of the function about y equal to x line. So if you take this as the mirror, this line as the mirror, whatever is the graph, it will become mirror image of the original function. This much is okay. Difficulty in understanding? We have a different approach also. The domain of the function and the range of the function will interchange. So domain becomes range and range becomes domain. Let me write it like this. So if I write a function, let's say f of x, okay, from a to b. Let me say it is 1, 1 on 2 only. So a is the domain and b is the range. Usually when they write the function, it is what? A is domain and b is codomain. I'm saying that assume it is an onto function. So it's going to be a range, a domain, b range. Okay. So a, b. If I'm writing b inverse, no, the answer will become b to a. Can you see over here carefully? B comes here, means B becomes the domain of the inverse function, whereas the A becomes the range of the inverse function. So this is what you define inverse with what? With what? With your algebraic way, graphical way. This is the understanding. Mirror image about the y equal to x line. Clear? 2 points are clear, no? Next is what? When can we say the given function is inverse, sir? Is all the function inverse? Sir, do we really need to know this question? You might ask me, sir, do we really need to know this question? Yes. If you don't ask yourself this question, when can we say the given function is inverse? When can we call a given function, function invertible? Sounds familiar, right? This statement invertible sounds familiar. Yes, because you've learned in PU2 first chapter. So yes, when can we call a given function invertible? Is it relevant? Yes, it is. Because let me define invertible for you. Invertible function are those functions which is bijective in nature. When fx is bijective in nature, then it becomes invertible. Any function which is bijective in nature becomes invertible. Okay, sir, you said it, I accept it. Meaning of bijective, sir, can you recall once? Yes, I will. Bijective functions are what? A function which is 1, 1, and onto. Both means it should have unique mapping and also it should have basically range and codomain equal. Okay, sir. Agreed. This much is okay, sir. You said invertible we need. What is invertible? Means bijective. Bijective is 1, 1 on 2. That much is okay. Sir, how is this related to the inverse trigonometric function? I'll go to this. Forget about inverse right now. We know that will change once we find the original function. We know how to make inverse of it. We can take the domain and range different. We'll make the inverse operation, or we'll take the image across the y equal to x curve graphical approach. We know how to do it. Okay, that much we know how to do it. But what about trigonometric function? How does it converse into? How does this will be following this condition of invertible? Let's try and understand this. Y equal to sin x. Y equal to sin x. First graph, my favorite, the easiest. Okay, let's draw the graph. Sir, this is wrong. Is it wrong really? All of you, tell me, do you remember the graph of y equal to sin x? Yes, you do. Even though it's a recorded session, I do watch your comments. I might be late, so leave your comments in the live comments when it is streamed, or you can leave in the comment section also. I will be watching your comments and replying it to it. Okay, there only I'll reply that time itself. So let me know whether it is a sine function or not. What is the answer? Yes, it is the sine function. Okay, now what happens with the sine function? Check, sir. Is it invertible, sir? Do a horizontal line test. Check. 1, 2, 3, 4, 5, 6 points. What happens to one function? It should have only one intersection. Only one intersection should be there. But I have how many intersections? So many. Then what we actually do is we do something called as truncate the domain. Something called as truncate the domain. Can we truncate anyway? No. Truncate the domain keeping the range same. Keeping range same or constant. So without changing the range of the given function, which function? Sin x. What is the range here? Sir, -1 to 1. What's the domain here? Sir, all real. So we're gonna make a restriction on the domain without changing the range. So we'll look for that part of the function, and then I show you, you'll understand this very clearly. Okay, so basically I'm gonna break it down over here. Check. If I break like this, and this is my major graph, only this much, check. What is the domain? Domain is, sir, -π/2, sir, to π/2. Domain is -π/2 to π/2. What about range? Sir, -1 to 1. This value right here is -1, sir, and this value right here is, sir, 1. Is the range changed? No. Did we get the truncation? Yes. Is it 1, 1? Yes. Because if you check the yellow line, it has only one intersection, sir. It has only one intersection, sir. So we can say the given function y equal to sin x is now 1, 1. Onto, because range and domain are equal. So basically my range and domain are equal, range is not changed. So what I have got? I have got the given function y equal to sin x, where from the domain -π/2 to π/2, this is the truncated domain keeping the same range as -1 to 1. Now it is invertible, and I'm gonna apply the invertible condition only to this marked part, and when you do that, you end up with this. When you apply that, you end up with this. This is the marked part. You check here. This is the marked part. Excuse me. This right here is the marked part. This right here is the marked part. And then you take the image of this. About which line? About this line. I'll show you. About this line. What line is this, sir? Y equal to x line. This will come. This here. This curve will become like this. It'll become like this. Okay, something like this will become. Okay, I want to erase this because it's too confusing, but you're getting my point, right? You're getting my point at least. Yes, sir, getting it. So you check here carefully. This part here is taking mirror image, and it's coming like this, and same goes to this part also. It comes like this downwards. It'll be moving towards me. So same part is here moving towards me. So this is your graph of sine inverse of x with the changes. What is this? Y equal to sine inverse of x. Domain, sir. Domain is going to be what? Of course, -1 to 1. And what is the range, sir? Range will become what? Range will become -π/2 to π/2. Right? In this case, what was the domain, sir? Domain was, sir, -π/2 to π/2. Sir, it was all real. No, it was not all real. We made the intersection. We made the restriction on the domain. So this is the new domain now, and the range is what? Range is -1 to 1. Now check, they are reversed. Excuse me, they are reversed. Okay, they are reversed. All right. This is your understanding how to obtain the graph of inverse trigonometric function. Okay. Same you go for cos inverse also. This is the cos graph. No, it is not, sir. Is it really not the cos graph? Check here. This is a cos graph. Y equal to cos x. Domain, what is domain here? All real, sir. Sorry, not all real. You have to make the change, right? We are truncating it, no? So 0 to pi, sir. What is the range? Range will be same, -1 to 1. What did I say? Truncate. Apply the restriction on the basis of range keeping as it is. And over here you check. This mirror image, if you take about this line, no? This is the line over here. Check. This is y equal to x line. This part here will go like this, no? Something like this, right? This part here will go something like this. Yeah? Correct, no? This will be, it's not very smooth, but you're getting my point, no? This part here is like this. Okay, and this part will become this one. This part will be taken over here. This small part will be over here. So that is my mirror image about y equal to x line. So I hope this is clear. I'll erase this part. Okay, once you do that, you'll get this curve, and your domain is what in this case? Domain is going to be -1 to 1. And what is your range? Range will be what, dear? It'll be 0 to pi. Of course, you should know that for any inverse trigonometric function, output, the outcome, the result out of the given function will always be an angle. Will always be an angle. Okay, this is clear, right? Cos inverse of x, this is y equal to cos inverse of x. This is y equal to cos x. Okay, clear? Simple things, okay, not difficult, very, very simple things. Alright, next, the most important one as well, and we're going to discuss only till this part, tan inverse, because that's what is relevant for our syllabus. That is going to be good enough. Okay, what is this curve? Y equal to tan x. This curve is y equal to tan x. Domain is what in this case? Domain is, please check here, -1 to 1, right? Domain is going to be all infinity. Sorry. Domain is a tan x, no? My bad, guys. Domain is here minus, excuse me, some mistake is there in this. Yes, the mistake is this is the mistake. Good that I saw it. The values are mistake actually, sir. This is a mistake. Okay, this is not required. This is wrong. Let me strike it out for you and I'll write the correct ones. Okay, this over here is -π/2. This here is π/2. Okay, and this is going to be what? Till infinity, so plus infinity, and this here is minus infinity. Okay, so this, the number which is written now, it was wrong actually. I made the change, no problem. So now what we have, what is the domain? Here you check, -π/2 to π/2, open, because if you check it, π/2 will become infinity, plus infinity. Over here it is negative infinity, so we can't keep it open, we can't keep it closed actually. What is the range? Range is all real, na? From minus to plus infinity, from minus to plus infinity. What about in the case of tan inverse? Check here. So this is going to what? The domain becomes what? All real, because this is going to be negative infinity, this is going to be plus infinity. It is moving on till plus infinity, right? X is all real. What about range? The range becomes -π/2 to π/2, open. Clear? Both are clear. Now there comes your table of all. First we already discussed, for cot inverse we have domain all real and range is 0 to pi. For cosec inverse we have more than 1 or less than -1, and this is again -π/2 to π/2, the except for 0, because sin 0 is 0, so reciprocal will be undefined. Sin 0 is 0, sir, so reciprocal cannot be defined, that's why it is like that. Okay, here again we have for sec inverse less than -1 or more than -1, and for range what we have 0 to pi, except for pi/2, because cos pi/2 is 0, so it becomes basically what? Sec will be undefined. So this is your table for domain and range. Now I have to start solving your questions. Clear, na? Now sir, properties you forget. I do not forget the property. I can write it over here if you want me to. So sin inverse, I'll write it with the help of questions, but it's okay, I'm gonna write it over here also. This is minus sin inverse of x. Okay, we have tan inverse, also same property, minus tan inverse of x. For cos inverse is different, pi minus cos inverse of x. Okay, and for tan, so sin is there, no? Cosec will follow the same as sin inverse. Cosec will follow the same as sin inverse, and cot will also follow the same. The cot will go with this actually, because cot has, excuse me, yeah. So cot, no, here I'm not able to get the marker. Okay, where is it? It's here, no? Where is it? 1 second, sir. Yeah, it's here. Just a second, sorry. So cot will follow this rule, no? Cot will follow this one, and even the sec inverse will follow this one only. These two will follow the cos inverse, because they have both cos in it. That's why we're gonna go with this one. Clear? So the negative will become as negative only for cos inverse, means we can take the minus sign out for these two. Okay, odd functions. Okay, sine, cosec and tan inverse is odd function, others we can't say. All right, sir, so this is clear. This is clear. Now we'll move on to, we have one more property, sorry, this is very, very important. Sine inverse of x plus cos inverse of x is going to be what? Always pi/2. Always pi/2. Same goes in the case of tan and cot also. Tan and cot also, same thing. Same goes over here. But again, you have all the properties and formulas listed in your NCERT summary. Do go ahead and check it out. Okay, but I'm going to give you a formula sheet very soon. If you want me to, I'll give you a formula sheet very, very soon. Let's start solving the question number 1. Principal value branch of cot inverse of x. Principal value branch of cot inverse of x. Clear? Simple? Okay. Again, for this one, check the property wala question. Minus cosec inverse of root 2. So I get minus pi by 4. Option A. Third one. The value of tan inverse of this is basically what you call expression. We are going to solve it. What's going to get? Solve it from here. Pi by 4. Here we'll get what? Pi minus cos inverse of 1 by 2. And we have over here minus sin inverse of 1 by 2, no? It'll become pi by 6, I guess. Right? Correct, no? It'll become pi by 6. Sin inverse of minus 1 by 2 will become minus sin inverse of 1 by 2. So it becomes pi by 6. Okay, sir. Pi by 4 plus pi minus this value. Pi by 3 minus pi by 6. Okay. Minus pi by 6. Let's take LCM now. LCM is going to be 12 only, right? 4 3s are. So 3 pi. Plus 12 pi, 3 4s are. So what we have? Minus 4 pi, minus 6 into 2, 2 pi. What is the difference? Check here. 15 minus 6, so 9 pi by 12, which is nothing but 3 pi by 4. Option B is correct. Option B is the right choice. If you're not getting it, do one thing. Do your own calculation. Okay, if you have a doubt, ask me in the comment section. Okay. Fourth one. Sine of pi by 3 minus sine inverse of minus 1 by 2. We can solve it again. Very simple. Check here. Sine pi by 3 as it is. Take formula of sine inverse into of minus value. It will become minus of minus. This will come out. So plus sine inverse of 1 by 2 is how much? Pi by 6. 30 plus 60. 30 plus 60 is 90. Sine 90 is 1. So option D. This is 30. This is 60. 90. Sine 90 is 1. Fifth one, question number 5. Value of tan inverse of 2 cos. Same approach. Okay. Check here. Check here. We'll keep tan inverse as it is. 2 is there. Cos is there. We have 2 sin inverse, right? So we're gonna get this as 2 as it is into pi by 6. 2 3s are. Cos pi by 3 is how much? So tan inverse will be as it is first of all. Cos of pi by 3. So cos 60. Again 1 by 2. 2 and 2 cancel. Tan inverse of 1 pi by 4. Option D. Option D. Okay. 3 more MCQs to go. 3 more MCQs. Let's solve them. Principal value of sine inverse of this. Okay. Sine inverse of, we're going to use quadrant rule over here. 3 pi by 5. So sine inverse of sine of pi minus 2 pi by 5. Correct, na? Pi minus 2 pi by 5. Check here, please. This will become same as 3 pi by 5. This angle is same as 3 pi by 5. Okay. Now this angle, this is pi. This angle is in which quadrant? Second quadrant. Pi minus some angle will be in second quadrant. Second quadrant, sine is positive or negative? Sine is positive in second quadrant. So I'll get what? Sine inverse at pi will be sine only 2 pi by 5 and will be positive because of second quadrant. Quadrant rule you know, right? Okay. Apply these two. You'll have the answer as 2 pi by 5. What is the answer? 2 pi by 5. Option C is correct. Option C is correct. Clear? Okay. 7th. Value of cot inverse of 1 upon root of x square minus 1. Now from here onwards you have to use some substitutions because we have cot inverse outside. To solve it I need to get what? Cot inside. Check. Take x as sec theta. So you'll have x square minus 1 as sec square theta minus 1. So you'll have this as tan square theta. How come, sir? The first identities that we have learned in grade 10. Sec square minus 1 is tan square. Apply root to this. What's the answer? Tan theta. Answer is tan theta. Okay. Because we are looking only for positive values or more than 1. Okay. Check here. Cot inverse of 1 upon tan theta will become cot inverse of 1 by tan cot theta. Answer is theta. X is sec theta means theta is sec inverse of x. Option C. Option C. Clear? Done? No problem. Last MCQ. Cos inverse of 4x cube minus 3x equals 3 cos inverse of x. Hold good for what? Just check here, just for contradiction. Check what you're going to put x value to solve this equation. You're going to put x as cos theta. Then no problem. Then no problem. Okay. Check here. What is do we have? 3 theta. And this will lie between where to where? Of course, 0 to pi. Of course, 0 to pi. Correct? No? It lie from 0 to pi. Move on this side. What are you going to get? You'll get this as 0 theta pi by 3. Take cos on both sides. So cos 0, cos theta, excuse me, cos theta and cos pi by 3. Cos is a decreasing function. What will happen? Inequality will reverse. Does less than equal to becomes greater than equal to. Here also same thing. Cos 0 is 1, cos theta is x. 1 by 2. Answer is 1 by 2, comma 1, both closed. Option B. Option B. 8th is option B. Please check. Clear? Clear, right? This is no problem. Moving on to your 2 marker now. First 8 questions. I hope there is no doubt. If you have, what are you going to do? Ask in the comment section. 2 marker now. Question number 9. Write the following function in the simplest form. Simplify this. This is a substitution method. A equals to, we're going to take what? I have tan inverse over here. I need to get tan inside. So x equals to, x equals to, right? X equals to a sin theta. So x by a equals to sin theta. So theta equals to sin inverse of x by a. Why did I find this? Because of course, so the question is given in the form of variable x, sir. We have to write the answer in terms of variable x only. So I got x as a sin theta, but I have to find the value of theta also, sin inverse of x by a, just to use it later. No problem, right? Okay. Solve it from here. You'll get tan inverse. X is nothing but a sin theta. And inside you check. A square minus a square sin square theta. Okay. Take a square common. It will become 1 minus sin square theta. A square into cos square theta. Apply root, please. Answer is a cos theta. What's the answer? A cos theta. Life easy now? Yes, sir. Tan inverse of sin by cos. Tan theta. What's the answer, sir? Theta. What is theta, sir? Sin inverse of x by a. Sin inverse of x by a from here. That's my answer. Clear? This is a simplified answer for this one. Okay? Why is it important? Plays a big role in the questions of derivatives, integration, and so on. Question number 10. This is clear. Question number 10. Find the values of each of the following. How do you solve it? Okay, not each of the following. Find the values of the following actually. It had multiple options, but they were very similar. I've taken some of them as homework. That's why I took only one of this question. It's a PYQ, that's why. Okay. Find the value of the following. Okay, let's go like this. Tan inverse. I think I solved this question already. 2 into cos. I think I solved this question. 2 into pi by 6. Yes, no, I think I solved it. It was coming as pi by 4. Please check, guys. Same was the PYQ over here. Yeah, here. It was pi by 4. Check. Same question has been asked for. If there was 2 options over here, no? So also the same question. This is also if you solve it. No, please solve it. Solve this one and verify this. Answer will come as pi by 4 only. Cos pi by 3 will be 1 by 2. 2 cancels. Tan inverse of 1 is pi by 4. Did I go too fast about this? No, right? Let's solve these 2 questions. Simplest form. So let's go with the first one. Tan inverse of cos x upon 1 minus sin x. So tan inverse of, let me do one thing. Just write this part. Cos x upon 1 minus sin x. cos square x by 2 minus sin square x by 2 by 1 minus sin x, no? So we have cos square x by 2 plus sin square x by 2 minus 2 sin x by 2 into cos x by 2. Clear, na? How come, sir? How come, sir? Okay. How come? Let me show you. 1, because of this, sin square plus cos square is 1. Sin x formula is 2 sin x by 2 and cos x by 2. 2 sin x by 2 and cos x by 2. Okay. Not visible? I'll write it again. No problem. Check this out. This expansion. Cos x by 2 minus sin x by 2 into cos x by 2 plus sin x by 2 divided by, check here, a square b square minus 2ab. So cos x by 2 minus sin x by 2 the whole square. To the whole square. This will cancel. One of them over here. Now you check. This whole thing has become actually, what is this? This whole thing has become cos x by 2 minus, plus sin x by 2 upon cos x by 2 minus sin x by 2. Divide by cos on both sides. You will get both up and down. 1 plus tan x by 2, 1 minus tan x by 2. Do you know the formula of this? Yes. This is nothing but tan of pi by 4 plus x by 2. How come, sir? Tan a plus b. Tan a, tan pi by 4 is 1. Tan of a plus b. A is pi by 4. Tan pi by 4 is 1. Tan x by 2 plus, that is in plus, in the denominator we have tan of pi by 4 will come later. We still have 1 minus tan pi by 4 will be 1. So 1 minus 1 into tan of x by 2. So this is the formula. You should know all this formula, but still, okay? Giving you an explanation. Got it? Now the last step. We got this for this thing. Put back in the equation. Tan inverse of this particular value, tan of pi by 4 plus x by 2. What's the answer? Pi by 4 plus x by 2. This question has been asked in the CND also. Okay? Alright? Okay, sir. Next what? Cot inverse of 1 upon x square minus 1. Do one thing, solve it over here. X equals to, if you take cot inverse is there, na? Take x equals to sec theta. You'll get the answer. Apply this. This is your hint, okay? I solve it right now for you, but this is your hint. PYQ. X as sec theta. 12th one. Find the value of each of the following. Let's solve it. Very simple. Check here. Take x as tan alpha. Here you're gonna take y as tan beta. Okay, tan beta. Check over here. You're gonna get what? I'll just write on this side. Sin inverse of sin 2 alpha plus cos inverse of cos 2 beta. Because this is the formula of sin 2a and cos 2a. What is this? 2 tan a upon 1 minus tan square. 1 plus tan square is, what is it? Tan 2a. This formula, 2 tan theta upon 1 plus tan square theta is what? Sin 2 theta. And what is this? 1 minus tan square theta upon 1 plus tan square theta is what? Cos 2 theta. I've used that only over here. Okay? Now check. So basically I'm getting this over here as 2 alpha, here as 2 beta. Take 2 common, alpha plus beta. Now bring back this value. What do we have? 1 by 2 outside. What do we have? 1 by 2 outside with tan. So 2 and 2 goes out. 2 and 2 goes out. Now what I have left? Simply tan alpha. What is alpha? If x is tan alpha means alpha is tan inverse of x. Tan inverse of x. What about this? Y. I have tan outside. I cannot apply right now, but if I can get them as same, if I can make them one value of tan inverse, then I'll get the answer. Okay? Right here tan, and check this out. Tan inverse plus tan inverse. This becomes tan inverse of x plus y upon 1 minus xy. How, sir? It's an identity, okay? Do check it out. Apply this tan to tan inverse. Answer is going as x plus y upon 1 minus xy. This is my final result, okay? My final result is right over here. Done? Okay. 12th one is clear. Next. Last type is 3 marker. So first 8 questions, next 4, so 12. Now next is 5 questions. Okay. Solve the equation tan inverse 1 minus x upon 1 plus x. This is very simple, right? This will become what? Tan inverse of 1 minus tan inverse of x equals to half of tan inverse of x. We just solved it right now. Please check. Same formula we use, no? Tan inverse of x plus y upon 1 minus xy we have. In this case we have 1 minus x. Same thing. Okay? This is the formula of tan inverse of 1 minus tan inverse of x. This whole thing, the LHS side. So this will become what? Pi by 4, 1 by 2 plus 1. Take tan inverse of x common. Correct, now? Right, now we have this 1 over here. This is 1 by 2. Will become 3 by 2. Check now. Pi by 4, 3 by 2 tan inverse of x. 2 2s are 4, 3, sorry, not cancel, it'll come down actually. So we have the answer over here, pi by 6 equal to tan inverse of x. So x is tan pi by 6. Tan 30 means x is 1 upon root 3. What did they ask? They asked us to solve it. We got it done. X value is coming as 1 by root 3. Okay, question number 14 now. Look, the thing is, sometime for some students this confuses to the questions of ITF confuses, but if you know the identities, if you ask me, sir, why ITF is difficult, I'll say, bacha, you don't know the formulas of trigonometric function. If you actually do the formula, if you actually do know the formula of trigonometric function, then this is very, very easy. Can you see how fast we can solve the questions? This is clear. Moving on. Write the simplest form of this. Divide by cos. Tan inverse of 1 minus sine by cos, na? Sin x by cos x upon 1 plus sin x by cos x. What I get? Tan inverse of 1 minus tan x. I hope nobody has doubt about this step, right? The first step. Why can we divide by cos? Because we can do the same operation on both numerator and the denominator. So I divided by cos to make it tan and 1. Now you check the formula. Again, same thing, sir. Yes, it is the same thing. Tan inverse of, what is it? Tan of 1, sorry, pi by 4, na? Minus x. Tan of pi by 4 minus x. So what I get for this? Pi by 4 minus x is my answer. 3 mark question. Okay, done, easy. Next one. Prove that cos inverse of 4 by 5, cos inverse of 12 by 13 is equal to cos inverse of 33 by 65. Okay, take this as value A, this as value B. We'll solve this one later. So why is the value A, B? Cos inverse output is an angle. I've taken the angle as A and B. I can do that. Okay, sir. Now try this triangle. If this is my angle A, sir, then what is they've given? They've given that, sir, that cos of A is 4 by 5. So this is, sir, 4. This is 5. Now we all know by Pythagorean triplet, this will be 3. 3, 4, 5 is what? It's a Pythagorean triplet. To make this triangle work, the ratio has to be 3, 4 and 5. Okay? Alright, sir. Cos A is 4 by 5. Okay. Can I make another triangle over here? Yeah. Again, this is angle B. Over here what we have? 12 and 13. 12 and 13. So, of course, this has to be what? 5 only, no? 144 plus 25. 144 plus 25 is how much? 169, which is 13 square. What they have given? Cos beta. Cos beta or cos B is 12 by 13. Check here, please. Clear? Now, take LHS. What have they given in LHS, sir? They have given A plus B. No sir, they did not give. Yes, they have. I've assumed the angle to be A and B, so they have given A plus B only, no? This is the angle, this is the angle. I've taken as A and B, this is A plus B. Problem? No. Now apply cos on this side. Cos of A plus B. Why sir? Why can I do that? I can apply any formula, right? I can apply any formula. Okay sir, if you say so. Apply cos of A plus B. So this is cos A, cos B minus sin A, sin B. Sir, we don't know sin A, sin B. We don't. Check from here, sin A. 3 by 5, sin B. 5 by 13. Opposite by hypotenuse, 5 by 13 and 3 by 5. Use it over here. So we get this as 4 by 5 into 12 by 13 minus 3 by 5 into 5 by 13. Check here. 48 minus 15 by 65. 48 minus 15 by 65. Difference is what? 3 by 65. What is this, sir? This is nothing but, sir, cos of A plus B equal to 33 by 65. Take cos inverse on this side. Sir, A plus B is equal to cos inverse of 33 by 65. I hope you're getting right. What I'm doing over here, basically I'm taking cos inverse on both sides. So this will become cos inverse of cos, cancel. This is going to be cos inverse of 33 by 65. Check here. A plus B was what? LHS. What is this? RHS, na? Proved? Yes, sir. Hence, proved. Done. As easy as it gets. Very, very simple. Just break down the problem step by step, and result is on the screen for all of you. Any problem, any doubt, let me know in the comment section. Okay? If you solve your homework, I'll discuss in the session. If you don't solve, I'll not discuss. Okay? Then it's waste of my energy. This is done? Okay. Prove that tan inverse of root of 1 plus x minus root of 1 minus x is going to be this. Difficult? No. Check here. 1 plus x. What is 1, sir? 1 is sine square x by 2 cos square x by 2. Okay. Sine square x by 2 cos square x by 2 is your this value. What is x, sir? Sine theta. Take x as sine theta. Take x as sine theta. So it will become, I'm taking this x as, excuse me, sine theta. So it will become what? Plus 2 sine theta by 2 into cos theta by 2. So again I'm getting here 1 plus x as cos theta by 2 plus sine theta by 2 the whole square. Check. A square b square 2ab. A plus b the whole square. Okay, sir. Take root. So then this is cancelled. Okay, sir. It means that root of 1 plus x is nothing but simply cos theta by 2 plus sine of theta by 2. Okay, sir. You did for 1 plus x. Let's do now for 1 minus x. Do we need to? Right here minus. Right here minus. Because this is nothing but 1. This whole thing is 1. The minus sign is over here. If this is minus means this will be minus, this will be minus. That easy. Now you check. So do we need to write this? You can write similarly 1 minus root of 1 minus x is cos theta minus sine theta. Don't have to write all the steps. Just I'm explaining this with the help of steps. Okay? You have to write similarly root of 1 minus x is cos theta minus sine theta by 2. Not writing all the 3 steps. Okay. Done, sir. Apply from here. Tan inverse of cos theta by 2 plus sine theta by 2 minus cos theta by 2 minus sine theta by 2. Close the bracket. Check here. Check here, please. This cos will cancel. Cos minus cos will be cancelled. What do we have left? Sir, why not denominator, sir? You'll see. Sine plus sine is what? 2 sine theta by 2. 2 sine theta by 2. You can take this as 1 plus x. If you take 1 plus x, no? If you take x as cos theta, that also can be solved. Okay. I think this way also works, but we'll see. Okay, I did not see the RHS side. We want here cos inverse, no? We want cos inverse here. Okay, sir. I'll try solving this way. It doesn't work, then basically what we have to do now, I have to take x as cos theta, then we can use different approach. For all of you who want to try this. 1 plus x is there, no? So take x as cos theta. It will become 1 plus cos theta. So what is this going to be? 2 cos square theta by 2. And for 1 minus cos, no, it will become 2 sin square theta by 2. Okay, so I have made a mistake over here. What I have made a mistake? That I did not see the right hand side part. I'll try to solve using this way also, it should work. But just telling you, if you want to, the faster way, the better way, the correct way, because I did not see the RHS side, I went with this method. But what you can try is simply take x value as cos theta. I have taken x as sin theta. Remember, check here please. I have taken x as sin theta. I am asking you to do the what? Take x as cos theta. This is the faster and better way. But since I have taken this step already, I'll try to solve and simplify from this here also. Please check. So 1 plus cos here, this will become 1 plus cos, no? Because x is taken as cos, it will become 2 sin square theta, 2 cos square theta. So I'll have the answer as root 2 cos theta. Here I'll have root 2 cos theta. Here I'll have what? Root 2 sin theta. Okay, check. So I have 2 sin theta by 2. And over here, same way, I'll have here as 2 cos theta by 2. So I'm getting here what? 2 cos, 2 cos theta by 2. 2 cancels. Tan inverse of this will become what? Simply theta by 2. Simply theta by 2. Correct, no? Because sin by cos is tan. Tan inverse of tan will become theta by 2 only, no? What is this? This whole thing is nothing but tan theta by 2. Tan inverse is outside. It will become tan inverse of tan. So theta by 2 is the result. What is theta? Theta is nothing but, please check here. So if I write theta over here, it will become sin inverse of x. Sin inverse of x. Sin inverse of x by 2. X by 2. But I want the answer in terms of pi by 4 minus cos inverse of x. I can get that. Wait a second. So if I take this as some angle, let's say alpha, okay. If I take this some angle alpha, okay. If I have over here alpha, then I have what? I have sin inverse sine of okay, no. 1 second. Theta by 2 is, excuse me guys, I'm just thinking what way we can get the same answer. We can apply the complementary ratio and get the same answer. Theta by 2, if I take directly from here, it will become what? It will become sin inverse of x by 2. Okay, that is correct. X by 2, this is correct. If I take this as, let's say, some angle alpha. If I'm taking this theta by 2 as some angle alpha, I'm trying to reach from here to this part. So 1 by 2 is equals to sin inverse of x. Bring here alpha, it will become 2 alpha equals to sin inverse of x. Bring back over here, you'll get sin of 2 alpha equals to x. Okay, so we can write this as cos, check here, cos of pi by 2 minus 2 alpha, no? Yes, equals to pi by 2 plus alpha. Will it work? No, minus only will work as x. Now I think it should work. Is it working? If I do it like this, it will be sin 2 alpha only. Cos of pi 90 minus 2 alpha is sin 2 alpha. And over here what I have this as, I'll get something. Let me solve it from here. So I'm getting here cos, I'm getting this as pi by 2 minus 2 alpha. Excuse me, I'm lost over here a little bit. 1 second. Pi by 2 minus 2 alpha equals to cos inverse of x. So I've got at least cos inverse. Yeah, cos inverse of x. Now if I bring on this side, I'll get pi by 2 minus cos inverse of x equals to 2 alpha. Right now, equals to 2 alpha. Check here. So I have, yes, I've got the answer. Now I'm getting I need the value of alpha only, no? So this will come over here. So pi by 4 minus 1 by 2 cos inverse of x equals to alpha. What was alpha over here? Alpha was sin inverse of x by 2. Alpha was sin inverse of x by 2. Okay, and what was this value? This was the value of this answer. So yes, I use a different method which is more lengthier. You should not follow it. Please don't mind because I did not see the RHS side. I went a little faster on that side. So use this method, take x as cos theta, 1 plus cos will give me 2 cos square, 1 minus cos will give me 2 sin square. Then you're going to directly get what? Root 2 cos minus root 2 sin. Please check here. You'll get this as root 2 cos theta minus root 2 sin theta upon same thing, root 2 cos theta plus root 2 sin theta. Root 2 all cancelled. So now you divide by cos, it will become 1 minus tan theta upon 1 plus tan theta. Okay, now you all know this will become what? Tan of pi by 4 minus theta. Now apply tan inverse on this. Check outside is tan inverse. So answer will become what? Pi by 4 minus theta. What is theta value? If you have taken x as cos theta, theta value is cos inverse. So you'll get here pi by 4 minus cos inverse of x. This is theta by 2, no? Sorry. By 2 everywhere. Here also 2. Here also 2. Here also 2. This will become what? Theta by 2. So answer is cos inverse of x by 2. Pi by 4 minus cos inverse of x by 2. Clear? Okay. So this is the method number 2, which is the faster method. Use this method. What I've done, taking x as cos theta and applying like this. 1 plus cos is 2 cos square, 1 minus x is 2 sin square. Forgive me for taking two methods and taking it longer, but yeah, I didn't want to say that this is also wrong approach. This is the correct approach. We got it. We got the result of this whole thing as 1 by 2 sin inverse of x, and I have taken this as alpha and proved that this alpha is actually, if you change from here, is coming as what is it? Pi by 4 minus 1 by 2 cos inverse of x. Please check. Same as this one. Yes? Clear, right? Both of these are clear. Okay? 16th is good question. I use the wrong method, but very easy question. Very, very easy question. Okay? So use the right method. This is the correct method. Correct method. Okay. Okay. Now question number 17. Let me solve it. I have not taken the space because I have used two methods. I have to solve it over here only. 2 tan inverse of cos x. 2 tan inverse of cos x. And what do we have? 1 second. The last question, just give me 1 minute. Tan inverse of 2 cosec x. Tan inverse of 2 cosec x. Okay, we have to solve this only, right? Yeah. So the problem is what over here? The problem is that we are having 2 tan inverse. Otherwise we can cancel, right? The formula of this is there, no? Tan inverse of 2 cos x upon 1 minus cos square x, no? 1 minus cos square x. That's the formula. How come, sir? The formula is there. Please, you have to remember the formulas. Yeah. So 1 minus cos square x. This is the formula of 2 tan theta. So if you have 2 tan inverse, no, that is the formula. Tan inverse of 2 cos x upon 1 minus cos square x. This is nothing but here also tan inverse of 2 cosec x. Tan inverse is here and here. We can apply tan on both sides. Tan inverse will go away. Now we have left what? 2 cos x upon 1 minus cos square is going to be sin square, no? And here we'll have what is this going to be? Tan inverse of 2 cosec x only. 2 cosec x only. So I'm getting this 2 and 2 cancelled. What I have, check this out. So I'm getting this value as let's cross multiply. I'll get 1 by sin. So I'll get sin x cos x equals to sin square x. Right over here, I'll get sin x common. Cos x minus sin x will be 0. Correct, no? If I take sin square over here, it will become minus sin square. Now I take sin common, cos minus sin will be left. Check here. From here I'm getting sin x as 0. From here I'm getting cos x equals to sin x. Cos x equals to sin x. Sin x 0 means from here I have to get x value is 0 or multiples of pi. X value is 0 or multiples of pi. But if you take x as 0, cosec will become undefined. So this is not possible. This here is not possible because if you take x as 0, cosec of x is undefined. Okay, so we have to use something over here. What is that given? Cos x equals to sin x. From here what I get? Tan x divided by cos. Tan x equals to 1. X has to be what? n pi plus pi by 4, no? Basically multiples of pi by 4. So I'll get this answer. If I'm looking for a principal value, I'll get this as pi by 4 only. This will be pi by 4 only. The first value, the principal value will be, this is the principal value. Principal value will be pi by 4. But if you want a general answer, n pi plus pi by 4. Done? Check here. Sorry, plus minus, no? Both are true. Yeah. So this is the part 1 answer. The 17 part 1 answer. Let me go to the part 2 now. Part 2 is here. Check this out. Part 2. Sin inverse of 1 minus x. Okay. Sin inverse of 1 minus x plus, minus or plus? Minus 2 sin inverse of x equals to pi by 2. We have to prove. Equal to pi by 2. Okay, sir. Move on this side. It will become what? Pi by 2 plus 2 sin inverse of x. Pi by 2 plus 2 sin inverse of x. Now take sin on both sides. It will become 1 minus x, and over here you'll have sin of pi by 2 plus 2 sin inverse of x. 1 minus x as it is. Over here what I get? Sin of 90 plus some angle. Sin of 90 plus some angle. How come angle, sir? Sin inverse is some angle into 2 will be some angle only. So the sin of 90 plus some angle, second quadrant, positive only. So it will become cos. Excuse me. Something is wrong. Pi by 2 only. Correct, na? Pi by 2 plus. Okay, apply sin, it will become cos only. Yes. Cos of 2 sin inverse of x. Cos of 2 sin inverse of x. Okay. So far so good. Alright. So cos of 2 sin inverse of x we have, but we use the cos part. Okay. You have to change this now to sin inverse of x. Okay. So what we have now? 1 minus x equals to, what do we have? 1 minus x equals to sine of this. So cos of 2 sin inverse of x. Cos of some angle. Cos of twice of some angle. 1 minus 2 sin inverse of, correct, no? Cos of 2 sin inverse of x. So 1 minus 2 sin of sin inverse of x. Yes, sorry. Yeah. Sin square of sin inverse of x. Right? That's the formula, no? Cos 2 theta will be 1 minus 2 sin square theta. So what we have answer as 1 minus 2. Sin of sin inverse is simply x square of that, so 2x square. And we have 1 minus x over here. 1 and 1 cancel. Bring on this side. We get here 2x square minus x. Take here from this x common. I'll get x into 2x minus 1 equal to 0. So gives me value of x as either 0 or 1 by 2. X is as 0 or 1 by 2. Okay. Now if you check over here, which is satisfying, if I put here 0, it will become sin inverse of 1. It will become minus sin inverse of 1. Yeah, that is correct. If I put x as 0, it is satisfying, no? This will be what? Sin inverse of 1 minus 2 sin inverse of 0. This is going to be 0 only, right? And this will be what? Pi by 2. Sin inverse of 1 is what? Sin inverse of 1 is going to be pi by 2 only. So this is satisfying. Let's check 1 by 2 now. So for 1 by 2 if I take, I'll get sin inverse of 1 minus 1 by 2 is how much? 1 by 2. And we get minus 2 sin inverse of 1 by 2. So I get here, this is same thing, no? So minus, it's coming as negative value. Minus 1 sin inverse of 1 by 2. Basically this is coming as, 1 second. I can write it better. Yeah. So sin inverse of 1 by 2. This is coming as basically minus pi by 6. Is not equal to pi by 2. So if you check the two values that we got, 0 and 1 by 2, this is not working. This right here is not working. This is the correct one. So answer is what? For this part, answer is x equal to 0. And for this part, answer was what? For the first part, answer was pi by 4. Please check. Clear? No, both parts are clear. This is 17th. This is answer for question number 16. Question number 16th answer. Please check, guys. No confusion, right? 16th answer, 17th answer on the next page. This is on the next page. Next page. Over here. Please check both of these. I know a little bit messy, but why did I continue with this step? No, because usually what happens as a student, we do get stuck. We do get stuck in the question, and because we chose a different way in the examination, our mind can work like that, right? You can make a mistake that I also made. But if you continue this way also, if you don't waste time, if you continue this way also, if it is possible, you'll get the right answer even from that method. So that also works out. For maths, there's no standard methods. You can apply your own learnings always. Okay, so this is done. 16th also done. 17th is here. This is 17 part 2. Little bit messy. I hope you have taken screenshots and copied it. 16th from here. Clear? 17th. This is again 16th only. 17th, and this is your homework. So today I've given you 4 questions. This. All of them are 3 marker. All of these are 3 marker. So this completes the chapter, inverse trigonometric function from the PU2 syllabus. Now if you ask me the most important topics, first of all it has to be MCQs, very relevant. Then comes your domain and range and graph of ITF and formulas of trigonometric identities from the PU1. We have first thing, as I said, we'll see the weightage, we'll see the blueprint. How does it work out for the chapter matrices? So we have total of 3 questions. We have total of 3 questions. Please check. Total of 3 questions are there of the categories 1 mark, 3 mark and 5 mark. So there will be 1 question from 1 marker, 1 question from 3 marker and 1 question from the 5 marker category. If you club them together, it becomes total of 9 marks. So the questions that I've taken in our content, check here, in the content here are of the same category. So I've taken the first 10 questions on the MCQs. Now this right here also consists of your PYQs. So I've taken today PYQs alongside your question bank problems. Okay, so there'll be a PYQ based question and MCQs in all of that. And so first 10 questions are MCQs, next 5 are your 3 marker, and the last 4 is your 5 marker from the chapter matrices. Okay, this works out great. Now check it out here. What is the next thing? Next thing is your, I'm gonna give you homework also today. So I'm still waiting to see how many of you have solved the answer. Do let me know if you're getting the answers or not. You can find the answers at various platforms available, but do attempt it because the questions that I give are very important. Okay, so for the homework problem, to see the practice where you are, whether you know the concepts or not, you can ask the doubts only if you practice by your side. Okay, so that for that reason I'm giving you homework, so do solve it. Let's start the first section, which is MCQs, the 1 marker category. The 1 marker category. In that, the question number 1, MCQ from the March 2023 paper. If a matrix has 18 elements, the number of matrices having all possible orders. 18 elements, so it can be what? 2 cross 9. Correct, now? It can be 9 cross 2 also, means 2 rows 9 column, 9 rows 2 columns. We can also have 1 row 18 columns and 18 row 1 column. You can also have 3 rows 6 columns and 6 rows 3 columns. Any other possibility? Check here. Any other possibility? No sir. So total options are 6 orders. 1, 2, 3, 4, 5, 6. Answer is total of 6 orders are possible. So B. Total of 6 orders are possible for B. Okay. Next what we have, if A equals to cos alpha minus sin alpha cos alpha is there. We're looking for A plus A dash to be I. Then what is the value of alpha? This is the property. We all know this very well. Let's in this case solve it. So this is your A, right? Let's write A transpose. So this will remain as it is, cos alpha. This will be also as it is, cos alpha. This will come over here. So minus sin alpha. This will go over there. So plus sin alpha. Now if you add them as A plus A dash or transpose, you'll have cos plus cos as 2 cos alpha. This will be 0, again 0, and 2 cos alpha. This is equals to what? They're saying this is equal to I. It means it has to be 1, 0, 0, 1. Compare, you'll get what? 2 cos alpha is 1. It means cos alpha is 1 by 2. This happens only if it is at pi by 3 for principal value. Answer is option D. Answer is option D. Fair enough. Okay, next is question number 3. If a matrix has 13 elements, then the total number of possible matrices of the different order, 13 elements, right? So elements are 13, we can have only two combinations, 1 cross 13 or 13 cross 1. It's a prime number, right? We have only two factors possible, 1 cross 13 and 13 cross 1. So 1 row 13 column, 13 row 1 column. Answer is two combinations possible, B. Also a PYQ. Also a PYQ. Okay, now this is from your question bank. If A and B are matrices of order m cross n and n cross n, so A is given with the order m cross n and B is given with the order n cross n, then which of the following is possible? So I can multiply AB because this is number of column here, number of row, they are equal. They are equal means AB can be multiplied. What about B square? For any square matrix you can multiply to itself, so B square is also possible. What about A square? No. If it is not, what do you call? If it is not a square matrix, it is difficult to do it. Please check. M cross n, A is m cross n. So this and this is not equal. N here, m here, they are not equal. So A square is not possible. AB is possible. Okay, so AB B square option is D. AB B square option is D. Right here. D. Please check. Okay. Question 4, option is D. So this is question number 3, this is question number 4 from the question bank, which is nothing but question number 11 of your MCQ. Okay, question number 11 of your MCQs. Next, we'll move on to question number 5 now. The following scalar, okay, in the following scalar matrix is what? Scalar matrix we all know is a diagonal matrix, so everything else will be 0 and this will be equal. Scalar matrix is a matrix with which is basically a diagonal matrix, so it has to be a square matrix with non-diagonal elements to be 0 and diagonal will be of the same element. Check here. No, no, here. Yes, C is correct. C is the right choice. C is the right choice, sir. So fifth one, answer is C. Very simple. Okay. Next, which one of the following is not true? This is true, right? Yeah, this is true. Matrix addition is true. Commutative. So A plus B or B plus A, they are the same thing in the addition. Also associative, you can take 3. So A, B plus C or A plus B plus C. Same thing. So it is also associative. Product is also actually associative. So you can write A into BC and AB into C. Both of them are true. The same commutative, this is not possible. AB is not always equals to BA. Only equal if it is inverse. This is only true if it is inverse. So only in this case it is possible, not always commutative, hence the answer is option C. Hence the answer is option C. Got it? Next. So I am trying to explain you the concept with the help of questions here, okay? So wherever we see the question, the kind of question they've been asking us in the PYQs or in the question bank, I'll discuss the concept of that part right here. Okay. If A is a symmetric as well as Q symmetric matrix, then what? Symmetric. The concept part here, A transpose is what? A. It represents your symmetric matrix. Now A transpose, when it becomes minus A, this is nothing but your skew symmetric matrix. Skew symmetric matrix. Now when you add them, okay, not add them, right? Okay, they are talking about the nature of this. So they are both A transpose. They are both A transpose. It means if this is equal, this also has to be equal. So I get A equals to minus A. On this side we get 2A equals to 0. So A equals to 0. So A is a null matrix. A is a null matrix. B. Seventh answer is B. Fair enough. Clear. Okay, next. Eighth one. If ABCD is a skew symmetric matrix, then A plus B plus C plus D is what? Okay. They're saying the skew symmetric matrix. So one thing is very clear about skew symmetric matrix of order 2 cross 2, that the diagonal will be 0 actually. Diagonal element will be 0. How come, sir? Because as I said, A transpose, excuse me, you write like this: A12 equals to what? Minus of A21. If you add them, okay, it will become what? Twice of A12 equals to 0. Okay. Let me take a general form only over here. Why to write 1 2 or something? General form I'll take. Aij is equals to minus of Aji for skew symmetric matrix. Okay. So from here I get twice of. Okay, this is true. Not twice of. Twice will come over here. Now you check. So if I'm writing the case of these two elements, it will be either A11 or A22. A11 or A22. From here I get, so A11 equals to minus of A11. On this side it will become what? Twice of A11 is 0. So A11 is 0. The concept part is clear. Same goes for the A22 also. Same concept, A22 equals to minus of A22. From where, sir? From this definition of skew symmetric matrix, the elements condition, we get twice of A22 is 0. It means A22 is 0. That's why the diagonal elements are 0. I'm explaining you the concepts here. You can see this very clearly. Okay. Now, what next is there, sir? The other elements. So if it is, let's say, A, this is has to be minus A. Okay. This has to be minus A. I have already that A in the given matrix. I write this as x and minus x. Just to understand, this is x and minus x because that's how it is. 1 2 is x means A21 will be minus x. Now compare this with this. Compare this with this. This is the general form of a skew symmetric matrix. Compare it. So you get value of A as, value of A is 0, value of D is 0, value of B is what is it? X, and value of C is what? Minus x. If you add all of these, you'll get A plus B plus C plus D will be what? 0, x minus x plus 0. What is the answer? 0 only. Answer is option C. Getting it? This is the complete recall of the chapter, of the topic skew symmetric matrix from the chapter matrices. Very, very important. One question will come on this for sure in your board examination. Okay. Certainly it will come because you can see very, very important concept. Every time it repeats. Okay. Next. Statement based question. Very sometimes they're very easy actually, but students fear reading all the statement and they end up making mistake or skipping it also. So don't do that. Let's solve the question over here. Okay. If A is a symmetric as well as skew symmetric matrix, then A is a null matrix. We just this right now. If I have A transpose as A and A transpose as minus A also, both symmetric matrix and skew symmetric matrix, if both of them are true, then it has to be what? A null matrix. So statement number 1. Statement 1 is true. Now 2 you check. Same thing is given here. Symmetric is A transpose is A and skew symmetric is A transpose is minus A. They have given the definition as well. So it means both of these are true and 2 explains the statement 1 correctly. So 1 is true, 2 is true, 2 is the correct explanation of 1. So option is D. Right here. Very simple question. Next. 10th one. If a matrix is given like this, what is it? Aij is m cross n, match the column 1 with column 2. Square matrix. When it is m equal to n, so option A is third one. When m is equals to n, okay. Column matrix. Column matrix. When the number of column is 1, right? The number of column is 1. So n is 1. So this is going to be 2. And row matrix, when the number of row is 1. C is going to be this one. So 1. So answer is 3 to 1. 3 to 1 is the option number B, right? Option number B. Okay. Let's move on to the next section now. Now 3 marker. Okay. So let's solve it. First question, third 3 marker. Very simple. Again, I am keep telling you guys always, it is very, very important to know this concept of symmetric and skew symmetric. Question will come on this concept for sure. They can ask you in 3 mark also, they can ask you in 1 mark as well. Okay. For the matrix of A as 1 5 6 7, verify this. Okay. Let's find this A dash first. So we'll get here 1 7 as it is. This will become what? 6 and 5. Okay. I'm looking for A plus A dash. Check here. A plus A dash will be 2 14 and this will be minus, actually my mistake. This will be minus A minus A dash. No, this cannot be plus. This here is A minus A dash. Second option is A minus A dash. Please change that. Okay, so we get 2, we get this 11, 6 plus 5 is 11 and 6 plus 5 is again 11. You can see here this matrix is nothing but, if you take this as matrix X, no, you'll get what? X transpose will be simply X. So this is your nothing but symmetric matrix. So here this is nothing but A plus A dash is your symmetric. Okay, now next is what? Next is your skew symmetric. For that we have A minus A dash actually. So subtract these two. So we'll have A minus A dash as 1 minus 1 is 0, 5 minus 6 is minus 1, 6 minus 5 is 1, and 7 minus 7 is again 0. If you check carefully, this is nothing but your matrix X. Okay, so X, if you take as A, sorry, not X, in this case we'll take this as Y actually. Let's take this as Y in this case. So Y equals to, if I take A minus A dash, no, then Y transpose is nothing but simply minus Y. What is it? Minus Y. Therefore Y equal to A minus A dash is your skew symmetric form. Skew symmetric form. Simple question. Okay, next question number 12. If x plus y equals to 7025, x minus y is given like this, find the value of x and y. This is based upon comparison, addition and those concepts. Okay, basically operations on matrices. Add these two. If you do that, you'll get x plus x as 2x. Excuse me, you'll get this as x plus x as 2x. Y and y will become cancelled, so 0, and add the matrices. 7 plus 3 is 10, 0 plus 0 is 0, 2 plus 0 is 2, and 8. I'm looking for just x, right? So I'll have here 5, 0, 1, 4. 5, 0 and 1, 4 is your x value. Check here. Divide this by 2, no? 5, 1, 4. Okay. Now how do you find y? You can find y from here. So y will be, if you check from here, simply, okay, I can solve it from here actually. Y will be simply what? Your 7025 minus x. So 7025 minus, what is the value of x here? 5014. Subtract and tell me the value of y now. So y is nothing but, check, 7 minus 5 is 2, 2, 0, 1, 1, right? 2, 0, 7 minus 5 is 2, 0 and 1 and 1, correct. So this is the value of y and that's the value of x here. Okay, 3 marker, PYQ as well. So that's why I've taken PYQs over here alongside your question bank. What they expect, what they ask and what they expect at the same time. Discussed in the session of Brahmastra 2.2 of your chapter matrices. It's 9 marker, means okay, not a low weightage chapter but not very high weightage as well, and simple also. Matrices is very simple. When you go to determinant, then the challenge becomes a little bit more. Okay, in matrices only difficulty thing will be finding the multiplication of 3 cross 3. We'll deal with that. I have taken that question also over here. Okay, so if A and B are invertible matrices of the same order, prove that this condition is true. It's a very good question. Okay, very unique question. They're saying that prove it that AB inverse is equals to B inverse A inverse. Okay, I'm going to take the RHS first. I have B inverse A inverse. Okay, now in this B inverse A inverse, I'll multiply AB. Check it out. This is AB. I can multiply anything to anything, right? Yes, so AB. If you do that, what will happen? B and B inverse will become what? Simply I. If you multiply this, B and B inverse, we have a property, remember? X into X inverse is what, sir? I. Or X inverse into X is what, sir? Also I. Same approach. It will be I and we have A inverse left. Now we all know I can be ignored over here because they're all 3 matrices only of the same order. So this will become what? A inverse also becomes I. So your RHS is coming equal to I when you are actually multiplying AB to it. When you are multiplying AB to it. Super, sir. Check this out then. Now if you multiply AB to the LHS side, check. If you multiply AB to LHS side, you will get what? AB into AB inverse. Now you might think like this, sir, how will you expand this? How will you solve it? You don't have to. If I take AB as a matrix X, what is this? X inverse. And what is X into X inverse? Always I. So basically your RHS is coming as I, and also if you multiply the same thing, because you're multiplying same thing AB on both sides. Check here. You're multiplying same thing AB over here also and over here also. So basically in the equations given to us, I have multiplied the same result or same value on both the sides and getting the answer as I and I. It means if you multiply AB to this, if you multiply the same thing to both sides, you're getting the same result. It has to be what? They are equal in nature. So basically we are getting LHS equals to RHS, hence proved. Hence proved. Clear? Simple question. But yeah, you have to apply yourself to get the result. There's no mathematics like numbers involved in this particular problem. Okay, maths of course is there, but no numbers involved in this particular problem. Now multiplication question. Okay, from here onwards, the actual where the students struggle or make mistakes, those type of questions will start from here. Okay, A is given, B is given, we have to verify this. So product of AB transpose is same as B transpose A transpose. This is what? A property of a transpose. We'll start with the RHS. This is the property of transpose, right? AB transpose is B transpose A transpose. So we'll start with the RHS. Multiply AB 1 minus 4, excuse me, 1 minus 4, 3 minus 1, 2, 1. Check here. This is 3 cross 1, this is 1 cross 3. Matrix order you check. This is 3 cross 1 and this is 1 cross 3. Of course the answer will be what, sir? 3 cross 3. Any problem? 3 cross 1 and 1 cross 3 answer will be 3 cross 3 only. Check here. 1 into minus 1 is minus 1. 1 into 2 will be what? 2. 1 into 1 will be what? 1. What are you doing, sir? I'm multiplying a row to the column 1 by 1 to get a element. You multiply the first row to first column to get first element, first row to second column to get the second element, and first row to the third column to get third element. That's how you do the multiplication in matrices. Second row again. Minus 4 into minus 1 is plus 4. Minus 4 into 2 is minus 8. Minus 4 into 1 is again minus 4. 3 into minus 1 is minus 3. 3 into 2 is 6 and 3 into 1 is 3. This is my AB. Am I looking for AB? No, sir. I'm looking for AB transpose. I'm looking for AB transpose. Transpose it. Row will become column. So I'll have minus 1, 2, 1 over here. Minus 1, 2, 1 over here. And 4 minus 8 and minus 4 over here. And minus 3, 6 and 3 over here. Transpose is done. What I've done here, taken the row over here, made it column. Row here, made it column, and so on for all the 3 rows. Next step. Next step is to find the B dash A dash. Let's find B dash A dash now. Find B dash first. What is B dash here? Transpose of this. So we'll have here minus 1, 2, 1. This is B dash. And what is A dash, sir? This will be, sir, 1 minus 4 and 3. 1 minus 4 and 3 is your A dash, product of these two. So we're looking for B dash, A dash. Multiply in that order, minus 1, 2, 1 and 1 minus 4 and 3. Again, same thing you can see over here. Please observe, it is 3 cross 1, 1 cross 3. Very important to know. To multiply, the number of columns over here has to be same as number of rows over here. I'll repeat. To multiply, number of columns over here is same as number of rows in the second matrix. Okay, sir. Do the multiplication please now. What we have? B dash, A dash. Check. The elements right here. Minus 1 into 1. Minus 1 into minus 4. Minus 1 into 3. 2 into 1. 2 into minus 4. 2 into 3. 1 into 1. 1 into minus 4. And 1 into 3. Now this is your result of B dash A dash. Check carefully, this is equals to AB dash. Check here. Minus 1, 4, minus 3, 2, minus 8, 6 and so on. Therefore, sir, hence proved, verified, whatever you want to say. Verified. Please check. Simple or not? 3 marker. This is another 3 marker question. Okay, sir. Moving on. If A equals to 3 minus 2, 4 minus 2, 1, 0, 0, 1. So that K, find K so that A square K minus 2I. We have to find the K value given this equation is true. Given this equation is true, we have to find the K value. We can do that. Let's find A square first. How do you find A square? A into A. How do you find that? Check here. 3 minus 2, 4 minus 2, 3 minus 2, 4 minus 2. Multiply this. 3 into 3 is 9 and minus 2 into 4 is minus 8. This is my first element, okay? This is not 2 elements. I hope you get it. First row to first column will give me my first element. 3 into 3 is 9, minus 2 into 4 is minus 8. Why I am putting so much emphasis on this part? Because this is where the mistakes happen by students, okay? That's why. Okay, next what? Same, we go with second column now. 3 into minus 2 is minus 6, minus 2 into minus 2 is plus 4. Next, 4 into 3 is 12 and minus 2 into minus 4 is minus 8. 4 into minus 2 is minus 8, minus 2 into minus 2 is plus 4. So 1, minus 2, 4 and minus 4. 1, minus 2 and 4 and minus 4. This is your A square. Now what is the next part? Ka. Ka. K will be what? K into this 3K minus 2K, 4K and minus 2K. Now what is this next one? K minus 2I. So basically check here. 3K minus 2 minus 2K, 4K and we have minus 2K minus 2. Correct, no? Because 2I means what? What's the meaning of 2I? 2I is nothing but, sir, 2002. 2I is 2002. Subtract these two, you'll get this condition only. Now compare this with equals to A square. Compare here and here, okay? So what are you getting now? Check this out. 4K equals to 4. 4K equals to 4. K value is 1. Compare the corresponding element, you'll get the answer as K equal to 1. 15th question answer is 1. Next one. 5 marker now. So we have done now 3 markers. We have now moving to the 5 marker as well. So what is this we are doing right now? We are doing a complete revision of the chapter matrices alongside the concept for every type of question they're gonna expect us to answer in the board's examination. Okay. Now here it is. There are 3 cross 3 matrix, 2 given here, and there's a 3 cross 1 matrix. They're asking you to verify a property, which is what? A plus B multiplication C is equals to AC plus BC by finding AC, BC and A plus B C value. Okay. How do you find AC, sir? Check here. From here, first row and the column. 0 into 2 is 0, sir. 6 into minus 2 is minus 12, sir. 7 into 3 is 21, sir. Minus 12 plus 21 is, sir, 9. 9. This is 9. Please pay attention. I've done this just to avoid any calculation errors, okay? And save some time also while doing that. Check here. Minus 6 into 2 is minus 12. 0 into minus 2 is gone. 24. 8 into 3 is 24. 24 and minus 12 is what? 12. Minus 6 into 2 is minus 12. 8 into 3 is 24. Difference 12. Next. 7 into 2, 14. Minus 8 into minus 2, 16. 14 into, and 0 into 3 is gone. 14 first. Minus 2 and minus 8 will make 16. Sum 14 plus 16, 30. So AC is known. I hope all of you know how to multiply this. A to C, row to column, 1 by 1. Next, BC. Okay, sir. 0 into 2, 0. 1 into minus 2 is minus 2. And 1 into 3 is 3. Minus 2 plus 3 is 1. Is 1. Okay. I hope this is visible. Okay. Next one. Check here. 1 into 2 is 2, 0 is gone, and 2 into 3 is 6. 2 plus 6 is 8. 1 into 2 is 2, minus 4, 2 minus 4 is minus 2. Answer is minus 2. This is your BC. So AC is found, BC is found. What are they asking? Now next is to find A plus B into C. Let's find that. A plus B. Add these two. 0, 7, 8, minus 5, 0, 10, 8 minus 6 0 minus 6 and 0. This is my a plus b. Into c we have to do again, into c. So check here, we are going to multiply this over here with this particular condition, 2 minus 2 and 3. Check here. So I'll end up with 0 into 2, 0. 7 into minus 2 is minus 14 plus 24, that's 10. Check here, minus 14 and plus 24. Minus 14 and plus 24. Minus 14 and plus 24, answer is 10. Fair enough? Okay. First element is done, sir. Let's erase this. Next now. Minus 5 into 2, minus 10, 0 and 30. Minus 5 into 2 is minus 10 and 30. 20, sir. Next. 8 into 2 is 16, plus 16 again, and this is gone. 16 plus 16, because minus 6, 12, right? My bad. 2 is 16 and plus 6 into 2 is 12. 16 and 12. We get here what? 28. So answer is 28 over here. Okay. This is my a plus b into c. We found that we have to verify this condition now. Add these two, please. Add these two. This is my RHS now. If I'm adding it, this is my RHS. Check here. So my RHS will be what? 9 plus 1 is 10. 12 plus 8 is 20. And 30 minus 2 is what? 28. 30 minus 2 is 28. Over here, check. Same thing. This is equals to what? I'm getting a plus b into c is equals to ac plus bc. Verified, sir. Comes for 5 marks. It's a PYQ March 23 paper. Comes for 5 marks. Please check the most recent ones. 17th one now. Again we have, this is a summation question, very very simple. We have to compute a plus b, b minus c and so on. We'll check the result. Okay. Let's find a plus b first. We'll find a plus b first. Okay. So what we get for a plus b? Add these two. We get 1 plus 3 as 4, 1 and we have 5. Okay. We have 9. We have 9 and we have 2. We have 7. We have 3 minus 1 and 4. Let me cross check once. Okay, a plus b. 4, 1 and 5. Okay. 9, 2 and 7. Okay. 3 minus 1 and 4. Alright, sir. Doesn't look like 9. Let's just rewrite it. Okay. This is my a plus b. What is next one? They're asking to find us b minus c also. B minus c also. Okay. B minus c, what is going to be from here? 3 minus 4 is minus 1, minus 2 and 0. What is next one? 4 minus 0. 4. 2 minus 3. Minus 1. 5 minus 2. 3. 2 minus 1. 1. 0 minus 2. Minus 2 is going to be 2 and we have 0 over here. We have 0 over here, so b minus c. A plus b and b minus c. Found, sir. What's the next step? Find this result a plus b minus c. So let's start with LHS first. Let's start this a plus b minus c. Do we have b minus c over here? So add these two. Add these two. Check here. Minus 1 and 1. 0. Minus 2 and 2. 0. 3 and 0 is 3. 4 and 5 is 9. 0 and minus 1 is minus 1. 2 and 3 is 5. 1 and 1 is 2. Minus 1 and 2 is 1. And 1 and 0 is 1. This is my a plus b minus c. Next is going to be what? Next will be your RHS. RHS. What is that RHS? A plus b minus c. Let's find this out from here. A plus b is right here. Minus c. 4 minus 4. 0. 1 minus 1. 0. 5 minus 2. 3. Here. 9 minus 0. 9. 2 minus 3. Minus 1. 7 minus 2 is 5. And 3 minus 1 is 2. And we have minus 1 minus 2 will become minus 1 plus 2. So 1. We have 4 minus 3 also as 1. Now cross check. 0, 0, 3. 9 minus 1, 5. 2, 1, 1. they are both equal. So what we got? We got LHS is equal to RHS, hence verified. So they are so simple. I know they are simple, but I have not given this question. This is a PYQ. This is a PYQ, okay? So this is what they expect from this chapter. So you need to be ready and practicing this with very clarity so that you don't make mistake while doing simple calculation. You guys do silly mistakes in the examination? Of course you do. If you won't, you'll get very good marks every time, okay? If you try to actually reduce the silly mistakes that you make in a chapter or you make in a question, you'll certainly get much higher marks that you're getting right now. Mark my words, silly mistake is the giant that makes your marks go that reduces the marks very highly, okay? 17th is done. Check here. Question number 18 now. Question number 18 now. Another very beautiful question where you have to use the product and show the function as well, okay? So find f of x, f of y, and so it is equals to f of x plus y equals to f of x plus y. Okay, sir. F of x we already have. Let's find f of y directly. F of x we have, right? Let's find f of y. When you do that, what do you get? Check here. It'll be, sir, cos y. It'll be, sir, minus sin y. It'll be 0, 0, 1. Again we have here sin y, cos y, and we have 0, 0, 1. Okay, we have 0, 0, 1. Okay, so fy we have now, cos y minus sin y and everything. We want to multiply it now. Okay, fx into fy. Let's do it. Let us do it, sir. Fx into fy. Alright, no problem. If you multiply this, what are you gonna get? Check. So I'll not write it, I'll just write directly. I'll write directly. Row to column. Cos x cos y, cos x cos y, first term, minus sin x sin y, this is my second term. Okay, now last time you check, same way, 0 into 0 will be gone. Okay, 0 into 0 will be gone. This is my first element. I'll leave some more space, so I'm gonna write from here actually. 1 second guys, 1 second, sir. So we have fx fy. First what we had, cos x cos y, and we had minus sin x sin y, minus sin x sin y. Okay, now this is my first element. Okay, after doing first row to first column, same we're gonna do with second column also. So cos x sin y, cos x sin y. Okay, sir, minus cos x sin y, sir. Next, sir, minus sin x cos y. Okay, first row, second column, minus sin x and cos y, minus sin x and cos y. So, sir, minus sin x cos y, and the last term you check this to this, 0 into 0, 0, 0 into cos is 0, 0 into sin is 0, and 0 into 1 is 0. So this is 0, sir. Very important, very important. Okay, sir. Now what next? If you go with the second row now, sin x into sin y, sorry, sin x into cos y, cos x into sin y. Okay, right here, sin x sin y. Check here, sin x cos y. My bad, calculation mistake. This can happen, that's why you have to be careful. Okay, sin x cos y, and we have next what, cos x and sin y, cos x and sin y. Okay, super, sir. Next, second row, second column, second row, second column. So sin x sin y is with the minus sign, sin x sin y with the minus sign, and cos x with cos y with the plus sign, cos x cos y with the plus sign. And this last one is 0 into 0 is 0. Now take the last one, sin into 0 is 0, cos into 0 is 0, and 0 into 1 is 0. This is also coming as 0. So this is my matrix actually. Okay, this right here is my matrix. If you multiply, this also will come at 0. 0 into this is 0, 0 and 0. So this will actually be 0 into 0. Everything will be 0 and 0. Excuse me, sir. Yes, 0, and this will be 1 because we have 1 into 1 here, so this will be 1. I'll repeat, don't worry. I'll repeat, check here. So what we have, we got this after multiplying first row to first column, cos x cos y minus sin x sin y. Do you know the formula? You should know the formula. What is the formula? fx fy is equal to, sir, cos of x cos y minus sin of x sin y is nothing but cos of x plus y. Formula is there, cos of x plus y. Okay, now check this out. Check minus sign common. Minus sign common, it will become sine of x plus y actually, and this will be 0. This will be here, excuse me, okay, this will be 0, the last element, all right, the last element. Okay, next what? Same way, sin x cos y, cos x sin y will be sine of x plus y, and this will be what? Minus sin x sin y, cos x cos y will become cos of x plus y 0 1 0 0 0 1 0 0. Now what I'm getting over here, please check carefully. Fx into fy, fx into fy, what I get? I'm getting over here simply same function. Check the matrix over here, same function, just in place of x we have x plus y now, so we become what? F of x plus y now. So in place of x in the matrix, check here, it has become x plus y. Hence, if you start with the product, you're getting this result as the final matrix. Compare it with the original matrix, you'll get x becomes y over here, and that becomes x plus y over here. Hence, we have proved that fx into fy is coming equals to f of x plus y using the formula of cos of a plus b and sine of a plus b. Is it clear? Check this out. Clear, no? Yes. Okay. Now question number 19. This is very important one. Now what do we have over here? First thing, we have a matrix A and we're looking to prove this. This comes A cube. If it is A cube, usually it comes for 4 marks. This can also come for 4 marks, but this year they are expecting only 5 mark questions. So this can come for actually 5 marks. And this is where it will be difficult, it will be challenging, it will be calculative in nature. So you have to keep some patience over here. You have to. There's no other way around. You need to keep some patience over here. Check this out. A square. How do you find A square? A into A. A into A. 1 into 1 is 1. 2 into 2. 2 into 3 is 6. And 3 into 4 is 12. 12 plus 6 is 18 plus 1 is 19. 19. Same way. 1 into 2 is 2. 2 into minus 2 is minus 4 and 6. 6 minus 4 is 2. 2 plus 1 is, excuse me, I made a mistake, yeah. 2 is there, no, 6 minus 4 plus 2. So it'll become 2 actually. 6 minus 4 is, 6 plus 2 is 8, minus 4 is 4. So 4 here. Correct, no? Check here. 1 into 2 is 2, minus 4 and 6. 6 plus 2 is 8, minus 4 is 4. What are you doing, sir? No problem. Pause the video here and do the calculation. Please do the calculation. Okay. First row, last column. 3, 2, 3. 3, 2, 3. 6 plus 2, 8. Same way you'll get the result for A square matrix. Once you get A square, you will get A cube as A square into A. You will get A cube as A square into A. How do you solve it? This is A square and A is this one. A is over here, A square is over here, now multiply. 19 into 1 is 19. 4 into 3, 12. 19 plus 12 and 32. 2 plus 2 is 4 plus 9 is 13. Carry is 1. And 3 plus 1 is 4 plus 5 plus 1 is 6. 63. This is 63 right here. Next. Same way. 19 into 2, 38. 4 into minus 2, minus 8. And 8 into 2 is 16. So I get here 38 plus 8, 46. 16 and minus 8 is there, no? It will become plus 8. So 46 and so on. You get A cube also here. You get A cube also here. Likewise. Okay, if you solve it, you'll get A cube also. All the terms are written over here. Clearly, same approach, row to column. Once you get A cube, let's find 23A because they're asking us to find this equation equals to 0. We have to prove this. Okay, find A cube. 23A actually. A cube is done, find 23A. 23 into 1 is 23, into 2 is 46, 69, again 69, minus 46, plus 23, into 4 will be 92, and 46 and 23. Simple multiplications, nothing else. Table of 23. We don't know that, but we can multiply, right? Okay. Minus 40i. Minus 40i. So I is simply what? I is simply, what is it? 1 1 1 40 I means 40 40 40, rest all element is 0. Super. Now I'm looking for this equation. Let's take LHS now. What is LHS? A cube minus 23a minus 40i. Check here now the matrix. What is a cube? 63. 63 minus 23 will be 40, minus 40 will be, excuse me, will be 0 only. Yes, 63 minus 23 and 40 will be what? 0 only. Okay. And if you want, I can do a better approach to this. Yes, take AQ as it is and add these two, 23i and 23ia, and one second, excuse me guys, sorry, we have AQ, add this 23a plus 40i. Now you check AQ as it is, add these 63, 46, 69, 69 again. This is going to be minus 6, right? Yeah, minus 6, 23 here, 92 here, again 46 here, again 63, right? Yeah, check, are these two same or not? 63, 46, 69, 69 minus 6 and 23, they are two same. These two are same thing. It means I'm getting a cube minus a cube. Answer will directly come as 0. Answer will come as 0. Here it is. Answer will come as 0. That is nothing but your RHS. Your RHS. Have a look. This is your 5 marker. Question number 19 is also over now. Okay, so LHS is I've taken, got the result by adding these two, and answer is coming as 0, which is RHS. So now next time when you're solving this question on multiplication, do pay some attention. Don't be in rush to get the result. And I know it's very simple multiplications, right? But still you end up making mistakes in calculations or sign problem, whatever it is. Be careful. Do not lose easy 5 marks because of calculation error, which is silly mistakes. Okay, now the time of homework. One question on the product. Okay, again this is the property. This is the property here, and this also is the one that comes for 5 mark again, or 4 mark in the questions. A square minus 5a plus 6i. So 2 5-mark questions given for homework. Do attempt them. You have solutions available. If you want me to solve it, let me know in the comment section as well. Okay, so this completes your session today. In this session, I'll help you score 12 marks for the chapter Determinant in your PU2 boards. That's the weightage, and I'm here to help you with the different category of questions. Let's start seeing them one by one. The weightage that we have. Okay sir, the weightage that we have. Here it is. MCQ, 1 question will come for 1 mark. Short answer, 2 marker. 1 question, 2 mark. Long answer, 4 marker. 1 question, 4 mark. Long answer, 5 marker. 1 question, 5 marks. Add them. 5 plus 4 is 9, plus 1 is 10, plus 2 is 12. Your 12 mark is coming from the chapter Determinant, and they're very, very easy. You can score it. Believe me, trust me on that. Okay, let's start. Let's start the session now. The content index. Of course, the first thing first, I'll give you the homework. Sir, where are the questions? That will also come. But yeah, I will give you the homework. I'll tell you the most important topics. And here comes the questions. I've taken a total of 24 problems apart from homeworks. Okay. 5 marker, I've taken 2 questions because they are very similar in nature. Then we have 4 marker, 3 questions. We have 2 marker, 4 questions, and MCQs, total of 15 questions. Okay, so let's start solving because why I've taken 15 questions over here, because any other properties can be asked. Okay, so we need to cover all of these. MCQs, you have to practice more to get that 1 marks, but other category are very much predictable. Okay, let's start now. Let us start now. MCQs. Okay sir, MCQs. Minor. What is minor? Now don't worry about the concept. I'll tell you the concept with the help of questions only. So minors. Now what are minors? Minors, what happens is, for every element there will be an element that we write it as minor. So we have 3 symbols over here. For any square matrix, something called as Aij we have first. This is your element. Mij is your minor, and Cij or Aij is your adjoint. Element, minor, adjoint. Number of element will be same as number of minor, will be same as number of adjoint. Oh sorry, cofactors. This is your cofactor. Okay, sorry, these are cofactors, not adjoint. Cofactor, minor, and your element, they will always be same sir. If a square matrix has 9 elements, means the order is
3 cross 3, 9 elements, 9 minor, 9 cofactor. How do you find the minors? Very simple. Whichever element they're asking, across that element, remove the row and column. Whichever element they're asking, so 2, minus 4, 0 and 3. Remove that particular row and column where the element is contained. Row is cancelled, column is cancelled. This 3 is over here, no? Yes. Now, whatever is left out, find the determinant of that. So in this case of 2 cross 2 matrix, we have only one element left. But if it was 3 cross 3 matrix, you'll have a determinant left of 2 cross 2 order. Solve that, you'll get the minor. Is it clear? For a matrix of a 3 cross 3 order, if you remove the row and column, you'll have 4 elements left. Find the determinant of that. When you do that, that is your minor value. In this case, the minor will be what? 0. So answer is what? Option D. Is the concept of minor clear or not? Is the concept of minor clear or not? Yes, sir. For example, as I said, if you have 3 elements, okay, 3 cross 3 matrix, let's say 1, 7, 9, 4, 0, 8, 2, 1, 5. Okay, I want you to find across 9. So remove this row, this column, this you see over here. Find determinant of this. So 4 minus 0, answer is again 4. So minor of this element, minor of the element 9. What is this element called as? 1 first row, third column. So M13 will be given as 4. How come, sir? 4 into 1 minus 2 into 0. M13 is 4. Now what about C14 or A14? C14 is the cofactor. So C14 goes like this. Minus 1 power 1 plus, excuse me, C13 is there, no, there is no 14. C13, M13 and C13, okay. So minus 1 power 1 plus 3 and M13, minus 1 power 4 will be 1 only. 1 into M13 is how much? 4. This will be your cofactor. So basically the formula for your cofactor is given as minus 1 power I plus j m. If it is ij, no, mij. This is your cofactor. That's how you find minor, and the element you know anyway. So first question answer is option D, and all the concepts are discussed over here. Next, cofactor of this, of the 4 in it. Okay. Remove this please. We have only minus 2 left. So C, which element is this? This is 2, 1. This is 2, 1. So right here minus 2. 2, 1, minus 2. Okay. Check here. The element is minus 2. For 2, 1, this is your minor actually. What about cofactor? Right here minus 1 plus add of this 2. Add of the position. 2 plus 1. What we get? Minus 1 power 3 into minus 2. Odd power means minus sign. So minus of minus 2. Answer is plus 2. Answer is plus 2. Hence your option is C. 2C. Fair enough? Clear? Okay. Next, third one. Adjoint of A is what in that case? Adjoint of A we have to find, we have two methods. One for 3 cross 3 we have separate, and for 2 cross 2 we have separate. Now basically if you want to find adjoint, you have to find the cofactor first, and then to find adjoint, no, you have to find cofactor matrix first. Okay, and then transpose of that. Okay, but there's a trick to it. For 2 cross 2 matrix, what is that? Write the matrix 2, 3, 1, 4. Across the diagonal, interchange. Across this, interchange. And across this, sign change. Sign change. When you do that, check the result. 4 comes here, 2 comes here, minus 3 and minus 1. Look for the option. This will be your adjoint of the given matrix A. Adjoint A. 4 minus 3 minus 1, 2. Option D is right. So far, no doubt in adjoint, in cofactor, in minor. Are you getting my point? So the MCQ can come on these concepts, or we have few more properties also. We'll check them. This is the property. Adjoint of A determinant is given by, very simple. If you have adjoint of A determinant is given by determinant of A power n minus 1 power what? When you have one adjoint, power is 1. So what is the answer? N is what? N is 3. So 3 minus 1. So square of A. Square of A. Option B. Fourth option B is correct. If we had 2 adjoint, we'll have n minus 1 power 2. If we have 3 adjoint over here, means adjoint of adjoint of adjoint, we'll have power 3 and so on. Next. Same approach. If the determinant is given as 5, they're asking you this value. Answer will be what? Determinant of a power n minus 1, n is 3, 3 minus 1, so 5 power 2, answer is 25. Option B. Option B. Fair enough. Next, question number 6. If A is 3 cross 3 matrix and adjoint of A is 36 given over here, so we'll write for this determinant of A power 3 cross 3 means 3 minus 1 equals to 36. So determinant of A square will be 36. Determinant of A will be what? Plus minus 6. Option C. Option C. Clear? Yes. Why same question, sir? Because they have been repeated so many times. They're all PYQs actually. Okay. Next, 7th one. If A is a square matrix of order n, then what is it? This is the property, no? Definition. If you had 2 adjoints over here, adjoint of A, answer will become what? Determinant of A power n minus 1 power 2. Getting it? Yes. 8th one. This one. 3x x1, find the value of x. Usually what happens, we are in the habit of solving this question based upon matrices. So we compare and get the answer. That's wrong. We have to see here determinant value. They are not a matrix. This is a scalar value. Solve it. 3 minus x square. Over here. 3 minus 4 into 2, 8. This over here, this over here. So 3 minus of minus 5 comes here, and we have this as x square. So I get x square equals to 8, x equals to plus minus 2 root 2. Option D. Option D. Solve it. You'll all get the answer. I know I can trust you on this one. Next question. Another question. This is from your question bank. This is an easy problem. Check here. If Ax equals to B, determinant of A is 0, adjoint of B equal to 0. Determinant of A 0 means it's a singular matrix. It is singular. It is singular. So in this case, we have 2 options. If adjoint of A into B equal to 0, and if we have adjoint of A into B is not equal to 0. When this case happens, it is going to have infinite solutions. When this happens, we have no solutions. Check the case of this one. Adjoint of A into B is 0 means answer is option D. Answer is option D, infinite many solution. Fair enough. Clear? 28. Sorry, this is 27 from the 27 from your what do you call from your question bank. 28th question I'm solving now. If A is a matrix of order 3 such that A adjoint A is 10i, again another property. So this is given by, if you remember the property, determinant of A into I. So determinant of A is given as 10 here. Now apply this property. Determinant of A power n minus 1. So 10 power 3 minus 1, 10 power 2, 100. So option D. Option D. Check here. Option D. Clear enough? Okay, this is a little bit cut on this side, but the answer is option D over here. Please check. This is written as 100. This is written as 100 over here. Next question. Okay, if A is a square matrix of order 2, all right, and determinant of A is 3, okay, then this will be given by what? Determinant of A power 2 minus 1, no? So determinant of A power 1. So 3 basically, they're given 3. It means first option is wrong. They're given 9, so this is wrong. Reason you check. Correct, this property is true. So A is false, R is true. A is false, R is true. Option A. A is false, R is true. First one should be 3, not 9. So A is false, but R is true. Yes. 41. 41. Okay, properties of adjoint, transpose with the determinant. Apply this. For we have a property Ka, determinant is given by what? This is given by K power n determinant of A. We also know that A transpose determinant is same as A determinant. So this whole thing becomes what? twice power 2 power n determinant of at. This will become 2 power n determinant of a. 2 power n is 2 in this case, so 2 power 2. Determinant of a is how much? 2 minus 3. So 2 minus 3. I get the answer as 4 into minus 1. So minus 4. 2 power 2 is 4 into minus 1 is minus 4. This is a fill in the blanks. Minus 4. Done. Next one. The value of cos 15, the determinant of this, cross multiply cos square of 15 minus sin square of 15. Cos square minus sin square a. Cos of twice of 15. So cos of 30. So root 3 by 2. Option B. Cos square a minus sin square a is nothing but cos 2a. Cos square a minus sin square a is nothing but cos 2a. 44 is also done. Okay. I think we are on to the last few questions of your MCQs. System of equations, this has what? Okay. So just take the ratio 4 to 8, 6 to 12 and minus 5 to minus 10. I get here 2, 2 and 2. They are all equal to 1 by 2 means infinite solutions. Answer is option B. Now, I understand. You might be thinking right now, sir, this is 2 variable. We know this, sir. What happens if we have 3 variables, sir? What happens if you have 3 variables, sir? Then what are we going to do about it? Nothing. If you have 3 variables, let's say x, y and z, and you'll have how many equations? You'll have equation 1, equation 2, equation 3. Use the 2 equations to eliminate 1 variable. Listen to me. Use 2 equations to eliminate 1 variable. You'll have only 2 left over here. So you'll get 2 different equations. Using these 2 equations, you'll get 1 equation. And let's call this to be equation number A over here. And use these 2 equations to get another equation B. Now these 2 A and B will be in 2 variables. I'll repeat. Right now we have been given 3 variables. X, Y, Z. How do we apply this principle, sir? Nothing is there. Just modify these 2 equations to eliminate 1 variable. How to do that? Make the coefficients same and subtract them if it is of the same sign. Okay, so eliminate one of the variable using the elimination method. Using the elimination method, you get one of the equations in 2 variable, either x or z or x or y, your choice. And same over here also you're gonna do with the second and third equation. You will eliminate one of the variables. Okay. Now we have 2 equations, equation A and equation B. That will be in the 2 variables, either xy or xz, whatever it is. Solve them in this way and check the nature. Done? Next. If A and B are invertible matrices of the same order, what is the value of this? Superb question. Superb question. So first principle will give me this. Reversal law, B inverse, A inverse. Now, individually we can find the determinant. We know the property as well. So 1 by determinant of B into 1 by determinant of A. Okay. And this is equal to what? 8. This here is equal to 8. Okay, sir. So determinant of B we don't know. So 1 by B will keep as it is. But 1 by A is given as 2. Equal to 8. So 1 by B is equals to, bring this 2 on this side, 16. It means B will be equal to what? 1 by 16. Option D. Done? Done? No? Easy question. Yes. Okay. Now time to solve. 2 markers. Time to solve 2 markers now. Let's go. Let's go. Here we are. If the area of triangle with vertices, this is given. Find the value of K if the area is 4 square units. Okay. Area we are looking for minus 2 0 0 4 0 K 1 1 1 equal to 4. 1 by 2 here. Area means has to become plus minus 4. Why plus minus 4? Because even if the determinant value was coming as minus 4, think about it. If you solve this part for a different question, if you solve this part, you get minus 4. What is the area? 4 only, because area will be taken as positive all the time. So if you are solving in the equation, we have to take both the cases, both plus and minus 4. Okay. Bring this 2 on this side. We'll get plus minus 8 and solve over here with the first column. Minus 2. We have 4 minus K. This is plus minus 8 because these 2 terms are 0 0. This is 0 0. So we get here minus 8 plus 2K plus minus 8. Solve now. We get minus 8 plus 2K equals to minus 8. Cancel. Value of K is 0.
other form, minus 8 plus 2k equals to plus 8. Being on this side, 2k equals to 8 plus 8 is 16. K is 8. Two values. Check here. Answer is k equal to 0 or k equal to 8. 2 mark. Have a look. So the type of questions you can predict is very, very simple. Properties based questions in the MCQs, area of triangle based questions, or equation of a given line or 2 points are given, that question can come, missing variable question can come, or area you have to find, that also question can come, like this one. Find the area of a triangle. Find it. 1 by 2, 1 0, 1 6 0, 1 4 3 1. Find across the third column, the second row. 1 by 2 as it is. Over here check 0, minus plus minus, so minus 3 times off. Minus 3 times off, you check here, this is cancelled. 1 minus 6. 1 minus 6. What I get? 1 by 2 minus 3 into minus 5. How much is that? 15 by 2 is your area. So square units. 15 by 2 square units. 15 by 2 square units. Next question. Find the inverse of the matrix 2 minus 2 4 3. How to find inverse? Find determinant first. 2 into 3 is 6 and minus of minus 8, that's 14. That's 14. 6 plus 8 is 14. Okay, correct. Inverse, find adjoint for that. I taught you this. Interchange this. So 3, 2, sign change. 2 and minus 4. What's the answer? Inverse. Okay, that's it. 3 minus 4, 3 minus 4, 2, 2. 1 by 14 is the determinant value which is non-zero. We can get the answer as this one over here. Done. Next one. Okay, find the equation of the line joining the points 3, 1, 9, 3 using determinant. Okay, so line joining the point, these two. Check here. I have 2 points like this. 3 1 and 9 3. Sir, we know how to find it, sir. Learned in grade 10. 2-point form. y2 minus y1 upon x2 minus x1 into x minus x1 equals to y minus y1, sir. 2-point form we know, sir. No need. We'll solve it using the determinant. Okay, we'll check over here. Right now we're supposed to solve it using determinant. We'll assume a point on this xy which lies on the line. We can assume a point on this xy, point xy on the line which is joining the 2 points. Okay, great. Since all the 3 points are on the same line, it means the points has to be collinear. The points has to be collinear. Okay, it means area of triangle formed by these points will be 0 because they're on the straight line. So what's the area? Is going to be 0. Area going to be 0. So 1 by 2, 3 1, 9 3, xy 1 1 1. 3 1 9 3 xy 1 1 1. Expand it. We'll get over here 1 by 2. Okay, and for 3 we'll have here 3 minus y. 3 minus y. For minus 1, for minus the second term we'll have here 9 minus x. 9 minus x. And for the last one we'll have 9y minus 3x. For 1 we'll have 9y minus 3x. Minus 3x. Let's take it over here. So the triangle area is coming as, what is it? This is coming as, and of course we all know that this has to be 0, okay? Because area of triangle has to be 0. So this over here has to be 0. Please check. So 1 by 2 we have, and expand it. So we get 9 minus 3y. 9 minus 3y. Then we have minus 9 plus x. Minus 9 plus x. Okay? And we have 9y minus 3x. We have plus 9y minus 3x. This should be equal to 0. Check here. 9 9 cancels. 9y and 3y we have. So that becomes your 6y. And x and minus 3x will become minus 2x equal to 0. We have 1 by 2 outside. Cancel it. So we get 1 by 2 will be cancelling these two terms with 3y and x. 0. I get x equals to 3y, or basically x minus 3y equal to 0. That's my equation. 2 with 3 will be 6, 2 with 1 will be 2. So 3y minus x equal to 3y, or x minus 3y as 0 is my equation of the line joining the points 3, 1 and 9, 3 using determinants. Clear? This is the end of your section B, which is 2 marker category. Now we're going to move on to what? The 4 mark category. The 4 marker category, have a look. Over here. Okay? So that the matrix given like this satisfies the equation, and I is your 2 cross 2 entity matrix, 0 is your 2 cross 2 null matrix or 0 matrix, and find the A inverse. Okay sir, fair enough. To prove it to this, we need to find A square first. Find A square. We have 2, 3, 1, 2. 2, 3, 1, 2. Row to column will go 2 into 2 is 4 and 3. So 4 plus 3 is 7. 4 plus 3 is 7. 6 plus 6 is 12. 2 3 is 6 and 3 2 is 6 again. So now we'll do the second row. 1 into 2 is 2. 2 into 1 is again 2. So 4. 3 plus 4. So 7 again. 7, 7, 12, 4. Okay, we are getting A square. Let's get now minus 4A or plus 4A. Check here, plus 4A, what we are getting? 8, 12, 4 and 8. 8, 12, 4 and 8. Now I, 1, 0, 0, 1. Difference of all these. Check the LHS I'm taking. A square minus 4A, sorry, plus I, not the difference, plus I. Okay? Subtract these two. 7 minus 8 is minus 1. 7 minus 8 is minus 1 plus 1, 0. Here, 12 minus 12 is 0 plus 0, 0. 4 minus 4 is 0 plus 0, 0. 7 minus 8 is minus 1 plus 1, again 0. This is equal to what? Null matrix of the order 2. Check here. Check here. Done. This is clear. This is proven. Now I'm looking for what? Inverse of A using same condition. So over here we have A square minus 4A plus I equal to 0. From here I get, what is it? I get I, I'll keep over here, it will become 4A minus A square. 4A minus A square. Now multiply A inverse on both the sides. So you'll get A inverse into A, I. 4 is a constant, so 4A inverse A minus A inverse A square. A inverse into I is what? Simply A inverse. 4 into A inverse A is nothing but 4I, and A inverse of A square will become what? Minus A. A inverse of A square will become minus A. Check here. A inverse 4I is what? Going to be what? 4, 0, 0, 4. And over here minus A will be what? A value right here now. 2, 3, 1, 2. 2, 3, 1, 2. Check the value of A inverse then. How much is it? 4 minus 2 is 2. 0 minus 3 is minus 3. 0 minus 1 is minus 1. And 4 minus 2 again is 2. This is your inverse answer. This is your inverse answer. This comes from 4 mark. It's a PYQ also of March 2022 paper. Please have a look. Clear? Okay, let's move on then. This question is clear, 4 marker. Moving on. So for this question, using determinants, so that points A, B plus C, B, C plus A, and C, A plus B are collinear. Let's make the matrix first. So we have A, B plus C 1, B, C plus A 1, okay, and C, A plus B 1. Okay, so let's call this matrix to be A. Okay, this matrix to be A. Now for them to be collinear, what should happen? What is the meaning of this? It means the points here A, B and C lie on the same line. Okay, they're collinear. So area of triangle has to be 0. Area of triangle has to be 0. Basically the determinant value of this should be equal to what? 0. So once we prove this is 0, means our result is complete. Okay, let's check. So we can expand, we can do the expansion over here with any of the rows or column, get the result, or let's try doing some transformation, and I think that will also work and will be faster also. So if I try column 2 to be
column 2 plus column 1. Column 2 to be column 2 plus column 1. Where's the column 2? This one here. So column 2 will be what? I'll replace the column 2 by column 2 plus column 1. Superb. So I get this as, check here, this will remain as it is, A, B, C will remain as it is. So if I add this to this, I'll end up with A plus B plus C, this to this, again A, B, C. So we'll have A plus B plus C. Here also we have A plus B plus C. 1, 1, 1. 1, 1, 1. Now you can check here, we have this as the same elements in the column. Okay, what happens because of that? Basically this becomes equals to 0. Hence we have proved that the determinant of this particular matrix of 3 cross 3 order is coming as 0, and that is the requirement for the area of triangle to be equals to 0, hence collinear. ABC are collinear. If you want, you can try the expansion method also and let me know if you're getting it equal to 0 or not. How are you gonna do it? A bracket C plus A minus A plus B, yeah, and we're gonna go with B plus C. If you take that element, it will become B minus C. For the last, we'll have A plus B into B minus C times of C plus A. Try that and let me know whether it is working out, you're getting the value 0 or not. Okay. Next, okay, so same question I've done over here, exact same question. The matrix is given A square minus 5A plus 7I. Just find the A square value, check how much it is coming, find the 5A and take LHS to prove it. Take LHS to prove it. Okay, we just solved this question right now. No, we just solved it over here. Please check here, right here only we solved it. Okay, find the A square value over here, then we got 4A and I value, use the LHS to get it equal to 0, and from here what we had, finally we found the inverse in this fashion. Okay, let me show you once again. Yeah, this is done. Yeah, so once you get that, how to find inverse from here, we have this condition A square minus 5A plus 7I equals to 0. Now simply take 7I over here, this all will go on that side, so 5A minus A square, and you have to take what over here as I will be equal to what? Will be equal to 1 by 7 5A minus A square. Now simply apply inverse to both the sides. You'll end up with inverse is 1 by 7, the constant outside. We have 5 into A inverse A, that is I minus A. So 5I minus A upon 7 will be a result. 5I you can find, A is already given to you. Okay, so 5I is what? 5, 0, 0, 5 is your 5I. What is A? Check here. The A value is given also. If you subtract them, if you subtract these two, you'll have the answer. So 5I minus A will be what? Will be 5 minus 3 is 2, 0 minus 1 is minus 1, we have plus 1, and 5 minus 2 is again 3. Okay, this is my 5I minus A divided by 7. So inverse is nothing but 1 upon 7 times 2 minus 1, 1 and 3. 1 and 3. This is the final answer. Prove it, finding the A square and 5A value, use the equation to prove it, the LHS equals to 0, and this is the solution to find how do you gonna get the value of A inverse. Alright, next will be your 5 marker section. In that, most of the times the question on the matrix method comes, so we have to give our energy on this particular question. Okay, there are multiple concepts, but what is important for our syllabus, we have to prioritize that first. Other topics also given in your NCERT, you can of course follow that and solve more and more questions from the PYQs and from NCERT, but this is the most important problem in your syllabus taken from your question bank. Let's solve it. What is the question? Solve the system of equations we have in 3 variables using the matrix method. They have specified it. You have to use matrix method only to solve it. Okay. So first step is to form this matrix. From this equation, I mean AX equals to B. AX equals to B. Now from here, once you get this value, you can find the X. You can find the X as A inverse of B. Means you can multiply A inverse into B. Okay. Now how do you find A inverse? For that you need to find the determinant of A and check it is not equal to 0. It cannot be a singular matrix. Superb. Once you get determinant as non-zero, once you have the determinant value as non-zero, next step is to find what? Adjoint, and we'll do that. I'll write the formula for you. So adjoint A upon determinant of A. Is that clear? Once you get that, multiplication with b will give me the answer. But first of all, I need to form the matrix, the first step. This is my step number 1, step 2, step 3, step 4, step 5 is the multiplication. Step 5 is the multiplication. Okay, so let me start with the first step of forming the matrix. So if I check over here, the coefficients will make the first matrix, variable is the second matrix, and b is the constant. Okay, so if I check over here, I have the coefficient as 1, minus 1, 2, 3, 4 and minus 5. We have 2, minus 1 and 3, and the variable matrix is the column matrix, so x, y, z. So is the resulting matrix, the constant matrix 7, minus 5 and 12. 7, minus 5 and 12 is my column matrix. Once we have this, what's the first step? Figure out and find the determinant of A. Okay, sir. Let's try it over here. Determinant of A. Check for 1. What I'm getting? I'm doing across the first row itself. 12 plus 5, so 17. 12 plus 5 is, sorry, minus 5. Sorry, forgive me. Calculation mistake. Yeah. 12 minus 5 will be 7. Okay, next is minus of minus 1, that is there for the second element, and we get here 9 plus 7. 9 plus 10, not 7. 9 plus 10 is the second bracket, and we get here minus 2. Last we'll have minus 3 and minus 8, so minus 11. Minus 3 and minus 8 is minus 11. So what are we getting the value of this to be? Check. Determinant of A is what? Is 7. Okay, 1 second guys. 7 here. We have 19, so it becomes plus 19, and we have plus 22. Determinant of A would be what? Determinant of A would be your value. Please check here. With 1 I'm getting 12 and minus 5, that is 7. Minus of minus 1 will make here plus 1, right? Minus of minus 1 for the second element, so plus 1. Okay, and we get over here 9 and minus of minus 10, that's 19. And the last with plus 2, what I have over here, minus 9 and minus 3 and minus 8, so minus 11. Yeah, this simply finding the determinant value. Got it. Next, what? Determinant of A is coming out to be 7 plus 19 and minus 22. So 26 minus 22, answer is 4. Determinant of A is coming as 4. Check here. This value is equals to 4. Okay, great. Determinant of A is 4 now. Next step is to find the adjoint. Now over here, we need to put some effort. Let's write the matrix first. So matrix is going to be 1 minus 1, 2. 1 minus 1, 2. And here we go. 1 minus 1, 2. And we have 3, 4 and minus 5. 3, 4 and minus 5. And 2 minus 1, 3. 2 minus 1, 3. This is my matrix. Okay. So this is my matrix A. I'm looking for adjoint of A, right? I'm looking for adjoint of A. Correct? Now for this, of course, you can find for each and every term. It'll take too much time. So simply do one thing. Take this matrix and repeat the first 2 rows. So I'm going to do what? Remove adjoint from here. Remove this A from here. And repeat the first 2 rows. So basically here, 1 minus 1. And we have 2. And we have 3, 4 and minus 5. First 2 rows. Then the first 2 columns. 1, 3, 2, 1, 3. Okay. First column. Then minus 1, 4, minus 1, minus 1, 4. So now we have a 5 cross 5 matrix. From here, we're going to remove the first row and first column. Check. First row and first column that we got now. The original we got for 5 cross 5 matrix. Remove the first row and first column, and we'll write directly the value of adjoint from here. Value of adjoint from here. Adjoint of A. How do we solve it? Check. So we'll solve from here, row to column. Okay. We'll go vertically over here and write in the rows. Okay. So 12 plus, what is it? 12 plus 5. 12 minus 5 actually, 7.
12 minus 5, because minus 5 into minus 1 is plus 5 and becomes, there's a subtraction over here, so 12 minus 5 is 7. Next we'll have minus 2 and plus 3, that is nothing but 1. Minus 2 and plus 3 is 1. Next, this was this one, minus 2 plus 3. Again we have 5 minus 8. Minus 1 into minus 5 is plus 5, minus 8 will be minus 3. Okay, carry on in the second set over here. 5 into 2, we get minus 10, and we have 9, minus 9, so becomes minus 19. Minus 10 and minus 9 is minus 19, and we get here 3 minus 4 will be minus 1. Okay, and over here 6 plus 5 is 11. So this is done. Now last one, 3 into minus 1 will be what? Minus 3 and minus 8, so minus 11. We have minus 2 and plus 1, so we have minus 1 over here. And the last, 4 plus 3 will be 7 again. 4 plus 3 will be 7 again. So now we have the value of adjoint of A. So you can know A inverse will be what? Same matrix with what? 1 by 4 outside, which is the determinant value. So what is the final answer I'm looking for? I'm looking for the matrix X. So A inverse into B I have to do. So right here 1 by 4. The matrix you're going to write. We have 7, 1, minus 3, and we have minus 19, minus 1, minus plus 11, plus 11. 1 second. Plus 11, and over here we have minus 11, minus 1 and 7. So little bit calculative, but it's worth 5 marks, and simple multiplication and addition. Okay, the matrix B you check now. So what is this? Matrix B is, sir, 7 minus 5 and 12. 7 minus 5 and 12. 7 minus 5 and 12. Okay, multiply now. Check. 7 into 7 is 49. 49, we have minus 5, and we have minus 36. Minus 5 and minus 36. Okay, next what? We have over here minus 19 into 7. Okay, so it will become what? Minus 9 sevens is 56. Okay, and 7 plus 5, so 12, right? This is correct. 19 into 7 is 126, and we have minus 1 into minus 5 is plus 5. And over here 11 12s will be your check here, 120 plus 132, so 132 we have for this. And next up, so we have minus third row, minus 77, we have a plus 5 again, and we have here 84. We have here 84. Simplify this to get the final answer for the matrix X. 49 minus, what is this? 49 minus 41, that's 8. And we have over here 132 positive, check, 132 positive with 126, so it will be 6 positive, 6 plus 5 actually. So 6 plus 5 is 11. Something is wrong. Okay, 1 second. So plus 5 I get, and 132 is correct. So 19 into 7, excuse me, 19 into 7 will be 163, no? Yes, excuse me, this will be 7 actually. Okay, so let's multiply now. Check here, 1 by 4 is as it is. Multiplication will give me 7 sevens are 49, and we have minus 5, minus 36. Okay, first one is done. Next, minus 19 into 7 will be 3. Okay, so minus 133. We have plus 5, this one to this one, plus 5, and 11 into 12 will be 132. Okay, again we get minus 77. We have plus 5, and we have 84. Okay, 84. Check. Okay, continuing from here will give me what? Simplify this. 49 minus 41 will be giving me 8. This 2 will become minus 1 plus 5 is going to be 4. And over here we'll have 7 plus 5, so 12. So 12. Okay, so this value gives me as 2, 1 and 3. This is the value of the variable matrix X, Y and Z, which is nothing but the matrix X if you cross check. Okay, so X is nothing but 2, Y is 1, Z is 3. That's your final answer. This here is your final answer. Check. Okay, done. So this is your answer for the 5-mark question. I can write it again over here. X is coming as 2, Y is 1 and Z is 3. Alright, check. 2, 1, 3, correct. I hope the whole process is clear, how to get the matrix form, how to write and find the adjoint and everything. Okay, so this is your final answer, will carry 5 marks. And I have a question like this, same approach you have to do. What are you going to do in this particular question? Exactly same. Find A, X and equals to B, and you'll have the X value as A inverse of B. To find the determinant to be non-zero and find the inverse, we have the formula. Inverse is adjoint of A upon determinant of A. How do you find adjoint, sir? Right here. This is the way to find the adjoint. You're going to do that approach for this particular matrix over here. 3 minus 2 and 3, 2, 1 and minus 1, 4 minus 3 and 2. So solve this question, okay, solve this problem and let me know your answer. So solve this question and give me your answer in the comments. Answer in the comments. Answer me right now for this question in the comment. This is the last problem of the day from the Brahmastra, and of course, as I said, homework will be given. So I've covered everything that you need to get the 12 marks in your determinant chapter in PU2. So I have given 2 homeworks over here. One on the same matrix method, 5 marks worth. This is worth 5 marks, and over here this is going to be worth 4 marks. 5 and 4 marks. Okay, so solve these and let me know what is your answer in the comment section. Now important topics from this chapter would be what? Adjoint of a matrix, area of triangle, we have inverse of matrix and properties. These are the 4 major topics for your syllabus from your chapter determinant. Continuity and differentiability. Blueprint. What is the weightage of this particular chapter, which is very, very, very important. Have a look. Check this out. We have 1 marker, short answer 2 marker, short answer 3 marker, long answer 4 marker and 5 marker from here, which becomes exactly 7 questions, and the weightage becomes 17 marks from this particular chapter. 3 MCQs comes. We have 1 of the question from 2 marker, 1 from 3 marker, and so on till 5 mark. Okay, so very, very important. I hope you can see the weightage. This is as per the latest blueprint given by your boards. And if you move on to the session plan, what I'm gonna give to you today will be starting from the most important topics discussion. I'll discuss the topics with concepts, then I'll move on to the questions. We have today 25 questions to discuss. So we have total 8 MCQs, 2 marker questions is again 4, and 3 marker is 8, and we have 5 marker, again 5 more questions, and later we'll get to know. Again, this is just a list of topics and I'll discuss them over here as well. Okay, so this is clear. So let's start discussion with the understanding each of this important concept. The first one is continuity. Yes, this question will come for 4 marks. So I'll tell you what concept can be asked in which category. So this will come for 4 marks. On this concept, questions comes on 4 marks. What is the concept? How do we define a given function continuous? Or if the given function is continuous and you find the missing variable, are you able to recall those questions? Yes. So when can we say given function is continuous? Okay, so fx, a given function, is said to be continuous if what? If the limit of the function fx at the point x tends to a should be equal to f of a. If the limit function of the function at the point a is equal to the function value at a, then you call the given function to be continuous. Okay, now in the limit, of course, to define the limit you need to there's a different criteria. Only you have to find the LHL and you have to find the RHL that you have learnt in your PU1 syllabus. Okay, so you know how to find the limit for the certain functions. Whenever I've taught you, I have given for in detail discussion of finding the limit, but in the syllabus, in this particular question, we'll use most of the time your LH rule, because this is faster and errorless. So we use LH rule. What is LH rule? L Hospital's rule we're going to use to find the limit condition, and we'll put it equal to f of a. If they are a missing variable, we'll find that value. If not, we'll prove that the given function is continuous. Okay, now for differentiability, we have the first principle. To prove for differentiability, right? To prove for differentiability, we have the one method is from the first principle. But in your questions you don't use it that often. What you actually use is you define the function. The method 2 is actually redefine the function. Okay, basically like this. So let's say the critical point is x more than equal to a or x less than a. You define the function in both the places, okay, and you what you're gonna do? Differentiate it for that. You're gonna differentiate it for these both areas. Okay, so for x more than a and for x less than a, let's write the function as something called as here as px and qx. Okay, then you're gonna get the value as p dash of x and q dash of x. P dash of x and q dash of x. If it is equal in both of them, if it is equal to means if p dash of a is equals to q dash of a, then we call the given function to be differentiable. Okay, differentiable. If listen to me very carefully, you're going to redefine the function in this format, x more than a, x less than a. We have the two different formats given to you, and we're going to differentiate both of them individually and find the value using the derivatives at the point a. If they are equal, then we call it as the LHD, the left hand derivative is equals to what? The right hand derivative. When that is true, we call the given function to be differentiable, and this is the method that we're going to use to solve most of our questions. That's why stick to this particular method, and this is continuity basic understanding of when to prove the given function continuous. I hope this is very much clear to all of you. Next, algebra of continuous function. On this, over a period of time, if you say for the last 10 years, 4 to 5 times they have asked questions on this, and I have also taken questions on this, where you have to prove that the given function f and g are continuous. The function f and g is looking like q actually. One second. The function f and g, are continuous either in an interval or a point. Okay, at a point, let's say a, at a point a, then even f plus g is continuous. Okay, or f minus g is continuous. Okay, is also continuous. Third one, f into g is also continuous. Okay, and we have the last one, f by g is also continuous, provided that g is non-zero at the point a. G is non-zero at the point a. Is it clear? If g of a is non-zero, means f of g is also continuous. This is your basic algebra of continuity. Okay, next. What next concept? Derivative formula for various function. Even though it looks very silly, but yes, the MCQ side, no, focus on this particular concept. For all the functions, whether it is trigonometric, logarithmic, exponential function, or a general polynomial function, for all of these, direct questions comes, and if you don't know the quotient rule, the product rule, you end up making mistakes in it. Okay, so derivative formula for various function is very, very important. Let's try it from the very first one that we have, the polynomial function. Y equal to, if we have a power x power n, derivative is given as what? A n x power n minus 1. And of course you can keep continuing like this. Y equal to, if I have e power x, derivative is also equals to e power x. If you have y equal to a power x, derivative is what? Derivative is a power x ln a. A power x ln a. And for the fourth one, check here. If I have y equal to ln x, derivative is y dash given as 1 by x. If you have fifth one, y equal to log of x with the base a. If the base is not natural value, then it becomes derivative as 1 by x ln a. 1 by x ln a. Okay, now this is the basics for the polynomial and exponential logarithmic function. Now we're going to move on to the trigonometric ones. Check here. If I have y equal to sin x, derivative is y equal to cos x. Seventh one, y equal to cos x, if I have, derivative is going to be minus sin x actually. And if I have y equal to tan x, derivative is what? Sec square x. If I have y equal to cot x, derivative is minus cosec square x. 10th one, y equal to, if I have sec x, derivative is y dash equals to sec x tan x. And 11th one, if I have y equal to cosec x, derivative is what? Minus cosec x and cot x. Okay, these are the 6, I think, yeah, 6 trigonometric function. We also have for inverse trigonometric function, y equal to, if I have sine inverse of x, then derivative is what? 1 upon root of 1 minus x square. If I have, very important, if I have cos inverse, it will become simply minus sign, but this is the most important. If I have tan inverse of x, it will become y dash as 1 upon 1 plus x square. 1 upon 1 plus x square. I hope this is clear. 1 upon 1 plus x square. Okay. So as I was saying for this one, for y equal to cos inverse of x, the y dash becomes what? Excuse me. The y dash becomes equals to 1 upon, sorry, minus 1 upon root of 1 minus x square, and we have for sec inverse, cosec inverse and cot inverse as well. For cot inverse is going to be minus 1 upon 1 plus x square. For cosec inverse and sec inverse is going to be 1 upon x times of 1 minus x square, and so on. Okay. If you want, they are not that used in board syllabus, but if you want, I can write it for you. For I'll write for y equal to sec inverse, let's say. So I'll have y dash as 1 upon x times of, and so on. Okay, but not that useful. I'm going to remove it. Okay, for other three, less used, very very less used. Okay, so these are the main important points when you say the formulas are concerned. Have a look 1 second from here also. Yes, so now it's time to learn some rules of derivatives. Some rules, very very important. The very basics, I hope you all know that, but it's okay. We are here to revise them as well. The first one is the product rule. The first one is the product rule. What is that? For product rule, if I have two functions, let's say f into g, I'm looking for the derivative. Answer is very simple. Differentiate first one, keeping this one as it is, plus keep the first one as it is, differentiate the second one. Now in the case of product rule, there is no order over here. You can go ahead with the g first and keeping f as it is, sorry, f as it is, derivative of g into f. You can keep anyway because this is going to be plus sign, okay? But when you go to the other rules, you'll see next is what? The quotient rule. Next is the quotient rule. Now in this, the order matters. For example, if I have a function given in this format, f by g, I'm looking for the derivative. I have to do for derivative of f first, keeping g as it is, minus sign will come. This time you're going to keep f as it is, differentiate g, divide by the function in the denominator square. Okay, the function in the denominator square. And the last and the most important one is the chain rule. Okay, the chain rule, because what happens over here, no, let's say if I'm trying to differentiate a function which is in terms of another variable or another function, for example, log of sine t, log of sine t, and this is a function given as y, and I'm looking for dy by dx. I'm looking for the value of dy by dx. Then check, I have how many functions to differentiate. First, when I do dy by dx, no, we'll differentiate first log. We'll differentiate first log. So I'll have 1 upon sine t. Okay, 1 upon sine t. Now differentiate. This is the first function, log differentiated. Next I'm going to differentiate sine. So I'll get cos t. Is it over? No. I'll differentiate t also, because we have to get in terms of x. So we have to write here dt by dx. Now what is the answer actually? The answer is cos by sine. So cot t dt by dx. Cot t dt by dx. This is your answer for the chain rule. It's very important. You have to learn to apply it very in the correct fashion, otherwise you'll lose a lot of marks over here. Do not miss out on because usually we remember about product rule and quotient rule, but in the questions we forget about the last derivative of the function t. If it was x, it'll become dx by x, which is 1. If this value was not t, it was actually x. If this was just x, this will become what? X. The answer will be for this as 1 if it is dx by dx. Okay, but in this case it is dt by dx, so we have to keep it as dt by dx. I hope this is clear for all of you. Next we have parametric form and second derivative. Again, highly important and question based approach that we are learning over here. We have one more reason, which is logarithmic differentiation. That also comes for 3 marks. I'll tell you that when I'm solving a question on it. Okay, I'll explain you that concept over there. Over here we'll learn 2 methods, which is parametric form and derivatives, second order derivative. So whenever you have a function given, let's say y, in terms of a function t, okay, and I have a function, what, let's call it as x, also in terms of another function, I'll write g this time, g of t. So both the functions are defined in terms of a parameter, which is t and t.
And what are they asking? Differentiate them like this, dy by dx they're asking. Then what are you going to do? Differentiate f by dt and g by dt and take their ratios. Looks simple? It is simple. We'll solve them when the question comes, don't worry. Okay, next let's learn what is it? Second derivative. Now for the second derivative, what is there? Simply second derivative is nothing but, as the name suggests, derivative of the first derivative. So we have a symbol for it, t square y upon dx square. We can also write sometimes as y2 or y double dash, your choice. Okay, but we usually write it as d square y upon dx square. This is given by derivative with x of what? The first derivative. This is your first derivative. This is your first derivative. Am I right? Yes. This is my first derivative. So this is nothing but derivative of first derivative is called as second derivative. Okay. Now it's time for questions, sir. It's time for questions starting from MCQs. Are you ready? Let's start from the question number 1. Again from the question bank, which is question number 41 from parametric form. This is from 41 of parametric form. Let's solve it. What do we get? We need to find the value of dy by dx. We'll go like this, dy by dt upon dx by dt. Have a look. For this we have 2a. If you differentiate 2a, you will get 2a, and if you differentiate this one, you'll get what? 2at. Because a is a constant, derivative of t square is going to be 2t. So 2at, this is cancelled, answer is 1 by t. Answer is 1 by t, which is the option number C. Option number C. I hope this is clear. Clear enough? Okay. Next. So we are doing what? Now we learned and revised our important topics. We're going to move on to solve the questions on them. Okay. Next is what? Derivative of 2 root cot x square. This is based upon chain rule. This is based upon chain rule. Very, very important question. Check here. Y is given as 2 root of cot x square. How many functions we have over here? We have first function as the root, second is cot, then is x square. Okay, chali. Y1 we are finding derivative form. 2 as it is, derivative of this root will be what? 1 upon 2 root of the same thing. I hope you know this. Derivative of root x is what? 1 upon 2 root x, same thing. Okay, check here. If I have a function y equals to root x, derivative of this is given by 1 upon 2 root x. From which approach? Polynomial derivative. Okay, chali. Let's move on to this now. So we have over here derivative of first function is done, the root function. Then we're going to differentiate cot. We'll get here minus cosec, same variable. Okay, the angle which is the same, cosec x square. Next, derivative of x square, which is nothing but 2x. Check here, this 2 and this 2 is cancelled. Now option you check, minus, because of this minus sign, minus 2x cosec x square by root cot x square. Answer is option C. Answer is option C. Clear? Simple. Next. Here you go. We have derivative of this function, again a concept of chain rule. So differentiate sine of x square plus 5 will become cos of x square plus 5 as it is, and derivative of x square plus 5 will be what? 2x. What is my answer? 2x cos of x square plus 5. Okay, so your answer is, who is the answer? This one, option D. Option D is the right answer. Okay, done. Yes, questions like this can also come in examination. They're very, very simple. Okay, not everything will be difficult for you. And anyway, this chapter is easier when compared to the other high weighted chapter, which is integrals, 18 marks. Okay, again, this question is on what? This question is on the algebra of continuity. If f and g are two real function continuous at x equals to c, then which one is true? Check here. Discontinuous, no. Discontinuous, no. No, this is the right answer. F by g is continuous provided g of c is non-zero. So I gave you 4 options now for addition, subtraction, multiplication, and the ratio, the quotient. This becomes here the right statement. Other 3 are wrong. Option D is the correct choice. So see, if you know the concept, you can directly get the answer over here. The derivative of f given by fx equals sine inverse of x exists, means this function here is differentiable in what domain? In what domain? That's what they're asking us. Differentiable in what domain? Check here, sine inverse of x. The domain is -1 to 1. -1 to 1. Option B is right. So you need to know what? For some questions you need to know your principal value branches as well, okay, from ITF. Clear? Okay. Next, y equal to log of log x with the base 7. Find the derivative. So y dash, for differentiate this function, so we'll get 1 by log first, 1 by log x, and for this we'll get what? ln 7, okay, and we'll have the answer for this log as 1 by x. So 1 by x log x ln 7. So this is the answer, option A, right? Option A. I gave you the formulas for these for that point only, because if you know the formulas you can get the answers directly. As I said, these formulas that you see over here are very much important, are very important to solve direct questions in the MCQ, especially MCQs, and there are 3 MCQs in the blueprint that is going to come from this particular chapter. Okay, let's continue. So we were, I think, here. Okay, this also is done. Next, the function given fx as x plus 1 x minus 1 is what? Modulus function is always continuous. Yes, we have a critical point over here, mod of x plus 1 plus mod of x minus 1. Okay, this function will have critical point at x equals to minus 1 and x equals to plus 1. And the graph of this function, if you remember, looks like this. Okay, this is minus 1, this is plus 1. So if you take over here, okay, plus and plus, this will be what? X plus x. Okay, this will be plus here, and this will be minus. So yeah, so basically 2, this is the value 2, and if you take the positive of both, it will become 2x. So this is your function, this is your graph. Actually this graph is 2x over here, this value is 2, this is minus 2x. How can I say that? Expand it in 3 cases. Expand in 3 cases. Check here. Case 1, when what? When x is less than minus 1. Okay, less than minus 1, both will be negative. So you'll get this function as minus x minus 1 and minus x minus 1. Sorry, minus x plus 1. Check this out. You'll get this function as minus x minus 1. Over here you'll get minus x plus 1. So 1 and 1 cancels. You have only minus 2x left. Okay, and you can go with the case 2 now. For case 2, x is what? Between minus 1 and 1. Between minus 1 and 1. For that, this part here will be positive, but this part will be negative here. Okay, so you'll get here what? X plus 1 and minus x plus 1. X and x is cancelled. So what is left now? 1 plus 1, which is how much? 2. So this is minus 2x plus 2. This is what? Minus 2x. This is plus 2. And the last one will be, if you take x, the case 3, if you take like this, case 3, if you take x more than 1, both will be positive. So you'll end up with what? X plus 1 and x minus 1. X plus 1 and x minus 1. So 1 and 1 cancel. You'll have the answer as simply 2x. Getting my point? Both cases, case 1, 2 and 3. So you have this as the graph, and you get what? 2 critical points, but you check at both the points the function is continuous. There's no break in the function. There's no break in the function. For that reason, the function is continuous at both the points, and we get the result as as option A, continuous at both the points. Option A. It's a very good question. Little difficult, but for that reason only I've taken it over here and shown you with the help of graph, getting both all the 3 cases. I'll highlight it for all of you. I will highlight it for all of you. Case 1 is right here with this as the result. Case 2 is over here with this as the result. Case 3 is here with this as the result. Is it clear? Answer is option A. One more time, check. Yes. Okay. Why this is important? No, because this can come in your other questions also. That's why it is important. Okay. It can come in the 3 marker as well. That's why it becomes very relevant for us. I'll show you in the questions that I've taken over here today. We have y. I'm looking for second derivative plus y. First find the first derivative. Y when you find first, you'll get minus 5 sin x. No, you'll get minus 5 sin x actually, because cos derivative is sine. So minus 5 sin x. This will be minus 3 cos x. Okay, and if you take y2, derivative of the first derivative, so minus 5 cos x, and this will become what? Plus 3 sin x. Check here, take minus sign common, you get what? 5 cos x minus 3 sin x. Check here, this is y2, this is y2, minus, what is this? Same as y. Check here, 5 cos x minus 3 sin x, so minus y. Bring on this side, I get y2 plus y as 0. y2 plus y as 0. Answer is option A. Answer is option A. Done. Next. Now we are moving to the 2-marker category. So we are done with the first 8 questions. Here we go. Question on implicit function. This is a question on a topic which is called as implicit function, where you can't make the subject as y or any other variable, okay? Because we have y plus sin y. How would you find it? You can't. You have to differentiate it like this itself and take dy by dx common. I'll show you. Differentiate this function. I have y plus sin y and cos x. Differentiate, you'll get here dy by dx. Excuse me. Here we get cos y dy by dx minus sin x. Take dy by dx common. We'll have the answer as 1 plus cos y minus sin x. What are we looking for? This value. Hence we have dy by dx equals to minus sin x upon 1 plus cos y. And that's my answer. Fair enough. We don't have a y exactly as a subject, so we differentiate it like this itself. Take dy by dx common to get the final answer in this way. Okay. 2-marker question. Next. Let's solve this one as well. Okay. We have a given condition. We have to prove that this is true. Differentiate it. It's again a model question paper. Sorry, not model question paper. Question bank, question number 23. Question bank, question number 23. For which question paper? So question bank of 2026 that they have released this year. Okay. Last week. Differentiate for root x. We just did right now. 1 upon 2 root x will come. For this we'll get what? 1 upon 2 root y. Is it over? Is it over? No sir. Because for x derivative is 1. So we don't write that. But for y derivative is dy by dx. So we have to write that. And derivative of 10 is 0. So we'll move that part over here. So I get what? 1 by 2 root x as it is. Minus 1 by 2 root y dy by dx. Okay. Check this out now. 2 and 2 is cancelled. Now what I can do, I can simply move on this side, okay, this whole thing. So I get here, this root y will come over here, root y upon root x equals to minus dy by dx. Simplify one more step and you'll end up with what? Root of y upon x, move this over this side, so plus dy by dx is 0. Proved. This here is proved. 2 marks yours. Okay. 23 question from the question bank 2026. Easy, very easy. This is also PYQ actually. Next, find dy by dx if y equal to log of cos of ex is there. Okay, differentiate y1. We'll get what for log? 1 upon cos of e power x as it is. This is for log. Differentiate cos. We'll get minus sine e power x as it is. But is it over? No sir, we have to differentiate e power x also. So e power x comes one more time. We get y1 as sine by cos. So minus tan e power x into e power x. Basically my answer is e power x with a minus sign, tan of e power x. Tan of e power x. This is my y1. Check please. Simple problems. So in 1 marker, 2 marker, the questions are very much simple. Okay. Again, discuss the continuity of the function. Given here sin x plus cos x, sin x into cos x. Tell me, for the domain that they have, what is the domain of sin x and cos x? Sin x and cos x domain is what? They are both all real. They are both all real. Okay, they are both all real. In their domain, sin x and cos x are always what? Continuous. So if you check here, this is your sin x function. Okay, and so on. And this is your cos x, sin x function like this, and cos x will be over here. Check. This is your cos x. This is your sin x, and here cos x. They're always continuous in their domain. Okay, so continuous everywhere in the domain. Continuous
continuous everywhere in their domain. Am I right? Am I correct? Yes. So if they are continuous everywhere in domain, then even what is it? Their sum will be continuous. Their product will also be continuous. F plus G, F plus G and F into G will also be continuous in the entire domain. Getting my point? Yes. Next, 3 marker. Next is the 3 marker question. Let's see one by one. What do we have over here? Yes, the question on the continuity. We have to solve them to get the value of the variable. No, in this case we are looking for actually the relationship. We can't solve because we have 2 variables over here, so we can't solve 2 variables with the one equation. Okay, so we have to go with the relation only. Okay, so let's find for continuity. We have one rule, that limit of the function f of x when x tends to a, in this case 3, in this case 3 should be equal to f of 3. Check the function. Wherever wherever we don't have inequality, use that function. Okay, for the limit part, so we get bx plus 3. So right here, bx plus 3, the limit x tends to 3, am I right? Yeah, should be equal to f of 3. F of 3 is what? Check here, equality present is in the first part, so ax plus 1. We'll write that later. Check here, so we get 3b plus 3 equals to, now in this function you're going to put what? In place of x you're going to put 3, so 3a plus 1. 3a plus 1, so I'm getting what? I can move b on this side, so I get 3 minus 1 equal to 3a minus 3b. So I get 2 equals to 3 of a minus b, which gives me a minus b value is nothing but 2 by 3. Moving 3 on this side, 2 by 3. So we are able to establish the relationship between the variables a and b when the given function is continuous at the point x equals to 3. Fair enough? Clear? Okay, sir. Aren't you having fun right now solving all the questions in this motivation one by one and scoring that 17 marks in this particular chapter for your PU2 boards? Okay. Another question where we have to find the continuity. We have to use the continuity to get what? To get the value of the variable a and b. Now in this case we can make 2 equations because we have 2 critical points. Check here, 2 and 10. So we'll have to do for 2 different places. Same thing. Let's do the limit function of fx when x tends to 2 should be equal to f of 2. Okay, for f of 2 we'll have 5. Check here, equal to sign is here, so f of 2 will be 5 over here and limit will be over here. So what we get for this part? Twice of a plus b. First equation. This is my first equation. Okay, f of x is this one. Put the 2 values, so 2 of a plus b. Next, what we get? Limit of the function when x tends to 10 should be equal to f of 10. Should be equal to f of 10. Okay, f of 10 you check is 21. So right here, 21. Now we put the value of 10 here, so 10a plus b. 10a plus b. This is my equation number 2. Equation 1 and equation 2. Do one thing, do 2a minus equation 2 minus 1. So 10a minus 2a is 8a, b minus b is 0, and 21 minus 5 is 16. So I get the value of a as 2. Value of a is 2. Value of a is 2 means 2 into 2 is 4. B will become equal to 1. Check please. So value of a is coming as 2, b is coming as 1. Subtract these two. 10a minus 2a is 8a, b and b is 0, 21 minus 5 is 16. Answer is what? 8a equals to 16, so a equals to 2, b equals to 1. Done. Both the variables are found out. Same question over here. Find the point of discontinuity for the given function. Answer: no point of discontinuity. Reason? Check here, mod x. The critical point is what? X equals to 0. Here we have x minus 1. X equals to minus 1. Check this out. Here we have the critical point as x equals to minus 1. If you draw them, you'll get a graph like this. Check here. I just draw it for all of you, right? Where's the graph? This one, I think. Where is it? So we just learnt it right now. Mod of x, mod of here, this one. You'll have a similar approach to that particular question. Mod of x plus 1, mod of x minus 1. That's why I taught you over here, so you can apply in that particular question. So do it right now and learn it from that part only. Check one more time. This is the concept and apply in this particular question over here. We have two critical points. We'll have three cases, okay, because number line will be like this, minus 1, and we'll have a 0. So we'll have one part over here. If you take both positive, what will happen to this? At 0 it will become simply after 0. It is minus sign actually. So it will become simply 1, I think. Okay, correct, no? If you take both positive, this will be also positive after 0, and this is also positive after 0. Okay, so we have both positive, x will go on. We'll have the answer as minus 1 actually. Please check x minus after 0 is positive, after 0 is positive. So yes, it's going to be minus 1 actually. So over here, minus 1 over here, y equal to minus 1, and between 0 and 1 this will be positive, this will be negative, this will be what? Positive, right? So we'll have minus x, and over here will be minus 1. If you put minus 0.5 will be positive only, so minus x minus 1, it becomes minus 2x minus 1. Okay, this is a line like this, slope, negative slope will be there, something like this. When x is 0, when y is 0, it's going to be what? The point is going to be minus 1 only, I think, right? If you put minus 1 over here, it will become 0, it will become simply 1. Okay, so something like this will come. Okay, what is the point when it touches 0? Y equal to 0 will touch at it will come out as 0 where only when it is what? And this is for this part, after 0, before 0 and minus 1. Check this out. So what will happen to this? It will become minus x, and this will be as it is. So again minus x plus 1, because minus x minus 1 actually, minus x minus 1, because we're going to open with the plus sign, right? Between minus 1 and 0, this will be with the minus sign, this will be the plus sign. Okay, because if you put any value between them, let's say minus 0.5, if you put, this will be what? Plus 0.5. So the mod will open with the plus sign. Not sure? Let me show you for you. If I take minus 0.5 between minus 1 and 0 plus 1, what is the value? 0.5. What is the answer? 0.5. So basically between these two values, this mod will open with the plus sign. So it will become what? Minus x minus 1. Okay. So what is this? Y equal to minus x minus 1 means y equals to minus 2x minus 1. So this will touch the x-axis at you move on this side, 0 will become 1 by 2, minus 1 by 2. Okay, so this will go like this, and at minus 1, like on the left side of the minus 1, this is when x belongs to minus 1 to 0. Okay, and this particular is when x belongs to more than 0, when x is more than 0, and this is case 1 over here. This here is your case 2, and check the case 3, when x is less than minus 1. What will happen then? Both will be negative, so it will become what? Minus x, and this will be minus of minus x plus 1. Check this out. This will become cancelled as plus 1. We'll have minus x plus 1 cancels. Answer will be 1. So this is your curve. So this is nothing but y equal to 1 curve. This is nothing but y equal to 1. This is minus 1 curve, and this will be what? Y equal to minus 2x minus 1 curve. So if you check this graph, what I drew over here from all the three cases, case 1 x more than 0, case 2 between minus 1 and 0, case 3 x less than minus 1, we are getting this curve. This curve is never discontinuous, hence the answer was this, right in point that no point of discontinuity. You don't have to draw all the points, but you can show it like this. There are three total cases, and you can continue like that, because this question carries how many marks? Total of 3 marks. Please check. This carries 3 marks here. So it will take some, you have to show the 3 cases. This is case 1. This is your case 2. Okay, and this is your case 3. I hope this is clear. A very good question, challenging and difficult as well, but yes, part of your syllabus. Please check. Continue. Find the derivative of this one. Okay, take x as tan theta. What I get now? 1 minus tan square theta upon 1 plus tan square theta is nothing but cos 2 theta, right? Correct, no? This is the formula for cos 2 theta. So sir, it doesn't do any good to me. Actually it does. Let me show you. Sine inverse of cos 2 theta we are getting now so far. Okay, make this as sine inverse of sine of
pi by 2 minus 2 theta. Now this is same. Check. Sine of pi by 2 minus 2 theta is nothing but cos 2 theta. Okay. Now you differentiate this. So this will be cancelled. First you'll have y equals to pi by 2 minus 2 theta. Now put the value of theta back in. Theta is going to be tan inverse of x from here. Tan inverse of x. So y is nothing but pi by 2 minus 2 times of tan inverse of x. Differentiate. Y dash will be 0 minus 2 times of 1 upon this value, 1 upon x square. So answer is what is it? Minus sign only, no? Yeah, minus 2 upon 1 plus x square. That's my final answer. 3 mark. Very good question. Simple though. Okay. Differentiate the following with respect to x. Differentiate it. If I have here y dash will be what? E power x plus e power x square into 2x, the chain rule. E power x cube into 3x square plus e power x power 4 into 4x cube plus e power x power 5 into 5x power 4. Something is common? Is something common? No sir. It is not common because we don't have x common, 2 common, 3 common, nothing is common. So this is your final answer. Nothing is common sir. Okay, next. dy by dx of y equal to cos x, cos 2x, cos 3x. This is a logarithmic function, very, very important. So simply you're going to take this value as log of y, and over here log of cos of x, cos of 2x, and cos of 3x. Now differentiate, you'll have 1 by y. Sorry, before derivative you have to apply the rules for logarithm, okay, on the right hand side. Let's check. So we have log of y as it is. It will be what? Log a into b into c will be log a plus log b, excuse me, cos 2x, no? Log b plus log c. Differentiated now. So I get 1 by y dy by dx equals to, we'll have over here derivative of cos. So 1 by cos we'll have here, and we'll have cos derivative as minus sin x, no? Minus sin x. Okay, directly I wrote. Yeah, minus sin x. Same over here we'll have again minus sin 2x upon cos 2x. Derivative of 2x will be what? 2. Correct, because we have cos log derivative will become 1 by cos. Cos is nothing but minus sine, and for 2x we'll have minus 2. Same approach over here, minus 3 sine 3x upon cos 3x. Check the final answer. You will have dy by dx as y. This y will go on this side, so y into minus tan x minus 2 tan 2x, excuse me, minus 2 tan 2x minus 3 tan 3x. That's your final answer. Put the value of y back in as cos x into cos 2x into cos 3x. Put the value of y as cos x, cos 2x and cos 3x. Fair enough? Clear? Next question. Okay. Derivative of this using the parametric form. How would you solve it? Solve for each of them individually and use the ratio. Okay, sir. That's fine from here. So dy by dx is given as dy by d theta upon dx by d theta. Okay, let's try this first. Dy by d theta first. Differentiate. A is a constant. Keep it as it is. 1 will be 0. This will become plus sine theta. Correct, no? Cos will become minus sine, so become minus and minus plus sine theta. Next we're going to move on to this one, dx by d theta. Okay, for that a is again a constant as it is. Derivative of theta will be what? 1. Sine will become cos. Okay, cos theta. So 1 plus cos is given by 1, 2 cos square theta by 2. Okay, 2 cos square theta by 2. Now continue. I'm looking for dy by dx, so there will be what? Dy by d theta upon dx by d theta. So what is it? A sin theta divided by a into 2 cos square theta, no? A into 2 cos square theta by 2 actually. Cos square theta by 2. One more step, check here. Value of sin theta is what?
2 sine theta by 2 into cos theta by 2. Correct, no? Sin theta formula is there. 2 sine x, if it is sine 2x, formula is 2 sine x into cos x. Same we have here, a2 cos square theta by 2. So a cancels, 2 cancels, this one of the cos's cancel, answer is sine by cos, so tan theta by 2. That's my derivative dy by dx in terms of the parameter theta. In terms of parameter theta. Okay, done. Next, find f dash if the f is given a sine inverse of 2 power x plus 1. Okay, like this. First step, write this, write this f of x, sine inverse is there. Write it as 2 times of 2 power 2x, and we have 1 plus 2 power x times of 2. I've done nothing but using the exponents rule, power rule I've used. X plus 1 is there, so there is a sum rule, okay, product rule. So 2 times of 2 power x, and this is 2 power x power 2, the power rule. Power gets multiplied. Okay. What next we have? Sine inverse as it is. I'll write 2 power x as tan theta. So it will become what? X will become, what is it? Sorry, not x. I'm writing this over here as well. Theta will become tan inverse of 2 power x. Just for reference, we're going to use it later, no? That's fine. So we have 2 tan theta upon 1 plus tan square theta. This, if you know it, if the formula is there for this as sine 2 theta, this whole thing becomes what? 2 theta. This is your f of x. Yes. Now what are we looking for? The derivative actually. So try from here. F dash of x will be what? Derivative of, okay, one more step first before I start derivative. 2 times of, write the theta value, tan inverse of 2 power x. Differentiate now. F dash of x. So 2 as it is, 1 upon 1 plus 2 power x the whole square. Derivative of 2 power x now with the chain rule. So we'll get 2 power x only and ln 2. So it will become what? 2 power x into 2. So 2 power x plus 1 ln 2 divided by 1 plus 4 power x. 2 power x the square is nothing but 1 plus 4 pi x. This is my value of derivative, sir. This right here is the value of derivative. Please check. Okay, done. Have a look. All right, next we are moving to the 5 marker category. Now let's solve these questions and we can say our chapter is over for 17 marks preparation from one of the most important and easiest chapter of calculus, continuity and differentiability. Next, what we have, check, determine the value of k. This is a 4 marker also, sometimes it comes for 4 marker as well. K cos x upon pi minus 2x when pi is not and x is not is pi by 2, and when x is pi by 2 it is 3. Okay, sir. Limit value. They've given it is continuous at this particular value, x goes to pi by 2. So limit value of the function when x tends to pi by 2 should be equal to f of pi by 2. Okay. Apply now. So we'll get what? We'll have k cos x upon pi minus 2x when limit x tends to pi by 2 equals to f of pi by 2 means this value is given as 3 over here. I've told you guys you have to apply LH rule over here. This is faster and easier as well. If you apply LH rule, take here, apply LH rule, get the answer. So differentiate under the limit. Okay, sir. So limit x tends to pi by 2 only, right? X tends to pi by 2. Differentiate k into cos will be minus sine x divided by pi is 0, so minus 2. X derivative is 1, so minus 2 equals to what? Equals to 3. Okay, this minus minus cancels. I have k sine of pi by 2 upon 2 equals to 3. Sine pi by 2 is 1, so k into 1 equals to, bring this 2 on the side, 6. So value of k is what? 6. Value of k is what?
6. Fair enough? 4 marker question. Okay. Now differentiate this. This is a question from logarithmic differentiation, comes for a very high weightage. So what is given to you? Y equals to this is given, right? Apply log. When you apply log, what does this mean? The root means the power as 1 by 2. Root means power as 1 by 2, and in log power comes in front as the coefficient. So 1 by 2. And we'll have here log. Now when you have log of the product, it will become what? As a sum. So log of this plus log of this. And the ratio will become what? Difference. So minus log of 3x square plus 4x plus 5. This is your log. So the product will become sum, the ratio will become the difference. Now you're going to take the derivative. So you'll have 1 by y dy by dx, 1 by 2 as it is. Differentiate log, you'll have x minus 3 and simply 1. Over here you'll have 1 upon x square by 4, and derivative will be what? Of this x square plus 4 will be 2x. Over here minus sign is there. So 3x square plus 4x plus 5, and over here we'll have what? 6x plus 4. This is my derivative. Okay. LCM. That's your answer actually. If you want to take LCM, if you can do that, go ahead and do it. Okay. Let's just simply calculations of these steps. The answer will be y upon 2 times of this whole thing. That's the result. Do the calculation please. Y on this side, okay, 1 by x minus 3 will not be completely factorizable, so you have to continue like this only. Do the multiplication and get the result from here. It will become x square plus 4 into this, and over here you'll have 2x into like this. So yeah, okay, that's your answer. Next one, sir. Another question on the parametric form. We are very close to completing our syllabus from the chapter continuity and differentiability. So please don't give up right now. Let's complete all these questions. I have how many? Let's check. I have how many? We are right now over here. So we have only 3 more to go. Only 3 more to go. Let's complete them, and our session will be complete and prepared also from this particular chapter. X and y are connected parametrically by the equation given in this format. Find dy by dx. Okay. So we'll do first dy by dx we are looking to find. So we have to go like this, dy by dt upon dx by dt. Let's find dy by dt first. For this one, we'll have dy by dt as a cos t. A cos t, right? A sin t will become a cos t. Now we have to move to dx by dt. Okay. And for this we'll have a as it is, common. Derivative of cos will be what? Minus sin t. And for log we'll have what? 1 upon tan will be as it is, so tan t by 2. Tan will be what? Derivative as sec square t by 2, and we'll have derivative of t by 2 as 1 by 2. So I can write this 2 over here as simply in front of tan. Derivative of t by 2 will be 1 by 2, so 2 I can write in the denominator or simply with the tan. Okay, continue over here. So we have what? We have a, check this out, minus sin t as it is. Everything is on this step. So we have 1 by 2. Tan t by 2 is how much? Sin t by 2, and divided by cos t by 2. Tan t by 2 is sin by cos. Sec square will come in the denominator. We'll have 1 upon cos square t by 2. Right? So check this out. This cos t by 2 and this will cancel. Okay? We have 2 sin t by 2 and cos t by 2. Last step for this particular derivative. A as it is. We have minus sin t as it is. And this becomes what? 1 by, check this out, 2 sin t by 2 cos t by 2. The formula is sin into 2 times of t by 2. So sin t. Not sure? Have a look. No problem. 2 sin t by 2 cos t by 2. Formula of sin 2a. 2 sin a cos a. Same approach. 2 sin a cos a. It becomes sin 2a. So answer is what? Sin t. Multiply now. You get a. It will become minus sin square t plus 1 upon sin t. So we have dx by dt as, check this out, it will become a cos square t
upon sin t. I'm looking for this value over here, so use that last. Dy by dx will be equal to this particular value over there. What is that? A cos t. Check. A cos t divided by a cos square t upon sin t. Upon sin t. So a cancels, cos and one of the cos cancel. This will go in front, up actually. So I have here sin t in the numerator divided by cos t. The answer is coming as what? The answer is coming as actually tan t. This is my final answer. Final answer is tan t. Derivative is coming as tan t. Check. dy by dx is coming as tan t. Superb question. Okay. One more time, have a look. First, dx by dt we got. First we got dy by dt. We solve for dx by dt, use the formula of sin 2x, and over here we have the result as a cos square t by sin t. Use the ratio, getting the answer as tan t. Next, find the second order derivative of the functions and show that this is true. Okay, sir. Differentiate from here. E power y x plus 1 equal to 1. We have differentiate e power y x plus e power y equals to 1, right? Differentiating this will give me what? E power y as it is. Okay, why to do that actually? Not required. We can do directly, no? No need to expand it. No need to expand it. So e power y as it is, differentiate x plus 1, I get 1. This time keep x plus 1 as it is, differentiate e power y. So e power y dy by dx equals to 0. Now take e power y common. Okay, you'll have 1 and you'll have what is it? Yeah, 1 plus dy by dx okay, into x plus 1 equal to 0. Into x plus 1 equal to 0. If you know, this is nothing but a non-zero value. This is a non-zero value. Non-zero value. This is not ever 0. This is non-zero. Okay, it means from here we get that this part has to be equal to 0, because the product of this and this is 0, product of e power y and this particular bracket is 0, and this is a non-zero value, means this particular bracket has to be 0 over here. So I get this as 1 plus dy by dx equals to x plus 1 as 0. Check. So I'm getting this as dy by dx equals to into x plus 1 equals to minus 1. So I get dy by dx equals to what? Minus 1 upon x plus 1, the first one. Differentiate this one, I'll get d square y upon dx square will be equal to, take this derivative of this will be what? Minus of minus 1 upon x plus 1 the whole square. I'm getting this value as 1 upon x plus 1 the whole square. So now if you check carefully, so what we are getting the answer as, this is my value of second derivative and this is the value of first derivative. If you compare, my second derivative is actually coming as the square of the first derivative, sir. The square of the first derivative. Square derivative of the first derivative is minus 1 upon x plus 1 the whole square. That will come as 1 upon x plus 1 the whole square. So you have proved it over here. Second derivative is nothing but square of my first derivative. Is it clear? Second derivative is nothing but square of my first derivative. Okay, let's move on. So this is your last question. This is a PYQ as well. I have to find and so that this is true. This is true for the given function. Differentiate y1 will be what? 2 times of tan inverse of x, okay, divided by 1 plus x square. Am I correct? 2 times of tan inverse of x divided by 1 plus x square is the derivative of y for the first time. Multiply on this side. I get y1 into 1 plus x square equal to 2 tan inverse of x. Okay, now you can differentiate it one more time. y1 will become y2 and this will be as it is. Now this time keep y1 as it is. Okay, excuse me. Yeah, y1 will become y2 and this time you're going to keep y1 as it is and you'll have this value as 2x. This value as 2x. Okay, now differentiate this side. You'll have 2 upon 1 plus x square. Cross multiply. You'll end up with y2 times of 1 plus x square
this and this will multiply, becomes whole square, and over here you'll have 2x times of 1 plus x square into y1 equals to 2. Check. Is it what they're asking? Y2 into 1 plus x square plus 1 the whole square, 2x times of this into y1 equals to 2. We have proved this one. That's it. This is a PYQ also. Okay, very oftenly you can see this question in your papers. So this completes your session on the C&D. The important topics would be, again, definition based question will come. The definition rules are, which is there, quotient rule, product rule, chain rule, the formulas, which is very, very important, second order derivative, parametric form are the important topics of this particular chapter, alongside with logarithmic differentiation. When the function is given in the form of f par g or f into g or f by g, these three forms are there: f into g, f par g, and f by g. Three forms are there. You're going to apply log on both sides to get the result. Remember this kind of function? Yeah. So this is also very, very important. Comes for 3 marks sometimes. Okay. So you have to understand this very clearly. Application of derivative. So I wanted to tell you all, this is very, very important. Make use of it. First thing over here is the weightage. So as per the latest blueprint given by your boards for this 2026 examination, okay, we have total 5 questions coming from here. 3 will be MCQs, 1 is 2 marker, 1 is 3 marker. I'll repeat, 3 questions will be MCQ, 1 is 2 marker, 1 is 3 marker. Means questions will be relatively easier from here. Okay, then if you take the total marks, the weightage will be 8 from the chapter AOD, application of derivative. Okay, there are 3 categories in the concept side. If you know, the categories are rate of increasing and decreasing function, like basically rate of change, increasing decreasing function, and then comes the last one is maxima minima. Okay, I clubbed the first two together, pardon me for that. Next, the content index, what I have planned for all of you. So I'm going to revise some key topics. Which are very, very important. Then we'll go ahead and solve these 22 questions. Okay, I'll give you homeworks also, and last I'll let you know the important topics that you have to cover from this chapter to get out marks from the weightage, the blueprint which is given to you. Okay, so I think we are ready for the revision now. The revision starts with the first, okay, rate of change of functions. I will teach you with the help of questions, because it varies upon question to question. Okay, the rate of change I'll teach you with the help of questions with the problems, but increasing decreasing functions concepts are there. I'll tell you right now itself. So when can we call a given function increasing? When can we call the given function increasing, or when can we call the given function decreasing? So we have 2 types of questions in this. One question is at a point or in an interval. Listen to me, we have to discuss the functions increasing decreasing nature in 2 ways. At a point or in an interval, the rules remain same. The rule is, first find derivative. If the derivative is more than 0, the function is increasing in nature. If the derivative is less than 0, the function is decreasing in nature. One more thing comes from here also. There are 2 branches from here as well, that something called as strictly increasing. This happens when f dash of x is only more than 0, and this happens when just increasing case is when the f dash of x is more than or equal to 0. Means equality holds over there. So this is the case of increasing function, where this is the case of strictly increasing function. Same 2 properties holds true in the case of decreasing function also, bacha, which is what? F dash of x is less than 0. This represents strictly decreasing function. And over here, when f dash of x is less than equal to 0, this will be simply decreasing function. Yes, so there was some disturbance. Let's continue from here again. So f dash of x is less than 0. When this happens, when we have 2 cases in this as well, strictly decreasing function, and we have only decreasing function. For this we'll have without inequality, and for this we'll have f dash of x less than or equal to 0 also is true. Now this will be straightforward used in the point of, let's say when we're talking about the increasing decreasing function at a point, okay, means f dash of x is c. But when we talk about interval, then what happens? You have to use, in the case of interval, you have to use what? You have to use the wavy curve
method, okay, where you plot on the number line and check it out. Don't worry about it, I will teach you once the problem solving starts, but right now the concept by it is this only, okay. Next is maxima minima function. In that also very straightforward approach. We have two approaches to solve the questions over here. The first approach is the derivative test number 1 or first order derivative test. In this case actually I will refer only to second derivative test, because I'll tell you what, even though first derivative test is very useful at times, but right now for a question point of view it becomes lengthier and confusing also at times, okay. So we'll go with the only one approach today in the session. Second derivative test we'll discuss. I'll give you a hint of that part also, like what it works in the case of first derivative test, because I cannot leave you guys hanging, okay. Check here, first one is maxima, this is minima. You know that, right? Local maxima, local minima. In local maxima what happens? So the derivative, which is the tangent of the slope, is like this. Here it is positive acute angle, here it is negative obtuse angle. When the slope changes from plus to minus, listen to me, slope changes from plus to minus. Slope of what? The tangent. What it means? Derivative. So derivative sign is from plus to minus. Check here. Derivative from where to where, sir? From plus to minus. When this happens, this is called as local maxima, okay. Whereas in the opposite case, if you have over here like this is a case of minus and this is a case of plus. When the derivative changes from, check this out, minus to plus, then this is called as, this is your max, excuse me, this is your local maxima and this is your local minima, okay, local maxima and local minima. This is the concept of first derivative test. First derivative test. So basically you're going to find the derivative and you check that in the neighborhood of that point where you're looking for maxima minima, the left to right trend should be plus to minus means maxima, minus to plus means minimum, okay. So this is the first derivative test, but we'll keep our energy to this side, which is second derivative test. For all of you who wanted to know this, let's say when I say I will not teach you this part, I know that as a student we want, sir, why not, I want to learn that method. Here it is, but we'll give our energy to this one because this is straightforward, no confusion and rewarding in nature, okay. So we'll stick to the second derivative test only. What happens in this? Find the first derivative, okay. First step is find the first derivative. Once you find that, put the first derivative of x equals to 0. What are you going to do from here? Find the critical points. What is critical point? Basically the value that you're going to get for x which will make the derivative 0. Let's say I get x value as AB. AB. Third step would be finding the second derivative, f double dash of x. Basically differentiate the first derivative, you'll get the second derivative. Now the fourth step would be apply this. If f double dash of at the point A is coming as more than 0, any value you put, it will be either positive or negative. Or if f double dash at B, let's say, is coming as less than 0, so the second derivative is positive or negative. Based upon that, we'll have this point as, if positive means local minima. This is local minima. This will be here local maxima. Second derivative is negative means local maxima. Second derivative positive means local minima. Okay, is it clear, guys? Excuse me. 1 second. Yeah. Is it clear, guys? Local max, local minima from the second derivative test. Isn't this very straightforward without confusion? Why can't we use this method? Let's use it. Okay. Next we're gonna move on to the question solving now. Okay, so I said we have three major topics: rate of change of functions, okay, whether it is area problem, like rectangle, side changing, decreasing and all of that. I've taken the questions, so I'm going to take the questions approach to understand that concept. But for maxima minima I have given you some understanding. For increasing decreasing function I've given you some conceptual understanding as well. This will work out, right? If you have a problem with that, let me know in the comment section. I will resolve that issue as well. Okay, right now MCQs. Question number 1: the rate of change of the area of a circle with respect to the radius. Okay, sir. dA by dr they are asking. Differentiate. D area is given as pi r square. So the derivative of what? This will become what? Sorry, 2 pi r. So 2 into pi, what is the r value? 3. So answer will be what? 6 pi. Answer will be what? 6 pi. Option A is correct. Answer is 6 pi. Option A is correct. Next, question number 2.
Question number 2. How many MCQs I've taken today? 12. I've taken 12 MCQs which are either PYQ or from your latest question bank. Latest question bank. Okay. A stone is dropped into a quiet lake and waves move in circles. Okay. And the waves are increasing in nature. If you throw a stone, what happens? The waves increases, propagates like this. Okay. So wave propagation is there, and this is given as dr by dt is 4 centimeters per second. Okay. At that instant, when the radius is 10 centimeters, r is 10. Find the rate of increase of area. So dA by dt they are asking this time, not dr, dA by dt. Rate of increase in area. This is given by what? Differentiate pi r square. We'll have this value as 2 pi r. Did I do that in the previous case? Yeah. 2 pi r dr by dt, and have over here 2 into pi into r value is 10, and this value is given as 4. Put it here, 4 into 10 is 40, into 2 is 80. Answer is 80 pi, which is option C. Easy or not? Very, very, very easy question. Next, question number 3. Question number 3. So 2 questions we learned right now on the rate of change only. The very basics one, very basic, I understand. Don't worry. I'm gonna, as you go in the session, the question level will increase. Okay. Basics questions of rate of change is covered. Now we are moving to the basic question of increasing decreasing function. Interval in which the given function is increasing. No problem, sir. What did I teach you? Derivative you find will have 3x. We'll have 3x plus 7, sorry. Pardon me. Only 3, no? Only 3. Check this out. This is more than 0. This is more than 0. It means derivative is positive for what value of x? For x belongs to all real number. Now this is the derivative approach, but if you want to be logical, this function over here is a linear function. Right? It's a linear function. Linear function with slope positive. It means the derivative will be what? When x is 0, y is 17, and will be like this, no? So this function is always increasing in nature. For positive slope, the angle will be acute. So like this, always increasing in nature. So answer is what? Option A. Check this out. This represents all real. From negative infinity to positive infinity. From negative infinity to positive infinity. Okay? Clear? Yes. Next question. 4th one. Interval in which the given function is increasing in nature. Now the interval concept is going to be used over here. Derivative will find 4x minus 3. First step. Second step is to do what? Put equal to 0 to find the critical point. So x equals to 3 by 4. Next step is wavy curve method. Right here, 3 by 4. This side plus infinity. This side minus infinity. Now check the coefficient of x. Coefficient of x is 4. Is 4 positive? Yes, sir. So right here plus sign. Now the power of the factor is 1. Power of the factor is only 1. Is 1 odd? Yes. Then sign will change. Plus to minus. The sign will change. Plus to minus. Now you check. If it was 4x minus 3 the square, we can have a case like this. Okay. If it was 4x minus 3 the square, then will happen only plus and plus. Yes. Okay. Of course, no. If it is a whole square, it will be always positive. That's why plus and plus. Getting it? Yes. Okay. So we have plus and minus. I'm looking for increasing. So this is my derivative is positive. This plus represents derivative. Plus represents derivative is positive. It means the given function is increasing from which interval? 3 by 4 to infinity. Open. Answer is option A. I don't think any problem is there in this particular question. Very simple application of increasing function in an interval. Okay. Is it done, guys? Yes, I think. 3 by 4 to infinity. The interval in which the given function is increasing. Log x, sir, forget about it. For this value for a more than 1, this is always increasing. In the interval from where to where? 0 open, infinity also open, always increasing. This will always increase provided the log base is more than 1. Okay. Provided log base is more than 1. If it is between 0 and 1, the graph will change over here like this. What is it talking about? Automatically accepted. I told you guys, no, when they say only log, if in your syllabus, in your book, anywhere it mentioned only as log, it actually means ln x. Log in the syllabus means ln x, and ln has a base of actually log of x to the base e, and e is a 2.7 something like that. Okay, so that is more than 1. Listen to me.
When they say log in your syllabus, it means ln. ln means natural log. When they say ln, the base is going to be log base e. E is something close to 2.7. That is more than 1. So this is the graph for your given function. Now this function increasing where? For all values from 0 to infinity. Open answer is option C. Problem? If you want derivative approach, do that. No problem, sir. Sir, derivative you teach, no, sir. Okay, fine. F dash of x is 1 by x. F dash of x is 1 by x. Log derivative. Now check this out. First of all, x cannot be 0. X cannot be 0 because it is 1 by x. Next, this has to be positive, right? Increasing means this has to be positive. 1 by x has to be positive. It means that it is going to be what? If you multiply over here, okay, check this out. For any negative value, you check over here. If you take x as minus 1, this whole thing will become negative. If you take x as minus 2, whole thing is negative. Means x has to be what? Positive only, na? I wrote that same thing over here. Derivative approach is this. Logic approach is this. Whichever works faster for you, use it. Pick the answer, move on. Question number 5, option C is the right choice. Sixth one. The minimum value of mod x. Very simple again. 0. Mod x graph. Remember, please, guys. This is the minimum value 0. It will never go to the negative y side. Hence, answer is 0. Question number 7. Maximum value of this function. Maximum value they are asking. Check here. This x minus 1 the whole square. Positive or negative? X minus 1 the whole square. Positive or negative? Sir, positive. Outside we have negative. Here, what is the result? Sir, negative. Negative plus 10 I have. Any negative number plus 10 I have. Any negative number plus 10 I have. This will be having maxima. Let me write it like this. Minus of, let's write it as y plus 10. This is a function something. Let's say, okay. Let me change it. This is, let's say, y, and this is your, let's say, minus p. Something p, okay, no problem. Check here. So y is minus p plus 10, okay. So I'm asking you to find the value over here, y max. Y maximum when will be? When will be y maximum? When this p is 0. Because if you take p as 1, okay, p as 1, what will happen? It will become minus 1. If you take p as 2, it will become again minus 2. So okay, so this will be keep reducing. Now you might think, sir, what if p is negative? Sir, what if p is negative? Somebody will think this. I know you guys are very creative in nature. What if p is negative, sir? Sir, then if p is negative, sir, then minus p is, sir, positive. Very good. It means, sir, it will add. You will think like this, no? If p is negative, sir, then minus p is positive, then it will add to 10. It will become, sir, more than, no. No, sir, p here is this value. It is always positive square value. No, I've taken, check the flow. Minus p, minus this. P is a whole square. Can never be negative. This is wrong. And of course, we have established, no, this is plus sign always, this is minus sign, product is always negative. So we have established that this number over here is always negative. So in that case, the maxima will occur when the value is what? What is it? 10 only, sir. The maximum value is 10 only, na, sir. B is the right answer. No confusion. None of you should have confusion that the value of the maxima of fx can be anything but 10. Can be anything but 10. The maxima is 10 because this value here established that it is always negative. This is always negative or 0. Can be 0 also. Take x as 1. X minus 1 minus 1 is 0. So negative or 0, but can never be positive. Can never be positive. This is established. Okay. So I hope this is all not messing you up. Only this you understand. This statement. Always negative or positive. Or 0. Sorry. Or 0. Done. Question number 8 now. In second derivative test, if f dash of c is 0, f double dash c is more than 0, some c on an interval I, then, okay, this is the definition, guys. This is the critical point. F dash of c is 0 means we get the value of critical point as c. Double derivative at c is what? Is more than 0. Means this is local minima, no? Local minima. I just taught you guys. Definition of local minima. Double dash means the second derivative at the given critical point is positive. So local minima, sir. Where is the answer? Done. Question number 9. The minimum value of the function given by this is what? The function is fx equals to xy, and x belongs to where 0 open 1 close. 0 open 1 close. 0 is open, 1 is closed. If 0 was close, doesn't matter about 1. If 0 was close, then I can say fx minimum is 0, because 0 is the smallest value. But if you draw the number line, here 0, here 1, but here 0 is open, this is closed, means there is no minimum value. Sir, there's a value right after 0. You might say that. So there's a value right after 0. What is that value? What is that value? Tell me. 0. I'm writing. Let me know in the comment section. What is the value right after 0 which is the minimum value? Tell me, what is the value right after 0 which is the minimum value? Okay, sir, 0.00000000000. Where to stop? Let me know. Where to stop? Let me know. It will never stop, sir. It will never stop. If you write over here, this is wrong, because we can go one more 0. So basically, there is no minimum value when you have x at 0 open. At this point, if it is open, there is no 0 value. There is no minimum value. Hence, the given function will have the minimum does not exist. The minimum does not exist. Got it? Yes. Next. Chalo. Question number 10. Sir, this is fifth one. Fifth one from where? Question bank. Bhai, question bank 2026 is discussed in the Brahmastra as well. So can you see the weightage of it? I told you guys this is your Sanjeevani booty. This will help you do whatever magic you want to create in your boards. Okay, so do follow it properly. Do make use of these sessions. Very, very important. Okay, chali. The radius of a circle is increasing at the rate of this, sir. Okay, sir, dr by dt is given. Okay, then the rate of increase of its circumference. Okay, sir, dc by dt I'm looking for. So derivative of, sir, 2 pi r, sir, then 2 pi dr by dt, sir. So then 2 pi, this value is given as 0.7, sir. So sir, 0.7 into 2 is, sir, 1.4 pi, sir. 1.4 pi, sir. 1.4 pi, sir. Option is there. Option B, sir. Option B. Problem? No, right? Not at all. Next. The 10th question from your question bank again. Interval in which the given function is decreasing. Find it. Why dash you find? You'll have this derivative as 2x e power minus x as it is. Then you have plus sign x square as it is, derivative of e power minus x as it is, derivative of minus x is minus 1. Chain rule. No surprises over here. Simple chain rule. X e power x derivative is e power minus x only, and derivative of minus x is minus 1. Now you take your x common, e power minus x common. You have here 2. Here this will become minus. One of the x is taken out, so 2 minus x. Put it equal to 0. Why? To find the critical point. Okay. From here we get, can this be ever 0? This is, sir, never 0. Exponential function is never 0. So this is non-zero. This right here x will be equal to 0, and this over here we get x value equal to 2. Okay, x value equals to 2. Check this out. Number line, sir. Negative infinity, positive infinity, the value is what? 0 and 2. Now check the sign, the coefficient of x. Plus, here minus. Plus and minus, if you combine them, it becomes minus. Each factor has the odd power. Here it is x power 1. Here it is also 2 minus x power 1. So odd power means sign change. So plus, minus, plus. Plus, minus, plus. Okay, excuse me. I'm looking for decreasing, right? Excuse me, I made a mistake, sir. Made a mistake, sir. Sorry guys. The coefficient is negative, no? This is minus x. Okay, so I start with minus sign, no, not plus sign. Minus, plus, minus. Okay, so we are looking for derivative to be negative. So this is the zone and this is the zone. What is that zone? Negative infinity to 0, open, union, 2 to infinity. Answer is option B. Tell me, will you get any question wrong in the MCQ of AOD? I have discussed 12 questions, but 12 most important questions from your question bank, from your PYQs, from your NCRT. You will not make any mistakes if you follow them properly, because I've done local maxima, local minima, I've done increasing decreasing function, I've done everything, rate of change also. So if you solve these 12 questions, I know this is written as 10, but that is 10th from your question bank. No, I've solved a total of 12 questions, right, from your MCQs. Solve these 12 and you will see that you cannot make any mistake in your board's examination, the 3 marks that is coming from this particular chapter of your AOD. Okay, clear, sir. No problem, sir. Next,
Next, okay, we have one more. Forget. We have one more. Okay, we have one more. Statement number 1, intervals in which the function is like this, increasing. Okay, find f dash of x. You will find first. We'll get 2x minus 4 equal to 0. We get x value as 2. So sir, this is negative infinity, this is plus infinity, this is 2. The coefficient is, sir, plus 2 means here positive, here negative. So I have taught the wavy curve method, no problem. Plus minus, I'm looking for increasing, sir, this zone. So 2 to infinity, sir, is the increasing rays. This is correct, sir. This is correct. Second statement, let f be a continuous in the closed interval AB, differentiable in the open interval AB. Then f is an increasing function, closed interval AB, f dash of x is more than 0. Yes, correct, no? When the f is increasing, derivative will be more than 0. So it is correct only. So both the statements are true, and actually this only explains our statement number 1. Check here, I'm looking for derivative to be what? Positive only, no sir? So both are true, and 2 explains the statement 1. Option B. Option B. Problem? Not at all. Not at all, very simple question. Is this last? That was the last of your 1 marker. Now we're going to move on to our 2 marker. Let's solve this second question. Okay. So now see, question number 13 comes back. Find the intervals in which the given function is increasing, decreasing. Find it. Derivative you're going to find first. 0. You're going to put, so 4x minus 3 equal to 0. So x will be what? 3 by 4. Number line. 3 by 4 here. Negative infinity over here. Plus infinity over here. This is plus because the coefficient is what? 4. So plus minus. So your f dash of x is, I'm looking for first option, which is increasing. Okay, is increasing when x belongs to, excuse me, fx is increasing, right? When x belongs to what? When x belongs to 3 by 4 to infinity. In this case, we get f dash of x as more than 0. B. Okay, chali. So when we have this one, f of x will be decreasing in nature when what? When I get x is what? X is from here to here. Negative infinity to 3 by 4. 3 by 4. And we have in this case what? Derivative to be less than 0. That's it. Got it? 2 marks. Next. Question number 14. Find the local maxima value of the function given like this, local maxima value. So we'll find again same thing, f dash of x, 3x square minus 3. Whatever is given the function, first thing is derivative and critical points. They are looking for maxima, minima, increasing, decreasing function, doesn't matter. Derivative, critical point is the same step. First step is done. Critical point means equal to 0. 3 is common, x square minus 1 is 0. From here I get x minus 1 and x plus 1 is 0. We get 3 here, means x value is 1 or minus 1. This time we are looking for what? This time we are looking for your local maxima value. So we need to find our second derivative. Check here. From this, we'll get this as 6x minus 0. Okay, the second derivative will be maximum, right? I want negative value. I want second derivative to be less than 0. So that will happen at 6 times of minus 1. Minus 6, which is less than 0. So your local maxima, right, occurs when x is equal to minus 1, this value, and the value of that function at that point is going to be what? Minus 1 cube minus 3 into minus 1. So minus 1 plus 3, answer is 2. Answer is 2. 14th answer is 2. Next question. Another 2 marker. A particle moving along the curve 6y equal to x cube plus 2. Find the points on the curve at which the y coordinate is changing 8 times. Means dy by dt is 8 times of dx by dt. That's what they have given. Y is changing 8 times the x coordinate. dy by dt is 8 times of dx by dt. Differentiate this. 6y equals to x square. Sorry, I wrote ulta. Yes, x cube plus 2, right? X cube plus 2. Differentiate this now. I'll get 6 times of dy by dt equals to 3x square dx by dt plus 0, of course. Now put the value of dy by dt from here. 6 into 8 times of dx by dt equals to 3x square dx by dt. Am I right? Yes. Check here.
Cancel this out, we get 3 with this cancelled. I have the value of x square as 2 into 8, so 16 equals to x square. Value of x is going to be what? Plus minus 4. You get the value of x as plus minus 4. Find the y value. Y is x cube plus 2 upon 6. So find the values. When x is 4, we get y as 4 cube. How much is 4 cube? 64 plus 2. 64 plus 2, right? Divided by 6. So 66 by 6, which is how much? 11. So why I'm getting 11 means when x is 4, y is 11. First one is done. Second part now. When x is minus 4, y will be what? Cube of minus 4. So minus 64 plus 2 upon 6. Minus 62 upon 6. Minus 31 upon 3. Yes. So y is this when x is this. Minus 4 is minus 31 comma 3. This is the 2 points which is possible to be having the rate of change of y as 8 times the rate of change of x. Clear? 2 marker. Next. 16th. The length x of the rectangle is decreasing at the rate of 3 centimeter per minute. Okay. And the width. Okay. They're saying that length is decreasing. No. Let's try like this. This is x. This is y. They're saying dx by dt is what? Decreasing means minus 3 centimeter per minute. And they're saying width means y. They mentioned here length is x, width is y. dy by dt is what? Increasing, no, at 2. So 2 centimeter per minute. Okay. When x is 10, y is 6, find the rate of change of its perimeter and the area. Perimeter and the area. Let's find it out. For the first one is perimeter. Perimeter is given by what? 2 times of x plus y. So dp by dt, I'm looking for rate of change of perimeter is dp by dt 2 times of dx by dt plus dy by dt, derivative with x and y individually 2 times of this value is how much? Minus 3. This is plus 2. Answer is what? 2 times of minus 1. So this is going to be minus 2 centimeter per minute is the value of your dp by dt. Value of your dp by dt. Next is b. What is b? When your area, so area is given by x into y. So when you differentiate area dA by dt, you'll get what? Dx by dt, y as it is, plus x as it is, dy by dt. Correct now? You're going to differentiate using the product rule, one function at a time. Check this out. You'll have y as it is, this value is how much? This value is minus 3. Sorry, y value also we know now. We know the y value also. Excuse me. So we'll have dA by dt as it is. What is the value of y? The value of y is given as y is 6, x is 10. So 6 into minus 3 plus 10 into, how much is it? 2. 10 is y, sorry, x is 10 and y dy by dt is 2. Right? Yeah. Minus 18 plus 20, answer will be what? Plus 2 centimeter square per minute. Because this is nothing but dA by dt. Got it? 16th is dA by dt, 2 centimeter square per minute and minus 2 centimeter per minute. Clear? Okay. Question number 17 now. That will be your 3 marker question. So 2 marker also over. Very important questions and the PYQs you can check over here. March 2022 paper. Yeah? Yes. 17th one. Find 2 numbers whose product is 100 and whose sum is minimum. Product means x into y is given as 100. Also PYQ check here. And sum. Okay, so we can find y in terms of x will be 100 by x. Because we have to keep one variable to differentiate and all, right? Okay. And sum here is given as x plus y. So right, sum is given by x plus 100 by x. Now you differentiate. ds by dx. We are looking for minimum, no? So ds by dx will find to get the critical point and all of that will apply. Second derivative test basically. I'll get over here 1 and it will be minus 100 by x square. Because derivative of 1 by x is what? Minus 1 upon x square. Minus 1 upon x square. Put this equal to 0 to get the critical point. I'm getting over here 1 equals to 100 upon x square. It means x square equals to 100. X value is plus minus 10. x value is plus minus 10. Okay, super sir. Now let's differentiate this function again to get the second derivative. D square s upon dx square. What are you gonna get? Differentiate this. 0 and minus 100 will remain as it is. Derivative of 1 by x square will be what? Minus 2 upon x cube. So answer will be 200 upon x cube. That's my second derivative. Second derivative. Now, if you put the value negative, if you want to get what? Minimum value, no? So minimum will occur when second derivative is positive. So find this at x equals to 10. You'll get this as, what is it going to be? A positive value. This will be a positive value, 200 by 10 cube. 200 by 10 cube. But if you take minus 10, it will be negative value. I want minimum. Minimum should be when second derivative is positive. Okay. So we get here, therefore, x equals to 10 is the local minima. Local minima. Minima. Therefore, the value of x is what? 10. And value of y is what? 100 by 10, hence also 10. So the two numbers are x equals to 10 and y equal to 10, where the product is 100 and the sum is minimum as 20. Sum is minimum as 20. Getting it? Yes. So question number 17 is also over. Moving on to question number 18 now. Question number 18. The length x of a rectangle is decreasing at a rate of 5 cm per minute. Okay. So let's call it to be x only. dx by dt is given as 5 cm per minute. Decreasing in nature. 1 second guys, 1 second. Yes. Equals to minus 5. This is the length. X here, y here. Okay, x here, y here. What else? Width y increasing. Okay, so dy by dt is given as increasing to be 4 centimeter per minute. Okay, 4 centimeter per minute. When x is 8, y is 6, find the rate of perimeter. Okay, let's find it. P equals to 2 times of x plus y. So dp by dt will be what? Solve it individually. For x and y, we have 2 times of dx by dt plus dy by dt. And so here we have, excuse me, yes, so here we have 2 times of your dx by dt will become what? Minus 5 plus 4, and this answer is nothing but minus 2 centimeter per minute, because it is your dp by dt. Okay, next. What next is there, sir? What next is there? So we're going to move on to the rate of change of area. So dA by dt this time. So x into y will have to differentiate. We'll get dx by dt as it is with y plus x as it is with dy by dt. Okay, x as it is with dy by dt. Okay, so we have this value as dA by dt. Check this out. X, okay, y into this, y is 6. 6 into dx by dt. 6 into dx by dt is minus 5. So write that. 6 into minus 5 plus. Excuse me, plus. We have x into, x value is 8. So 8 into dy by dt, that is 4. dy by dt is 4. So what I get for this? Minus 30 plus 32. That's 2 centimeter square per minute. So your answer is again minus 2 centimeter per minute right here, and your answer is 2 centimeter square per minute as the rate of change of area. Okay, question number 19 now. Find two positive numbers whose sum is 15. Okay, so sum is x plus y. This is given as 15. It means y is nothing but 15 minus x. This much is clear, sir. You should know what is going to be expected. So you just write till this point after reading the first statement. Next one, the sum of the squares of the terms means x square plus y square. This value, let's call it to be p. This value should be what? Minimum. I have to minimize this. First of all, write like this: p equals to x square as it is, and y value we're going to write in terms of x as 15 minus x the square. 15 minus x the square. Now you're going to find the derivative to minimize it using second derivative. To minimize using second derivative. Okay. Chaliye. So we get dp by dx is equals to 2x plus 2 times of 15 minus x into minus 1. The chain rule.
15 minus x will come from the polynomial part, and the minus x will be derivative taken as minus 1. Okay, so we get here 2x plus 30 and sorry minus 30 because we have a minus sign over there. This is minus sign, so minus into 15 will become minus, so minus 30, and this will become plus 2x. So the next step you check, you will have over here dp by dx is coming as 4x minus 30. This is equal to 0 to find the critical point, means x will be 30 by 4, so 15 by 2. Now here we have only one critical point, no need to find the second derivative, okay, because if you take this over here, the second derivative will be what? D square p by dx square will be simply 4, which is more than 0. Therefore the point x equals to 15 by 2 is point of minima, okay, minima. Therefore the x value is 15 by 2, and the sum is supposed to be what? Sum is supposed to be 15. It means this is half of 15 and y is also half of 15. This is your answer, 15 by 2 and 15 by 2, 7.5 and 7.5. Okay, 9/10 is done. Now question number 20. Okay, another very beautiful question. Please pay attention. It's a PYQ from 2020 March paper, annual paper. Sand is pouring from a pipe. Okay, at a rate of 12 centimeter cube per second, means d by dt is given, sir. d by dt is given, sir, as 12 centimeter cube per second. First data is complete. The falling sand forms a cone. Okay, cone volume is what? 1 by 3 pi r square h. Okay, forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius. Okay, so I get the value of r as 6h. Super. We got one variable form also, because we can replace r by 6h. Now what are they saying? How fast is the height of the sand is increasing? They're asking us the value of dh by dt is what? They're asking us the value of dh by dt is what? Okay, continue from here. So we'll take the value, the volume of cone, because whatever volume is coming out of the pipe, the sand coming out of the pipe is forming the same volume. The volume coming out of the pipe will be same as the volume of the cone. Correct? No? Whatever sand came out of the pipe, that is only making the cone. So VC will be same as 12 centimeter cube per second. Okay, sir. Now, yes, we'll try this over here. So we'll get the value of 1 by 3 pi r square. What is the value of r square? So 6h the square into what do we have? We have another h, no? For h, this check. So I get this value as 1 by 3 pi 36 h cube, because h square into h is h cube. 12. I'm getting this value as 12 pi h cube is the value of your function. Okay, now we're gonna differentiate this. Okay, so we have dv over here. This v and vc will be same. The derivative will be same over here. The rate of change volume will remain same. So find the derivative of vc. What we're gonna get? dvc upon dt equals to 12 pi 3h square into dh by dt. 12 pi as it is the constant, 3h square into dh by dt, the chain rule. This value is how much? Given as 12. Write it over here, 12. Okay, 12, and we have 12 pi 3h square. dh by dt is given as how much? We have to find that value only, dh by dt, and h is given as 4. H is given as 4. Okay, let's replace that. Let us replace that. Yes, so 4 square. Check this out. 12 and 12 pi over here, this is cancelled. I want to find the value of dh by dt, right? So what I'm gonna get? 1 equals to, I'm getting here 4 for 16 into 3, 48 pi. 16 into 3 is 48 pi dh by dt. So the value of dh by dt is how much? 1 by 48 pi centimeter per second. That's your answer. 1 by 48 pi centimeter per second is the answer for this particular question number 20. Okay, next is your homework, sir. So we have 2 homeworks today. One on the sum and product question. You're gonna solve it and give me the answer for July 2020 paper, and one more homework is there. Find 2 numbers whose sum is this.
Sum is given, x plus y is given as 24, and the product is as large as possible. So maximize the product. Product is going to be what? X into y, maximize it. Large means maximize it. Okay. Next, 22, another homework. We have intervals to look for. The given function is strictly increasing, means derivative will be what? More than 0 without inequality. More than 0 without inequality. So find that interval. This also is a homework. 21 and 22 is your homework. Okay. The chapter is integration. Next is your weightage, sir. So if you see the weightage as per your latest blueprint, this is it. You have a total of 6 questions coming, 2 MCQs and rest 1 each from the 2 marker, 3 marker, 5 marker and 6 marker. The total becomes 18 marks. 18 marks. The next chapter after this is 17 mark chapter, which is continuity and differentiability, but over here we have 18 marks weightage. Okay, that's wonderful and very important for us. Next, what are we going to discuss in this particular class will be your category of questions from 1 to 30. 1 to 9 is the MCQs that I've taken. Okay. Then there's a 10 to 14 will be the next 5 questions are 2 marker. Question 15 to 23 is 3 marker, 9 questions. 24 to 27 is 3 question again. Again 5 marker we have. So this will be 26 actually, and this will be 6 marker, 4 questions over there. Okay, because you can see 27 and 27 here. No, this will be 26 over here. So we'll change that, no problem. So the total will be total of 30 questions only. Let's continue. Yes, so first we're going to deal with our MCQs, starting the first question right away. This particular problem is a straightforward question, came in PYQ. The year was 2023. You check here. This becomes e power x outside, secant x, tan x plus secant x. I'll write individually. We all know that this is going to be your f of x, and this is your derivative. Okay, so answer is we all know e power x fx, so e power x secant x plus c. The property is e power x fx plus f dash of x. If the integration is like this, answer is e power x fx plus c. So option D, right? Option D. Option D is the correct choice. First MCQ is dealt with. Next one. Sin x upon 1 plus cos x the whole square. What are we going to do with this question? This is a substitution based problem. Take this as t. You'll end up with minus sin x dx as dt. Correct? Differentiate cos will be minus sin. From here you get sin x dx as minus dt. Check this integration now. We have minus dt upon t square. So minus of, what is it? We'll have t power minus 2 dt. Integration, you'll get what? T power minus 2 plus 1 by minus 1 plus c. And this becomes, what is it, sir? Plus 1 by t plus c. What is t over here? 1 plus cos. So 1 upon 1 plus cos is option C. Not D. Check here, the sign is positive. Sign is positive. Yeah? Super. Next question. This is a definite integral, right? Of the form root of, what is it? dx 4 square plus x square. Integration is going to be tan inverse of 1 by 4, actually tan inverse of x by 4 from where to where? From 0 to 4. Check here, when you put 4, you'll get tan inverse of 1. And over here you'll get 0. Tan inverse of 0 is 0. That's why I wrote directly as 0. 1 by 4. And this will be pi by 4. Answer is what? Pi by 16. Option D. Option D. Clear? Yes. Next question. X dx upon x square plus 1. Again, we are looking for a definite integral. Okay, sir. Let's try taking x square plus 1 as t. X square plus 1 as t. So forget about the limits right now. Just take the substitution. I'll get 2x dx as dt. So we have this as dt by 2, x dx as dt by 2. We'll continue as indefinite only. So we'll have here dt. The constant outside will be t, will be 2, and we'll have this as t. Answer is 1 by 2 ln t. right? Let's substitute back the original variables. We have 1 by 2 ln of x square plus 1 from where to where? From 2 to 3. Check 1 by 2 outside, put 3 here. We'll have ln 3 square plus 1, so 10 minus ln 2 square plus 1, so 5, half of ln a minus b, a by b, so 2, answer is 1 by 2 ln 2, 1 by 2 ln or log 2. Please check. Calculation, nothing else. We could have changed our limits right there as well over here, but we don't have to. This is a straightforward question. The answer is option B. Next, this is again the same question, right? E power x f of x plus f dash of x, integration is nothing but e power x fx plus c. Check carefully. This is your f of x and this right here is your f dash of x. So answer will be e power x upon x plus c. Option C is correct. Option C is correct. Yes? Okay. I hope you are enjoying the MCQs that I have brought for all of you in this session. E power x 1 plus x sine square of x e power x. So, okay, again a substitution question. X e power x you take as t, you'll get this as e power x, derivative of x is 1 over here. X as it is, derivative of e power x is same thing. dt over this and dx over here. Check, we have e power x common. I get 1 plus x dx as dt. Integration changes now. dt upon sine square t. So we get cosec square t dt. So we get what? This will be simply cosec square integration will be minus cot, no? Minus cot t plus c. T is x ex. So answer is option D. Answer is option D. Yes. Have a look. Next. 3 cos x plus 4 sin square x. Again a simple question. Separate the terms. Cos x upon sin square x plus 4 upon sin square x. We get here cos by sin will be cot x and 1 by sin will be cosec x. Over here 4 cosec square x. Am I right? We separated the sign over here. 1 by sin is cosec and cos by sin is cot. Integrate both the terms. We'll get this as minus cosec x over here plus minus plus 4 times of minus cot x. Of course plus c, so we have both of these are negative. So answer is option A. Answer is option A. Yes, sir. Next, sin pass 7x dx minus pi by 2 to pi by 2. This is not a MCQ, but this can be asked in your fill in the blanks also. So this year in the blueprint they have mentioned it as only 1 marker. They not mentioned at MCQ and fill in the blanks separately. This can be asked in fill in the blanks or MCQs also. It is a 1 marker question. So the property is minus a to a f of x dx is 0 when fx is odd function. Okay, check here. Sin power 7x is a odd function actually. How come, sir? If you replace x by minus x, so sine of minus x to the power 7 will be minus sine of x to the power 7, which will be minus sine of x power 7. This is nothing but definition of odd function. When f of minus x equals to minus f of x, this is odd function. Hence this answer is 0. Answer is 0. Please check. Next, your last of the MCQ, e power sin x cos x, same rule. This is f of x, f dash of x. So answer will be e power x fx. So option B. Option B. Ninth one, option B is correct. Another PYQ. All right. Now your 2 marker. Now it's time to solve the 2 marker questions. In that, the first one is the very simple one. Separate the terms and integrate individually. We get 2, 1 by cos will become sec square x. Over here we'll have 3. Sin by cos is what, bacha? Sin by cos is tan x, and 1 by cos will be secant x. Of course, both the places has dx in it. Correct? No, we have 2 cos square, so it becomes cos x into cos x. Sin by cos is tan, and 1 by cos is sec. Okay, this will become what? 2 tan x. Integration of sec square is tan x minus 3 secant x plus c. Here 2 mark question. 2 tan x minus 3 secant x. Next, evaluate dx upon 1 plus x square. Dx upon 1 plus x square. Okay, this is a formula, sir. Tan inverse of x from where to where? 1 to root 3. Tan inverse of root 3 minus tan inverse of 1. This is going to be pi by root 3, no? So we have 3 over here. This is pi by 4. Take LCM. 12, 4 pi, 3 pi. Answer is pi by 12. Another 2 mark question dealt with. Next. Find 0 to pi by 4 tan of x. This we know integration of tan is what? Log of secant x. From where to where? Same. 0 to pi by 4. So formulas you all have to know. Okay, that is non-negotiable. Otherwise you can't solve any question. Even these simple ones. I did not make this question. They are PYQs. Okay. So log of secant of pi by 4 minus log of secant of 0. Sec pi by 4 is how much? That is 1 by root, sorry, that is root 2 actually. So we'll have log of root 2 here. Sec 0 is 1. So log of 1 is 0. So my answer is becoming log root 2 minus 0. Yes. So you can write this as log of 2 power 1 by 2 comes in front. 1 by 2 log 2. 1 by 2 log 2. Next, integral of this. Integral of sec square x plus secant x tan x. Okay, answer will be tan of x plus this will become what? Secant of x. Of course, plus c. 2 marker. Sec into sec is sec square and sec into tan is sec tan, and if you integrate them, answer is secant and tan. Formula if you remember, right answer. Next, another simple question, looks difficult but it is very simple. Tan power 4 root x sec square root x and upon root x, answer is what? Take here tan of root x as t. Differentiate sec square root x. Tan differentiation is sec square. What about root x? That's simple. 1 by 2 root of x dx equals to dt. This is the derivative of root x. If you're not sure, do the differentiation of x power 1 by 2. Check. I'm getting here sec square root x by root x dx equals to 2 dt. Equals to 2 dt. We have this form. Check. Yeah. So I get t power 4 dt. Of course 1 by 2 is outside. Integrate t power 5 by 5 plus c. What is t? Tan of power 5 root of x by 10 plus c. T is tan of root x. 5 into 2 is 10. Simple question, another 2 marker. Next we are moving to the 3 mark category. Let's solve these as well. Question number 15. 1 upon x minus root x is there. Okay sir, in this we'll take root x as t. Root x as t. Check here. Differentiate this first. You'll get what is this going to be? 1 by 2 root x 1 by 2 root x dx equals to dt. Can we do better? I can do better actually. I can try that way or this way. Both will work actually. Okay, let's try this. So I can write this as root x common. This will become root x minus 1 dx. Yeah, this also works. I've taken root x common in the denominator, so root x minus 1. Now I'll have this d of x root x equals to 2 dt, right? Okay, sir. So this form is over here. You can see that this form is over here. Looks messy. Now this is better. This is much better. So integration, this will be 2 dt upon root x is t, right? So t minus 1. 2 is outside. Okay, it will become ln of t minus 1. Okay, plus c. Put the value back in. Ln of what is t? Root x. So root x minus 1 plus c. This is your answer. Looks difficult, but it is actually very easy. Next, e power x sin x. E power x sin x. This is a very beautiful question. I equals to integration of e power x sin x. Not only you have to learn this over here, you need to memorize it as well, because in if you're writing KCET examination, what happens now, this becomes very handy there, because you have to use this directly over there. That's why please understand it right now and memorize it as well. You don't have time to do it again even if you know it that time. Okay, so you got to use the result directly. I'll tell you at the end as well. So we have to use eyelet over here. Algebra has the preference, we have exponential and trigonometry. So trig has the preference over exponential function. So sin x will keep as it is, and integrate e power x, that will be e power x only, comes the minus sign, integration, derivative of the first function, that is cos of x, right? And next we'll have this as e power x, integration is again e power x dx. But the problem here is, usually when we deal with by parts, this becomes a simple integration again. But right now this also is another by parts, right? So all right, sir. Let's continue from here. I sin x e power x we have. Now we can use by parts over here again. So this again rule will apply. Trig has preference over exponential. So we'll keep cos of x as it is. Integrate e power x will be e power x. There comes the minus sign. Now this time, 1 second, sign differentiation was taken, right? So cos derivative we're gonna take. So we'll have here minus sine of x. All right, and e power x as it is dx. Do the expansion now. So I equals to sine of x e power x minus cos of, excuse me, one more step I have to write. We'll write one more step just for better understanding. Cos of x e power x, check here, it will become plus, no, plus sine of x e power x, what do we have, dx. Check carefully, this and this is same. Sin x e power x dx, sin x e power x dx. I can replace this with I then. So I'll get I equals to sin x e power x minus cos of x e power x. Okay, and this will be what, minus I. This will be what, minus I. Please check. Expand it, minus this and minus this. It will become I, so minus I. Now move this I on this side. You'll have twice of I equals to, take here sine of x. 1 second. Yeah. I can take e power x common in the numerator. I'll have sine x minus cos x. Okay, sine x minus cos x, and this 2 can go over here now. So my final result will be something like this. I becomes equals to e power x sine x minus cos x divided by 2. This is the result that I want you to remember. Okay, got it? So we had to do the by parts one more time, so that's why we had used it over here. Sign change and everything, you can see the steps. I have not skipped any one of them. Okay, the steps are clearly mentioned over on the screen. Okay, sir, moving on. Important question. Evaluate x sine 3x. X sine 3x. Now this will be a different story. You'll see. Preference order, I let algebra have preference over the trigonometry. So we'll keep x as it is, integrate sign. So we'll have minus cos 3x divided by 3, there comes a minus sign, integration, derivative of x, that's 1, again minus cos 3x by 3 dx. Okay, check, I have minus x by 3 cos 3x, and this will become minus and minus, so plus 1 by 3 integration of cos 3x dx. So minus x by 3 cos 3x, excuse me, cos 3x, and we have 1, it'll become 1 by 9 sine 3x plus c. How come, sir? Cos integration is sine. 3x means we have to divide by 3, one more 3 is already there, 3 into 3 will become 9, so sine 3x by 9, that's your answer. Check, 3 marker. Next, evaluate, check here, this is clear, right? 18th one, evaluate sine 4x sine 8x dx. Okay, sine 4x sine 8x dx. Alright, sir. So in this, oh, this is a formula, right? Sine A into sine B. So this is given as 1 by 2 cos of A minus B. So cos of 4x minus 8x. Okay, minus sine cos of 4x plus 8x. Right? Dx is there. Correct? No, this is formula sine A sine B. 2 sine A sine B. Okay, cos of A minus B and cos of A plus B. 1 by 2 can be taken outside. Cos of minus 4, that is same positive only. So cos 4x. Cos minus A is what? Cos A, even function. And cos of 12x dx. Integrate now, bacha. We have cos, cos integration is there, no? So sine 4x by 4. Sine 4x by 4 minus sine 12x by 12 plus c. So we get here by 8 minus by 24 plus c. Sine 12x by 24 and sine 4x by 8, the difference is there. Next, 19th, x square x dx, again in the by parts. So ILAT, you can see the by parts are one of the favorite question of your boards. Okay, it keeps coming. Again, algebra and trigonometry. So we have the preference of algebra. X will be as it is. X square integration will be what? Tan x minus comes here. Derivative of x is 1. Again we have tan x dx. So this is as it is. X tan x minus integration of tan log of secant x. Log of sec x plus c. That's your answer. Log of sec x plus c. X tan x minus log of sec x plus c. Yeah. Next, dx upon x plus 1. Again, a very important question that comes almost every year for your boards, which is your partial fractions. Sorry, not particular function, partial fractions. So we're gonna make it like this. 1 upon x plus 1 we have. There are more than one form of partial fractions, but most of them, the times they ask this form only, the quadratic form. But you can expect for cubic as well, and I have given that as well in the previous classes. Okay. All right, sir. What about this? So a upon x plus 1. 1 second. Okay, I erase everything. So I'm writing this as x plus 1, x plus 2. A upon x plus 1, b upon x plus 2, a times of x plus 1, b times of x plus 2. Okay, this is your integration. I'm trying to write all the steps because this is your boards. You can see the denominator is same, so I can compare the numerator. Okay. X equals to minus 1 if you put, you'll get the LHS as 1 only. This will become 0, and you'll have b equals to, what is it? Putting minus 1, no? X plus 1 and x plus 2. Yeah. So we'll have over here minus 1 plus 2. How much is that? we'll have the value of 1 equals to plus 1, right? So b value is 1. Am I right? X plus 1 and x plus 2. So we have like this. Next, put the value of x as minus 2. We put it as minus 2. So we'll have 1 equals to, we'll get a times of minus 2 plus 1, which is minus 1, and this is 0. A times of minus 2 plus 1 is minus 1, and that will be 0 there. So I get the value of a as minus 1. Value of a is minus 1. Now you can take this integration. Instead of this, I can take that, no? So I'll have minus 1 upon x plus 1, and integration of again 1 upon b is 1, right? So x plus 2. Both has dx in it. Integration will become minus ln of x plus 1 plus ln of x plus 2 plus c. Log a minus log b is nothing but log of a by b. 2 upon x plus 1 plus c. This is your final result. This is your final result. Please check. Here you go. Yes. Next, question number 21. X square log of x dx. ILATE. I-L-A-T-E. Log has preference over algebra. So we'll keep log x as it is. Integrate x square. So we'll have x cube by 3 minus sign. Differentiate log. So 1 by x. Integrate x square. So x cube by 3 again with dx. This cancel out of the x as x square. So we are getting over here x cube by 3 log of x minus integration of, what is it, x square, dx is left. So x cube by 3 log of x minus 1 by 3. This will be what? X cube by 3 again plus c. Take x cube by 3 common. We'll have here log of x minus 1 by 3 plus c. Check here. I've taken this common, so we'll have 1 by 3 left over here. That's the answer. 3 mark. Find this sin square upon 1 plus cos x integration. Very simple. Write sin square as 1 minus cos square x divided by 1 plus cos x. Integral formula we have. This is going to be what? A square minus b square. For that we have a minus b and a plus b. A plus b will be cancelled. I'll have only a minus b left. So 1 minus cos x dx, answer will be x. Answer will be, 1 second, x minus sin x plus c. For 1 we have x, for cos we'll have sin. The minus sign will remain as it is. Next, find the integration of this. Okay, this is a good question. Integrated bacha, we have e power x outside, x minus 3 upon x minus 1 the whole cube I have in this case, whole cube, and dx. Check. E power x, x minus 1 minus 2 upon x minus 1 the whole cube. Separated over here, okay? Separated over here. So you'll have e power x, x minus 1 upon x minus 1 the whole cube minus 2 upon x minus 1 the whole cube dx. This makes sense. Cancels this with square. We'll have e power x 1 upon x minus 1, okay, whole square, minus 2 upon x minus 1 whole cube, right? Integral with dx. This is the form f of x. This is f dash of x. Cross check please. Derivative of x power, x minus 1 power minus 2 is what? Minus 2 times of x power minus 3, right? X minus 1 power minus 3. This is f dash of x. Answer will be e power x f of x. So this here plus c. That's your answer. Done. Next is your 5 marker. The end of 3 marker is done. Next is 5 mark. Over here the the particular functions of your indefinite integral has a big role. So we have to pay attention to those, and to solve these questions we need the application of substitution of different category. So we have x square plus a square. So x square plus a square, when we have, we usually take this as a substitution, x as a tan theta. Since we'll use it, I'll write this also, x by a as tan theta. We'll use it later. We'll use this later. Okay. Substitute it over here. So I had the integration given like this, x square a square dx. Substitute now. We'll have the derivative as derivative will be bacha dx equals to a sec square theta d theta. So we'll get a sec square theta d theta divided by a square tan square theta plus a square. Correct now? Yes. Check. So I can take this a square common, keeping this as it is. I'll take a square common and outside the root. I'll end up with a outside, and I have over here tan square theta plus 1. Correct? Check carefully. I have a square I've taken out and common, so it becomes a square comes out of root as a. Tan square plus 1 is what? Sec square. Continue. So integration is now sec square theta d theta divided by sec theta. Correct, because sec square in the root will be sec theta. So this is cancelled. I have only sec theta d theta left. This answer, this integration is a special one. Log of sec theta plus tan theta plus c, of course. Sec theta we don't have, but tan we have. Tan theta is x by a. Tan theta is x by a. What about sec? So sec square theta is given by 1 plus tan square theta. So sec theta will be root of the same things, 1 plus x square by a square. Simplify further. You'll have sec theta as, check, a square plus x square in the root upon a outside, because if you take root of a square in the denominator separate, it becomes simply a. Now sec also we have, tan also we have. Substitute back over here. So log of sec, first we can write for tan first, so x by a we'll write first, and then we'll write the sec well apart. So we'll have over here a square plus x square by a plus a constant c. You can see here I'm making a form over here. So log of x plus this root divided by a plus c. Separate this log a by b form. So log of x plus root of the same root minus log a plus c. This log a is also a constant and plus c is also a constant. Sum will make another constant. So you have the answer as log of x plus a square plus x square plus a constant k. This is your integration. Log of x plus a square plus x square plus the constant k. Please check. This is the result of your integration. Now we're going to use this question. X square plus 2x plus 2. We have to integrate this, no? 1 upon x square plus a square plus 2. Correct. So we can make this perfect square. We'll have x square plus 2x plus 2 is there, right? 2x plus 2 is there, not this. 2x plus 2. So we get 2x plus 1 plus 1. So I get 1 upon x plus 1 the whole square plus 1. This will become x plus 1 the whole square. So what was the integration? Log of the x. So in this case we have x plus 1 in place of x and plus root, whatever the root was. Here we had x square plus a square. The same comes in the root over here. So we'll have the same root. X square plus 2x plus 2 plus the constant k or c of your choice. K or C of your choice. That's your answer. Have a look. Moving on. Find the integral of 1 upon x square minus a square with respect to x, and hence find the hence evaluate this value. Okay. X minus a, x plus a dx. This is what they are asking. The x square minus a square is given by x minus a, x plus a. That's what they are asking. This is the form of partial fractions. Get the result. X minus a, x plus a equals to a upon x minus a plus b upon x plus a. Okay, compare this. A times of x plus a plus b times of x minus a divided by same thing. Correct? Right? Compare these two now. So same approach you're going to use. When x is going to be a, what will happen? This will become 0. So you'll have 1 equals to a times of 2a. So value of a is nothing but 1 upon twice of the small letter a. When I put x as a, small a. When you put x as capital A actually, sorry, minus a actually, you'll have value of b as minus 1 upon minus 2a. Value of b will be, check, minus 1 upon 2a. I'll show you. Put x as minus a. This will be 0. This will be 0. This will be minus a minus a. It will become minus 2a. We have on this side 1. So minus 1 upon 2a is the value of b. This integration now actually is integration of 1 upon 2a, the constant, and we have x minus a dx and plus minus 1 upon 2a integration of x plus a dx. So this becomes 1 by 2a is a constant outside. This will be ln of x minus a, and we have a minus sign over here because of this minus. So ln of x plus a plus c. Combine this 1 by 2a ln of x minus a upon x plus a plus c. Plus c. So for the second part, this will be given as, in this case, integration of 1 upon x square minus 4 square dx is there. So you'll have x minus 4, 1 by 2 into a will be 8 ln of x minus 4 upon x plus 4 plus c. This is your answer. This right is your second part's answer. A 5 marker. A 5 marker. Please check. Okay. Next one. Find the integral of the same form. Check here. These two are the same form. 1 upon x square minus a square. Asked in March 2022. This is July 2022. Okay. Same form. So this part is same as question 25. Okay. What about this part? 1 upon x square minus 8x plus 5 dx. Try to make the perfect square over here. So we'll have x square minus 2 into 4 into x, that is 8x, plus 4 square minus 4 square, and plus 5 is already there. Check. I've written the same thing over there. This gives me x minus 4 the whole square, and this is left minus 16 plus 5. How much is that? X minus 4 the whole square minus 11. Now keep it back in this. 1 upon x minus 4 the whole square minus 11. So 11 can be written as root 11 the square. The formula is 1 by 2a. So 2 root of 11 ln x minus 4 minus root 11 divided by x minus 4 plus root 11 plus c. X minus a, x upon x upon x plus a. X in this case is x minus 4. Please check. Yes, next. So 26 was the last of your 5 marker. Next we have 6 marker to deal with. Let's try. Okay. The King's rule property, we are looking for 0 to a. If you change the x to a minus x, the integration remains same. We'll go about that and then find the value of this particular integration. Okay. So what do we have over here? Check. Proving the property first. So the property is that you're gonna rule change x from. Okay. Wait. You write the LHS first. I write the LHS first. I equals to 0 to a f of x dx. We're going to use some type of substitution over here. X as a minus t. X as a minus t. Do everything. Change the limit, derivative, everything you change. You'll get dx equals to minus dt. First thing is this. Limit you change. When x is 0, t will be what? A. X is 0 means t comes here. This is a. When x is a, t will be 0. So limit is changed. When x is a, t is 0. So limit is changed now. I becomes equals to a to 0. X is what? A minus t. So f of a minus t, and this is nothing but minus dt. Write the minus sign outside. This is what? Minus dt, no? Write the minus sign outside. We know very well we can use the minus sign to reverse the limits. We'll do that. So 0 to a f of a minus t dt. We also know that since we have any integration, okay, in definite integrals, I can change the variable anytime. Okay, so let's do that. So I'll get what? I equals to, I'm changing the variable to x to a t to x, 0 to a, and now I'll have changing t to x. So I'll get a minus x and d of x. Be careful. I have taken over here substitution. Okay, and this over here I'm doing what? I'm doing changing t to x. This is called as properties of integral. Okay, we're changing the variable. We can do that. So I can change x to t or t to x. I did that. And if you do see this is nothing but same as RHS. This was your LHS. Start from LHS getting the RHS. Starting from LHS getting the RHS means the given integration is proven. Now the question. Let's do one thing. Let us do one thing. Right here. This as the integration I and equation 1. This part here I'm talking about. Okay. Now I'll rewrite this King's rule. What is this going to be? X replaced as sum of limit is pi by 2 plus 0 is pi by 2 minus x. When you do that, sign will become cos. I hope you know this. Sign of pi by 2 minus x is cos, and same thing, cos of pi by 2 minus x is what? Sine. Complementary ratios. So this integration if I rewrite, I'll get what? Same limit goes 0 to pi by 2. And sine becomes cos, and here sine becomes again cos, plus cos becomes sine, dx as it is. Check, this is my equation number 2. Now if you add equation 1 and 2, if you add equation 1 and 2, you'll get I plus I, which is 2i. I plus I is 2i. Check the RHS side, limit is same and denominator is same. Limit is same and the denominator is same. Sine plus cos in the root. So sine x in root plus cos x in root, dx is also same. Here we have root sine x, here we have root cos x. Same thing. Root sine x plus root cos x. So we get this whole thing cancelled. I have 2i integration 0 to pi by 2. Integration of dx, which is what? X 0 to pi by 2, which is what? Pi by 2 minus 0. So I get the value of 2i is pi by 2 value of I is pi by 4. I know many of you might know the trick that difference of the limit by 2 is the answer, but it is a subjective question. We have to solve all the steps. It is a subjective question. We need to show the steps over here. Okay, 27 is clear. Next, this is clear. 28. Prove that minus a to a f of x dx is this when it is an even function, 2 0 to a fx dx, and 0 if f is a odd function. Okay, start from here. So I'll start like this. Minus a to a f of x dx can be written as, check, minus a to 0 f of x dx plus 0 to a f of x dx. I'm breaking the limits, minus a to 0 and 0 to a. This is my equation number 1. Also, I'm assuming this as the integration I1. So what I have for I1? Minus a to 0 f of x dx. In this I'm going to use a substitution. X as minus t. X equals to minus t. X equals to minus t is my substitution. Differentiate, you'll get dx as minus dt, and the limit also will change. We'll check here. Then x is minus a, t will be a. When x is 0, t will be 0. Because I'm looking for x equals to minus t. So my integration I1 will be rewritten as a to 0, the lower limit and upper limit, a to 0 t value, f of minus t, and dt is negative, I can take it outside, no? Dx is dt means I can take the minus sign outside. Same, use the negative sign to change the limits. 0 to a f of minus t dt. This is very, very important. This step is extremely important. Now from here onwards, things will be very, very easy. Let me take you to the odd and even function definition. Odd function, even function. So odd function are those functions where f of minus t is actually equal to f of minus f of t. F of minus t, one second, f of minus t is equals to minus f of t. This is your odd function. Okay, and for even function I have f of minus t is simply f of t. So from here I can have two cases for I1, case 1 and case 2. Check here. If it is even, I'll get this as I1 equals to, I1 equals to 0, integration remains same, 0 to a f of t dt. And if it is odd, I'll get the I1 as 0 to a minus f of t dt. Okay, now we know that we can replace the variables anytime. I can change the variable to t to x, no problem. X. Okay, now let me call this as equation number 2. Use 2 in 1. Use equation 2 in 1. Now we'll have two cases. We'll have again two cases. For odd function, for even function. For odd function we'll have negative I1. So if you combine 2 in 1, this will become negative of this 0 to a fx dx minus 0 to a fx dx. I'll have the I1, I'll have I equals to 0 in that case. When you put here negative value, this and this will cancel. You have this as 0. Okay, and over here in the case of even function, they'll be same. 0 to a fx dx 0 to a fx dx. Over here 0 to a fx dx. So the result will become I equals to twice of 0 to a fx dx. The statement is proven for even and odd function. Please check. It's proven, sir. For even and odd, both I have proved. Yes, no problem, no problem, sir. Have a look. Next. Prove that 0 to a fx dx is 0 to a f of a minus x. Okay, this part I have not done, bro. Over here, sorry, this part I forgot. 1 second. Check here, this is odd and this is even. Combination of odd and even is what? Odd only. Answer will be 0. Answer will be 0. This is odd, this is even. Cos of minus x is plus cos x, and sin of minus x is minus sin x with the power odd. It will become odd only. So odd and even is odd. Answer is 0. Next, this I already proven right now. The King's rule. What about this? Same property. If I take this as I, my equation number 1, I can write this as I equal to same thing. Cos will become sine power 5x. Here sine will become cos power 5x plus sine power 5x dx. Limit remains same. Add equation 1 and 2. You'll have twice of I integration from 0 to pi by 2. This will be what? Sine power 5x plus cos power 5x. The numerators being added, and we have over here same thing, cos power 5x plus sine power 5x dx. This whole thing is cancelled. So twice of I equals to integration of dx 0 to pi by 2, which is x from where to where? 0 to pi by 2, which is what? Which is 2I equals to pi by 2 minus 0, which is pi by 2. I is pi by 4. This derivation over here is done. Please check here. This part. Okay? No. Yeah. Done here. Okay? This part is the derivation's end. Great. The last question, same definition. You can see this is very favorite question of your board. March 23, May, and again March 22. So this question repeats all the time. Same property. The result of this will remain as it is. I equal to 0 to a, the given form root x, root of x plus root of a minus x dx. This is your equation number 1. Apply the King's rule. You'll have you will replace x by a minus x. So you'll have 0 over here, a over here. This will become a minus x upon. This will be also a minus x. And this will be what? A minus of a minus x dx. A and a is cancelled. It becomes again root of x. This whole thing becomes again root of x. Please check. Root of x. Okay. Now add the equation. This is equation number 2, right? So add 1 and 2. We'll have twice of I over here, and we'll have 0 to a. If you add these two sum, will get simply cancelled. You'll have only dx left, because root of x plus root of a minus x, here also root of x plus root of a minus x, they'll cancel, only dx is left. Integration will be what? X from where to where? 0 to a. The limit you check, a and 0. So you have 2I equals to a minus 0. So I equals to a by 2. This is the end of your session on your PYQs of the chapter integration. With the chapter application of integrals, right? So we all know the kind of question that comes from this particular unit will be your 1 question 5 marker. So we'll have to again solve similar type of problems, right? The first thing first is going to be our weightage. Have a look. So we all know the weightage of this chapter looks like very simple. 1 question 5 marks. We're gonna deal with that. Next up, your content index. If you check what is there, sir, I have planned total of 12-13 questions for you, PYQs and most important questions, which will help you prepare the chapter in the best way possible. It has all the variety of questions taken into consideration. Let's continue. So first question over here we have is, find the area enclosed by the circle x square plus y square equals to a square by the method of integration. Okay, so of course we know it's a circle, means pi r square is the area, but we have to get the result using the integration method. It's a PYQ of 2023. Please check. So circle looks like this, right? And it's not symmetric, but understand it is going to be a symmetric figure. Okay, this will all be what, bacha? A minus a, sorry, plus a minus a and minus a, right? The radius is always a in the circle. In the case of ellipse, it becomes a and b because they are two different axes, major and minor. Okay, so I'm looking to get the area of this. Let me divide this into 4 parts: part 1, part 2, part 3 and part 4. So if I want to get the area of the circle, I can write this as 4 times the area of part 1. 4 times the area of part 1. Okay, sir. So how do you find area of part 1, sir? Very simple. Integrate under this curve. What is that curve, sir? The circle's curve, which is given as x square plus y square equals to a square. Now to integrate this curve, I'm going to take what? Y dx, and the value of x from where to where? From 0 to a. From 0 here to a here. Okay. So what is the value of y over here? We're going to find it out by making the y as subject. So we'll have y square equals to this, a square minus x square, and y equals to root of a square minus x square. Now we can put the value of y back in our integral. We'll have area of the part 1 as integration of y dx, right? So integration of a square minus x square 0 to a dx. We all know this is the integration of what type? Particular functions. For that we have the result, if you remember, x by 2 times the same root comes a plus sign, a square by 2, a is a square, so like this, the same a square over here into sine inverse of x upon a. The limit is from where to where? From 0 to a, bacha. Okay, if you put a in the first term, it becomes 0. Check here, a square minus x square. X, if you take as a, it will become a square minus a square, so whole thing is 0. If you put over here, you'll get what? A square by 2 sine inverse of a by a, sine inverse of 1. A by a is 1. Now when you take the lower limit, when you put 0 over here, 0 by 2 is 0, everything becomes 0. So first term will be 0 when you put the lower limit. Over here, sine 0 by a is sine inverse of 0. Sine inverse of 0 is 0. Again, that will also be 0, sir. So we have this so far as a square by 2. Sine inverse of 1, sir, is pi by 2. So I have the answer as pi a square by 4. Now this is the area of your part 1. Area of the part 1 taken as per figure, you can see. Taken as per figure, you can see. So basically in this result, I can write this as 4 times of area of part 1 as pi a square by 4. 4 and 4 cancels. My result is, sir, pi a square. Square unit of course. A was the radius, and that we all know is the formula of area of a circle using the method of integration, and we used here particular function of this category. I hope you know the formula of the integration of root of a square minus x square. A very simple question for 5 marks. Next, find the area enclosed by the ellipse. Same result, exact same result. This also is a PYQ. So first, we know that very well that this will be of the same form. In this case, we'll have a major and minor axis, but they will be symmetric in nature. They will be symmetric in nature. So check. Okay. In this case, we'll have bacha here 0 and a, because a is the major axis and this will be the minor axis as, as b. So I'm going to do the same thing, make the subject as y, and this part integration will be what? I. So it will become what? Y dx from where to where? I can take from 0 to a only. From 0 to a only. This will be my area of part 1. Area of part 1. Okay, chali. So once we have this, you can see here it will be symmetric in nature. Okay, AB, this will be minus A, right, bacha? This will be minus B. Okay, so this also is equal to this one, and they are all equal in nature. So I can just simply multiply this area of part 1 with 4 and get the required result. Okay, chaliye. So how would you find y in this case now? Y will be same result, y square by b square equals to 1 minus x square by a square. Continue, I'll get a square minus x square by a square. So I get y square as b square by a square, and the bracket will have a square minus x square. So this will give me the value of y very simply as root, if I take b by a, same thing will have here a square minus x square. This is the y value we're going to use in the integration. Okay, limit, I hope this is clear. 0 to a, I have taken 0 to a by bacha because I have taken the given function in terms of the variable x. Okay, y is in the terms of the variable x. This y here is a function of x, that's why the limit is taken for the variable x. Okay, substitute back for the part 1. I'll have the area as there's a constant b by a, I can take it outside. Constant is what? 0 to so limit is 0 to a, integration of the same thing. All right, with dx we know this result very well. Same formula, x by 2, root repeats a square minus x square plus a square by 2 sine inverse of x by a. The limit is from where to where? 0 to a. Continue please. B by a we have. Put back a, this will become 0. We know that. How, sir? Because a square minus a square will be 0, right? Now for this you'll have a square by 2 sine inverse of a by a is 1 plus, sorry, not plus, minus, no, minus here, right? It's a lower limit, so minus sign, minus. Check the lower limit. When you put 0, this will be 0 by 2 into 0 into everything is 0, and over here also 0, right? Sine inverse of 0 is 0, everything is 0. So my integration of for the first part is b by a. I have a square by 2 pi by 2, so this will cancel one of the a over here, and my answer is pi a b upon 4. Pi a b upon 4. So I'm looking for the ellipse, right? Area of ellipse. So area of the ellipse is given by 4 times of the area of part 1. So 4 times of pi a b by 4 cancels. So pi a b square units. So they do ask questions like this, deriving the area of ellipse, area of circle, or combination with parabola and straight line. We'll see all the different types of questions. Okay, don't worry, after this session you'll be very much comfortable solving any questions coming your way in the chapter application of integral. Okay, next, find the area of region bounded by the curve y square 4x y minus y axis. Okay, this is the combination of straight line and parabola. Symmetric about x axis, right? Okay, and y axis, so this one, this is the y axis, and the line y equal to 3. Excuse me, y equal to 3 line is over here. Which is my required area, bacha? This right here is my required area. People, you might think or understand that this will be the area over here somewhere. No, this says with y axis. Okay, with the y axis over here, there is no x, so you're not gonna make this, you're not gonna join this part. Okay, that's not there because they have mentioned very clearly y axis, so that is my required area. Okay, so this is my shaded region. How would I get this? If I call this to be, let's say, area A, so area A will be given by bacha integration of, let's say the limit is there for y, right? 0 to 3. Check here, 0 to 3. So right here limit 0 to 3. Since the given function limit is in terms of y, I'll write x as subject, so x dy, right? Because what is x actually? X is the function of the variable y. X is the function of the variable y. Let's get the x value from here. So we have y square equals to 4x. Very simple, x will be y square by 4. No problem over there. Substitute back in this integration. A will be integral from 0 to 3. 1 by 4 is a constant kept outside. Integration of y square dy. Okay, so we'll get here as y cube by 3 from 0 to 3. So 1 by 4. Put the value. Y cube is 27 by 3 minus 0. When you put 0, it will be 0. So I have the answer as 27. So 1 by 4 into 9, right? 27 by 3 is 9. So my answer is coming as the required area is nothing but 9 by 4 square units. 9 by 4 square units, please check. Okay, that's the required area that we have. Okay, the shaded region that I've mentioned as area A. Clear? No problem. Next question. Area bounded by the curve y equal to cos x between x to 0 and x to 2 pi. As I said, I have mentioned all the different types of questions. You can see it's pretty evident from the given statement. Okay, cos x curve. Cos x from 0 to 2 pi looks like this. Okay, this is 0. This right here is your pi by 2. This will be your pi. This is 3 pi by 2. And this here is your 2 pi. Okay, so if you break down into 4 sections, you'll have, check here, you'll have section 1, section 2, section 3 and section 4. Now there is a way to do this integration as area of part 1 plus area of part 2, right? Area of part 1 plus area of part 4 actually, and plus modulus of area of part 2 plus 3. Why that? Because 2 and 3 will be negative. I have to make modulus to get the area, right? We cannot take the negative as the area. So I have to add it like this. Otherwise, simply you can check here. Actually, area of part 1 is equal to area of part 2 is equals to area of part 3 and is equals to area of part 4. All these sections will have equal area. So simply find the area of one of the section, multiply by 4. Isn't it simpler and actually less calculative in nature? Yes, let's try that. So I'll get area of the part 1 as integration of what? The function here is what? The cos x. So cos x dx, the limit you check, 0 to pi by 2. 0 to pi by 2. Okay, I'll get what? Integration as sin x from 0 to pi by 2. Value you check now, sin pi by 2 and sin 0 is 0. So 1 is the answer for area of the part 1. Area of the whole thing, the whole curve, okay, the required area A, okay, will be part 1 times of 4. Part 1 times of 4, because they are all equal in nature. Answer is what, bacha? Very simple. 4 into 1. Answer is 4 square units. Answer is 4 square units. Please check. Does it make sense to all of you? Yes? Okay. Next, find the area enclosed by the circle x square plus y square equals to a square. We just did this question. Remember, this is a repetitive question, came in March paper as well. Same as the answer of question number 1. Okay. Why did I show you to show the same question over here? Because you can see the trend of the problems, okay, that they are repeating in nature. Check here. This was the question, right? Yes. Got it? Exact same question has been repeated. Next, sixth one. Same question. Check here. 16 June, 18 June and 22 April. The question has been asked again and again. Okay, same approach. Okay, you write y's value as b by a integration what? Sorry, root of a square minus x square. Integrate this from where? What is it? So you'll have the answer as required area will be 4 times the integration of b by a 0 to a this thing dx. Your answer will come as pi ab. Same result. Okay, question number 2 basically. Next, find the area of region bounded between the ellipse. Now in this case they have given the values over here, so we'll again solve this question, no problem. All right, sir. So let's simplify this. Y square by 9 equals to what we have, 1 minus x square by 16. We'll get the same result, 16 minus x square by 16. So I get value of y square as 9 by 16 and not root. We'll have the bracket first. So bracket of 16 minus x square. So we get the value of y as 3 by 4, 4 square minus x square in the root. Now integration will become what? The limit, if you check this, the ellipse will be like this. Your major axis is what? Your major axis is what? Please check here. 16. It means this value will be 4. This will be 3. So integrate from where to where? From 0 to 4. 0 to 4. And you have to multiply here with 4. And the constant will come as it is 3 by 4. This is the required area of the ellipse. Okay, I'm writing this as area of the ellipse. Let's say E. 3 by 4 I've taken outside. Integration of 4 square minus x square, and we have dx. Okay, so area of the ellipse will be what? Please check. This 4 and 4 is okay. We'll keep that later only. Okay, 4 by 3, 4 is a 12 by 4. Okay, and integration of this will be what? X by 2. So x by 2 into the same plus a square by 2 means 4 square by 2 sine inverse of x by 4. From where to where? From the limit 0 to 4. Okay, this is 3, right? Area of ellipse. Check here, put the value 4, will become 4 square minus 4 square. So 0 will be what? 4 square is 16 by 2 is 8. Sine inverse of 1. 4 by 4 is 1. Minus lower limit is both 0. Okay. 3, I have 8, pi by 2, 4. What's my answer? 12 pi square units. This is your area of the ellipse E. Got it? Yes. Same approach, of course, with the values this time. So the question might come in this way as well. That's why I've taken the different variety which is possible. Okay. Find the area of the region bounded by the ellipse. Now in this case, the major axis is y-axis actually. That's the only difference. So this is the major axis. Check here. This is your 2 and this right here is 3. Okay. So your choice. If you want, you can continue, change this time subject to be x or y, your choice. But we can go with y only. So I'll have here, check this out, y square by 9 equals to x square by 4 minus 1. Sorry, 1 minus x square by 4, excuse me. 1 minus x square by 4, no? 1 minus x square by 4. So this will be what? 1 is outside. Mistakes, excuse me. I'll get 4 minus x square by 4. So we'll have 3 by 2 root of 2 square minus x square. This is the value of y. Okay. Now integrate this to get the area of ellipse as 4 times this integration. 3 by 2 is outside. Integration for what? For same thing. I'm looking for x, no? So check here. This is the x is the variables means 0 to 2 only will go, not 0 to 3. If you want to use 0 to 3, you have to make this as a subject as x. Okay, right now subject is y. Okay, I have to make the subject x. In that case there will be different value. 0 to 2, same limit, same integration. 2 square minus x square dx. Check. 12 by 2 is 6. 12 by 2 is 6, and we'll have the integration as it is, x by 2 the same limit, and plus 2 square by 2. How much is that? 2 square by 2 into sine inverse of x by 2. From where to where? From 0 to 2. So 6, this is 0, gone. 2 square minus 2 square is gone, so 0. And too many cuts in this problem. I'll just change that. Okay, 1 second. X square, 2 square. Okay, this is x. Okay, x square. So I get this as 0, and this will be what? 2 sine inverse of 1 is pi by 2, and this is all 0. Cancel. Answer is 6 pi square units. The area of the ellipse. If you want, you can solve this question in this way as well. If it was a MCQ, we can do A value is 2, B value is 3, answer is pi AB, so 2 into 3 is 6, okay. Formula approach, if you need, the answer is 6 pi. If it is a 1 marker, 2 marker like that, but this is a 5 marker, we have to do using integration only, okay. Next, find the area lying in the first quadrant and bounded by the circle, first quadrant only. Circle is like this. First quadrant means from here to here. What is the R? R is 2, okay. R is 2 and the line 0 to x, okay, same thing. Means they can ask you to 0 to x equal to 1 also, but they have not asked that. They have given the limit to be 0 to 2 only, okay. What about this? I can write this as y. Y will be what? Y will be 4 minus x square in the root. So y will be 2 square minus x square, okay. I'm looking for only this part's area of part 1. We'll have this as from where to where? 0 to 2. This is nothing but 2 square minus x square dx. Integrate. So we'll have x by 2, same root repeats, okay, plus 2 square by 2 sine inverse of x by 2 from 0 to 2. What is this? This is 0. This is going to be 2 times of pi by 2. Sine inverse of 2 by 2 is 1. So pi by 2 minus all 0. We get this is cancelled. Answer is pi square units. This is the area of the part 1. Only the first quadrant they have asked, okay. Only the first quadrant and the circles between the limit 0 to 2, okay. This case the radius is also 2, that's why no problem. Otherwise, if they ask us 1, then we have to go only till this point, okay. Then the limit will be changed. Please check. Question number 10. Find the area bounded by the curve. Okay. Modulus is there. Modulus will change sign at x equals to 0. So if I take this, if I define the function again, I'll have here x more than 0, you'll have this as x square, and for x less than 0, you'll have this as minus x square. So the curve will be like this, x square minus x square. The limit is what? Minus 1 to 1 from here. Minus 1 to 1. Okay. So my required area is what? This is the required area. This is the required area. Okay. Alright, sir. So we have to use the modulus for the negative area part. This is the negative area. I have to use modulus over here, and the other side will be positive only. Okay. So let's break it down. We can integrate it like this. As I've already taken this as minus x square, so we don't have to write modulus also. So let's integrate to get the final area. Integrate will be what? From minus 1 to 0. I'll simply take as minus x square dx plus 0 to 1 x square dx. Understand this very clearly. If you want to use modulus, don't use minus sign, because what you have done already is you have already made it as positive by taking the x square. Okay, it's your choice. Yes, nothing is wrong. Let's continue from here. Integration of this will be what? Minus x cube by 3 minus 1 to 0, okay, plus x cube by 3 0 to 1, okay, 0 to 1. Now take the minus sign outside. We'll have here minus 1 by 3, sorry, excuse me, we'll have this as 0 the upper limit, this comes a lower limit. You'll have here I've taken the minus sign outside, right? Okay, so it'll be simply positive only, no, 1 by 3 minus 1 by 3 actually, and over here we'll have 1 by 3 only, no, lower limit is 0. Check this out. We'll have the value as minus 1 by 3, okay, plus 1 by 3. All right, 1 second. Yes, plus 1 by 3. Since it is negative, means we have to use the modulus sign over here. Correct? No, the area will be negative because it is below the x-axis, so we have to use the modulus sign. You get here 1 by 3 plus 1 by 3. Answer is what? 2 by 3 square units. Answer is 2 by 3 square units. Next, find the area of the region bounded by the line y equal to 3x plus 2, then x-axis Okay, this curve. All right. When x is 0, y is 2. X is 0, y is 2. So this is the point. When y is 0, it is going to be minus 2 by 3. Minus 2 by 3. And I want from minus 1 to 1. So this is minus 1, let's say. And this is going to be plus 1. So my area under consideration will be this one. This area is negative area. And this area right here is the positive area. Right? Means minus 1 to 2 by 3, minus 2 by 3, and minus 2 by 3 to 1 is the 2 parts. Okay? So the required area A will be integration of what? Of course, under the modulus, integration of 3x plus 2. Okay, from where to where? From minus 1 to minus 2 by 3, or of course with dx, and plus minus 2 by 3 to 1, same thing, 3x plus 2 dx. Okay, this we don't need the modulus because it is going to be always positive. This is going to be positive, 3x plus 2. Okay, clear. Let's continue with both the parts. Alright sir, let's start with this part first. I'll take this as my part 1 of integration, and this is part 2 of the integration, I1 and I2. So let's continue the first part over here. I1 will be, so we'll have integration from where? 3x square by 2 plus 2x. Am I right? 3x square by 2 and 2x in the limit, what is it? Minus 1 to minus 2 by 3. Put it back. I have the values over here as 3 into, upper limit you're going to put, no? 3 by 2 we'll have here into 4 by 9. Correct, no? 4 by 9. And over here minus 4 by 3. Comes the lower limit, minus sign. Put this minus 1, you'll get what? 3 by 2. And over here you'll have minus 2x. Am I right? Please check. So far the calculation is looking good. Let's continue over here. We'll get this is 3 by 3 is cancelled. 2 2s are 4. I can take the LCM now. 2 into, I have taken as x. So no, it's going to be simply 2 into 1, right? So minus 2. Okay. So we have this calculation as 2 by 3 minus 4 by 3 minus 3 by 2 plus 2 equal to, take the LCM, you'll have LCM as 6. 3 2s are means 2 2s are is 4, 3 3s are 3 2s are 6 means minus 8, 2 3s are means minus 9, and plus 1 6 are means 6 are 12. I get the value as 17 and 16, right? So my answer is coming as I1 is equals to minus 1 by 6. 12 plus 4 is 16, 8 plus 9 is 17, negative. So minus 1 by 6, but there is a modulus over here. You can see this is the modulus, okay? So I'll put a modulus over here. Answer will be 1 by 6. This is your part of the area 1. Square units is the area, okay? Next is what? Same thing under the limit, minus 2 by 3 to 1. So I2, minus 2 by 3 to 1. Excuse me, 1 I mean 3x plus 2 dx. Integrate now, we'll get 3x square by 2 plus 2x from where to where? From minus 2 by 3 to 1. Substitute back the value. 1 you put, 3 by 2 when you put 1, plus 2 when you put minus sign for the lower limit. You'll have here 3 by 2 as it is. For this you'll have 4 by 9, and there's a plus sign, so we'll get what? Minus 4 by 3 actually, minus 4 by 3. So it'll be a minus sign only, no? It'll be a minus sign only, minus sign, right? Please check. Minus 4 by 3 and plus 4 by 9, correct. 3 3s are 9 and 2 2s are 4. LCM you check now. 3 by 2 plus 2 minus 2 by 3 and plus 4 by 3. LCM will be what, dear? Same thing, 6. 2 3s means 9. Again 12. 3 2 3 are 6 means 3 3s are 9. And 1 6 are 2 6 are 12. Minus 2 3 2s are, we have 3 2s over here. So we'll get 2 2s means minus 4. And 3 3s means 4 2s is 8. Check. 12 plus 8 is 20 plus 4 9 is 29. Minus 4 will be 25 by 6 square units. 29 minus 4 is 25 by 6. I'm looking for the required area A will be
I1 plus I2. So I had 1 by 6 plus 25 by 6. So 26 by 6, which is 13 by 3. 13 by 3. So this is my answer, 13 by 3 square units. This is your answer. Please check. Okay, from here to here, if you add both the areas, green and the blue one, the answer will be 13 by 3. Check the calculation one more time. Yes. Find the area bounded by the curve y equal to sin x between x0 and x2 pi. Okay, something which is very similar to your PYQ, very, very important. Sin x will go from here. Excuse me. Okay, not looking perfect. I can do better. This is a little bit better. 0, pi, 2 pi. Since this is area 1 and area 2, and area 1 is equal to area 2, right? No, area 1 is equals to area of the part 2. Got it? So how do you find the area of part 1? Very simple. So your required area will be given by twice of the area of part 1 first of all, and you will find area of part 1 in this fashion, twice of integration of what? Sin x, from where to where? From 0 to pi, with a dx of course. With dx of course. Check. So area will be twice of minus cos of x 0 to pi, twice of, put here minus cos of x is what? Cos pi. Cos pi will be what, bacha? I'll write cos pi only first. Then comes here minus sign, and we'll have here minus cos of 0. Okay, twice of cos of pi is what? Minus 1, and cos 0 is what? 1. Cos 0 is 1. I get the value as twice of plus 1. Here minus 1 into 1 is plus 1. Here also plus 1. Answer is twice of 2. We get this as 4 square units. 4 square units. Check. Okay, 4 square units. That's your final answer. Okay, got it? Next. Okay, so your last question, 13th one. Find the area bounded by the curve. Alright, sir. X cube is like this. From where to where? Minus 2. Minus 2 to 1. So we'll go with this negative area and positive area. So we have to do what? We're gonna break the integration. X cube integration from where to where? Minus 2 to 0 will be in the modulus, and plus we'll have 0 to 1, the x cube integration in the positive side, so no need of modulus. Okay, check. We'll have here as x power 4 by 4, and we have here minus 2 to 0 in the modulus. Same way, x power 4 by 4, this is not modulus, okay, this is just the integration from where to where? From 0 to 1. Okay, so I get this as upper limit will be what? 0, and this will be what? Minus of, put the value, I get 16 by 4. Okay, over here we'll have simply upper limit will be 1 by 4, lower limit will be 0. Okay, I get this as modulus of minus 4 plus 1 by 4. I get this as 4 plus 1 by 4, which is same as 16 plus 1, 17 by 4 square units. Please check. This is your final answer. Okay, so this is the end of your lecture. Chapter is differential equation. 3 questions will come, 1 marker, 2 marker and 5 marker. 1 marker is simple ones on the order and degree, most of the times that's what they ask. 2 marker, it will be either on variable separable method or some types of substitutions, and the 5 marker will be usually on the linear differential equations of either general or particular form, right? So the weightage, if you see, will be like this. You have total of 3 questions, as I said, 1 1 1 means on the MCQ side, or 1 marker, or this also comes in fill in the blanks sometimes. So 1 marker, 2 marker and 5 marker will be there. Total will be 8 marks from this chapter. Again, an easy and important one.
First, start with the MCQ. So what we have over here in the MCQ. So MCQs, as I said, the questions are not only MCQs. Usually the questions are asked in your 1 mark category of fill in the blanks. Okay, usually they ask in fill in the blanks. That's why the question is like this. You can see the order of the differential equation they're asking. Order represents what? Order represents your highest derivative. Highest derivative. In this case it is 4, so order is 4. In this case it is 4, means order is 4. Next what? Question number 2. Find the order and degree if defined of the given differential equation. So this is, please check here. Order represents, very simple, the highest derivative means 3. What about degree? We can have the derivatives in terms of only polynomial function. Here we have exponential function. It's written as e power dy by dx. When you have this bacha, then the degree will never exist. Means there can be exponential function, but it cannot be of the exponential function of derivatives. Derivative has to be only of the form of polynomial. Only polynomial function of derivative should be the case. But this is missing. That's why degree is not applicable or not defined. Does not exist. Degree does not exist. Got it? Next. Question number 3, again 1 marker. The degree of the differential equation, you check over here. In this case we can do that. So highest order is what, bacha? This is the highest order, and the power of that will be the degree. Means highest order, or basically the highest derivative, index of that particular derivative is called as degree, right? So your degree will be 1. Highest order is what, bacha? Highest derivative is 2. So order is 2 and degree is 1. Next, they didn't ask us order, but I just wrote it for your understanding. Next, to find the order and degree of the differential equation. That's the type of question that they keep asking. This is your, again, PYQ. You can check over here. Order and degree. Order is what, sir? Please check. Order is the highest derivative. So order is 2 and degree is, sir, power of this 3. Wrong. Please check. Order is 2, degree 3 is wrong, because we have sine function of derivative. I said it should have only polynomial functions of derivatives. In this case we have trigonometric function. It means degree will not exist. The answer for degree is what? Does not exist. Degree is not defined in the case of functions other than polynomial of the derivative. Okay, let's move on to the subjective questions now. Before that, I have one more fill in the blanks of the different category that they keep asking. This is not a PYQ, but this can be a expected question this year. What is that? The number of arbitrary constant in the general solution of a differential equation of 4th order. Means they're saying that 4th order means you have power 4. You have power 4, or basically 4th derivative is present in the given differential equation. Now if you are trying to solve this, you have to integrate how many times? You have to integrate this once, twice, thrice and 4. You have to differentiate this, you have to integrate this 4 times, and for every integral you'll get a constant C1. This also you'll get a constant C2, C3 and C4. So every time you integrate, you get a arbitrary constant of the integration. So you have total of 4 constants. Your answer will be what, sir? Your answer will be 4. So number of arbitrary constant will be 4, because the order is 4. Okay, so based upon the number of based upon the order of the given differential equation, we'll have the number of arbitrary constants. Clear or not? Yes. The question can be asked in the opposite way as well. If the number of arbitrary constant is this, then what will be the order of the given differential equation? Answer will be same as the number of arbitrary constants. Got it? Let's move on to the subjective questions now. 2 marker and 5 marker. We don't have 3 marker as per your blueprint, so we have only 2 marker and 5 marker. Let's solve these. Okay, first one. This is a 2 marker. Find the general solution of the differential equation given like this. How would you solve it? A very simple question. So we'll have a simple approach to this. I'll move the 1 plus y square on this side, and I'll keep this 1 plus x square over here and move dx on the other side. Integrate now. So we have the answer as tan inverse of y equals to x plus x cubed by 3 plus c. X cubed by 3 plus c. That's your answer. Okay, that's your answer. Okay, 2 marker. This is for 2 mark. Next, find the general solution of the differential equation Let's try this out. So again we have here, this is a LDE, right? This is a LDE. So we'll have dy by dx 2 by x times of y, and x square by x will be simply x. This makes sense to all of you? Y by x, so I'll get 2 by x separately, and this will be simply x. This represents your p of x, and this is your q of x, right? This is a 5 marker. Okay, now first step is to find what? The integrating factor, e power integration of p dx. Please write all the steps in this format only. The integration of what is px? What is it? 2 is a constant, 1 by x dx. This becomes e power 2 ln x. This becomes e power ln x the square. This becomes x square. This is your integrating factor. Now the solution, for that you have to write the standard form of the solution. Since the form is dy by dx, means your y is the dependent variable, so write that over here. Y into the integrating factor equals to integration of what? Integrating factor into the qx dx. I'm writing everything. Let's not skip any step over here, because everything matters, everything carries marks. Okay, so y into what? What is if, sir? X square, integration of x square. What is qx? Is simply x, so right here into x dx. For this we'll have integration as x cube, so x cube will become x power 4 by 4 plus the constant c. I have here y x square. I can bring this x square on this side. I'll get y equals to x square by 4 plus c upon x square. This is your final answer, the general solution. This is your general solution with the help of arbitrary constant c. Y equal to x square by 4 c upon x square. Final answer, 5 marker. Please check. Okay, moving on. Find the general solution of the given differential equation. Let's try this. Same way we can write dy by dx works fine over here, plus 2 by x, y as it is, and here I have x log x. Am I right? Because if you divide everything by x to separate or make the coefficient of dy by dx as 1, that's the form of LDE, right? The linear differential equation. You have to keep the dy by dx in the form of 1. I hope you all know that in your syllabus we don't have the second order differential equation to be solved. We have only one, degree 1, order 1. Okay? Alright, sir. So you can see here, this is your px and this is your qx. Integrating factor, if we just solve this right now, I can skip the steps right now. Integration of 2 1 by x dx is given by what? X square. Check, exact same thing, x square. Okay, and so answer will be what? Y times of x square. You have to write all the steps. I just solved the question, that's why I'm skipping this step. You have to write till here and till here. Okay, I'm writing from here. Okay, so y into x square, integration of x square, x log x dx. This is a by parts form of integration. I get x cube log x dx. You know the preference of by part is islet, means log has the preference. This is my function number 1 and this is my function number 2. Function 1 and function 2. Okay, let's integrate this only first. Integration of x cube log x dx. Okay, we have to keep the first function as it is, so I'll keep log of x as it is. Integrate the second function, right? So I'll get x power 4 by 4. Integration of x cube is x power 4 by 4. Then we have a minus sign. Okay, integration again. Derivative of log will be 1 by x butcha, and this will be again same thing, x power 4 by 4. Dx will come. Integration of x cube is x power 4 by 4. Check this out. I'm getting here x power 4 by 4 log x minus, it will become x cube. So 1 by 4 is outside, integration of x cube dx. Am I right? X cube, because we cancel x and x power 4. Okay, no problem, sir. X power 4 by 4 log of x minus 1 by 4 x power 4 by, again we get one more time 4 plus the constant c, and this is your this answer. I'm gonna club it together to get the final result. right here yx square equals to x power 4 by 4 log of x minus x power 4 by 16 plus c. Divide everything by x square, you get y equals to x square by 4 log of x minus x square by 16 plus c upon x square. This is your final answer. Please check. Okay, this is your final answer. Please check. Got it? A 5 marker. This right here is your 5 mark question. Let's move on then. Question number 8 now. Find the equation of the curve passing through the point 1 1. Okay, curve like this, point is over here somewhere 1 comma 1, and they're saying that this equation is true for the differential equation. Okay, all right sir, we can do what? Let's try. I can divide by x actually there. This is simply a variable separable approach. This is simply a variable separable approach. So we'll get here dy as it is, and we'll get 2x square plus 1 divided by x dx. So we have dy, we have 2x plus 1 by x dx. Am I right? Yeah. Integrate now. We'll have here y, we'll have here x square by 2 into 2 plus ln x plus c. Okay, this is cancelled. So I have the answer so far is y equals to x square plus ln x plus c. Now we are saying that it passes through, the given equation passes through what? Through the point 1 comma 1. Means the given equation will satisfy the point 1 comma 1. So y equals to 1 square ln of 1 plus c. I get 1 equals to 1 plus 0 plus c. It means the value of c is 0. Value of c is 0 because 1 and 1 will cancel. I have c will be 0. So my solution will be what? From here you can see y equals to x square plus ln x, because c is 0. This is my final answer. This is my final answer. Question number 8 is also done. So find the general solution of the differential equation cos square x dy by dx. Okay, so what happened now while solving it previously? I erased all of them by mistake. Okay, there's an option here, erase all on the slide. It's okay, we can do it again, no problem. So this is a, of course we know this is a LDE. So we get here dy by dx plus y upon cos square x equals to tan x upon cos square x. This equation becomes dy by dx plus y into secant square x tan x into secant square x, because 1 by cos square is secant square. This right here will be what, bacha? This here will be your p of x, and this will be your, this whole thing will be your q of x. Let's find the integrating factor now. E power secant square x dx will give me e power tan x. E power tan x. Okay, let's write the final answer. Y is the dependent variable. Y into e power tan x equals to integration of what? The integrating factor e power tan x into the q. So tan x and secant square x dx plus c, the constant will be there, of course. Okay, write that later also. Let me integrate this part right now. This is my final answer. Integrate this part. So in this case, if I take tan of x as t, we'll have secant square x dx as dt, right? So this integration becomes e power t into t dt. Okay, now if you want, you can solve this, or if you want, this is also very simple integration, we can remember it all the time. Answer will be coming as, I'll show you, final answer will be e power t t minus 1 plus c. Okay, that's my integration of this. I'll show you. So if you remember the preference order, exponential comes last. So keep this as it is, t as it is. Integrate e power t will be e power t minus sign. Derivative of t will be 1. Integrate e power t, again e power t dt. Check here, I'll end up with t e power t minus e power t. Take e power t comma, you'll have e power t t minus 1 plus c. Okay, I will not write the constant again over there because it's the same constant. Okay, so my final answer is coming as, I'm looking for general solution only. So I can write the answer directly. E power tan x equals to e power t is what bacha? E power t is e power tan x. Okay, and we have tan of x minus 1 plus the constant c. Divide everything by e power tan x. You'll see this will become y equals to, this will be cancelled, so nothing is there. Tan of x minus 1, because we are going to cancel this e power tan x, and this will be what? C divided by, no, so I can write c into e power minus tan x. Correct? If you divide by e power tan x, it will become c by e power tan x, simply e power minus tan x, and this right here is my final answer. Check. Okay, 5 marker. This is a 5 marker. Okay, done. Let's move on. This is 5, okay, not S. This is 5 marker. All right, sir. Question number 10 now. Find the general solution of the differential equation. We are looking for again general solution. So we have tan x, what is problem over here, and tan y is the problem over here. So divide everything by tan x tan y. Divide in this everything by tan x into tan y. You will have the problem sorted. So you'll get what? Secant square x tan y divided by tan x tan y with dx plus secant square y tan x divided by tan x tan y equals to 0 is there, right? And dividing everything by tan x tan y, it will be 0 only on the right hand side. So I can see here tan x and tan x is cancelled. We had dy over here. Sorry, this is cancelled. My answer is now, my next step is now sec square x dx tan x over here plus secant square y dy tan y over here is 0. Integrate both of these. What is this? This is going to be simply dt by t, here also du by u, right? Check. Correct, no? Have a look. dt by t, if you take tan x as t, it will become t square sec square x dx as dt. Here also the same thing. My answer will be what, bacha? This will be ln t ln c equals to ln a constant, sorry, ln u, right? Ln u equals to ln c. What I've done over here, in this I've taken t as tan x, and in this I've taken u as tan y. Why ln c? That's a constant. If you differentiate this, you'll get what? 0 only. Okay. Now check, this will become what? Ln of t into u equals to ln c. If you take exponential function on both sides, you'll get what? Log remove tu equals to c. What is t value? Tan x. This will be what? Tan y. C is the constant. This is the final answer. This is your final answer. Please check. A very simple question. A very, very simple problem. Next. 11. Find the equation of the curve passing through the point this. Same approach. Point is what? Minus 2 by 3. Minus 2 comma 3. And tangent. Okay, slope of tangent. This means derivative only, right? I hope you remember this. This means derivative only. Okay. They're saying that dy by dx is given equals to 2x upon y square. Okay, let's do one thing. I'll write this as y square dy and 2x dx. Correct, no? Y square dy and 2x dx. Integrate. We'll have here y cube by 3. We'll have here x square plus the constant c. Integration of 2x is what? X square. 2 into x square by 2. 2 and 2 will be cancelled. I have x square plus c. This is my general form. What are they asking? They're asking us particular solution because they have given the point as minus 2 comma 3. Let's put it back. But before I do that, I can simplify this, no? I'll get y cube equals to 3 times of x square plus 3c. Y cube equals to 3x square plus a constant k. Now put the value of the coordinates minus 2 and 3 in this equation. The general solution. This is your general solution. So we'll have 3 cube means 27, right? And here we have 3 times of minus 2 square plus k. Simplify this. 27 left hand side. Square will become 4 into 3 is 12 plus k. So k has to be what? 15. K has to be 15, right? Check. 27 and 2 square is 4 into 3, 12. Difference will be what? 15 only. Answer you get as finally y cube equals to 3x square plus 15. This is my final particular solution. Particular solution. Got it? This is the equation of the curve, what they were asking. Got it? Simple question, again 5 marker. Moving on. I've taken more of 5 marker, simple reason because if you know the 5 marker solutions, I'm using everywhere substitution methods, your variable separable method, so you can see that the question approach will be simpler for 2 marker also. Okay. Find the general solution of the given equation. Okay, in this we can see directly is value of p. We don't have to make the form here because they've already given that. P is secant x and the q is what here? Tan x. There is no making of the standard form. They are given the whole thing in the standard form dy by dx. Okay. So integrating factor will be what? E power integration of secant x dx. We all know the value of this. E power log of secant x plus tan x. E power log means we'll cancel. We have only the answer as the integrating factor as secant x plus tan x. Okay, they are talking about only positive side, so we can just write directly without the mod. Secant x plus tan x. This is my integrating factor. This is also a 5 marker. I hope you know that. This is also a 5 marker. Okay. Now put it back in the equation. What is the equation going to be? Y times of secant x plus tan x equals to integration of secant x plus tan x into the q value tan x dx. This tan x dx. Check. We'll have secant x tan x and of course with the dx, and plus sign we have tan square x dx. I've separated the terms over here. Tan x into secant x as one of the integration, tan into tan will be tan square second integration. This we know will be what? Simply secant x plus side. Tan square is what? Secant square of x minus 1, right? Continue please. Secant x plus integration of sec square is tan minus 1 is minus x plus the constant c. Over here we have what? Y times of secant x plus tan x. If you want the final answer, it will become y equals to secant x plus tan x minus x plus c, the whole thing divided by secant x plus tan x. If you want to simplify further, you can branch it over here. You'll have only 1 there, 1 minus x plus c divided by this same denominator. Your choice. 5 marker. Clear? Next question. 13th one. The general solution of the given equation. Okay. You have to make the differential form over here. So y dx is there, right? Equals to x plus 2y square dy. X plus 2y square dy. Can we do one thing? Write this as dx by dy, because simple to create the fraction. So x by y and 2y, correct? Dividing everything by y. No, I've taken dy over here, this dy over here, and y on this side. I get x upon y and 2y square upon y is 2y. Okay, bring this over here to the standard form. Dx by dy minus of x by y equals to 2y. This is your standard form where x is the dependent variable. X is the dependent variable. What is p in this case? Your p value is minus 1 upon y and your q value is 2y. What is the integrating factor? Very simple, sir. E power integral of minus 1 upon y dy. So I get e power minus ln y. So e power ln y power minus 1. So we get this as 1 by y as my integrating factor. Integrating factor. Answer here, the dependent variable is x, means x times of the integrating factor. Sorry, Yeah, x is the dependent variable, so x times of integrating factor. Integration of 1 by y into q. Q is 2y. 2y dy. Y and y is cancelled. I get x upon y equals to integration of 2 dy. So x upon y is equals to 2 into y plus c, I guess. Please check. X upon y, 2y plus c. So answer is nothing but x equals to 2y square plus c. In this case, x is the subject. X is the subject. Okay? Good question. 14th one. A similar question we have solved. So you can see the trend of problems by now. These are all PYQs. Find the equation of the curve passing through the point. Same thing. 1, 1. Given that the slope of the tangent dy by dx equals to this part. Dy by dx equals to x by y. I get y dy, x dx. Variable separable form. No problem. Plus c. Right? Can you simplify this? Okay, sir. Y square by 2. Okay, 1 second. Y square equals to x square plus 2c. I multiply everything by 2. So you get this in the simplified fashion. Now put the value of 1, 1 because this is the general solution over here of the given curve, and the point should satisfy the given equation of the curve. So I'll have 1 square equals to 1 square plus 2c. Cancel. I have 2c equals to 0 means c value is 0. Check your answer. Put it back. Y square equals to x square plus 0. What is the answer? Right here. This is the answer. Okay. Next. The last question of the day. Y dx plus x minus y e power y dy. What is the general solution they're asking? What is the general solution they're asking? They've not given any points so far in this question. I'll bring this on this side. I'll have y dx equals to, it'll become y e power y minus x dy. Correct? No? Side change. The sign will be opposite. I'll have a minus sign outside. It'll become what? If you go inside, minus x and plus y e y. Now the standard form. I have here dx upon dy and y e power y minus x upon y. Moving dy on this side and y on that side. No problem. So dx upon dy e power y minus x by y. Y and y cancel for the first term and x by y as it is. Move this on this side. This is general solution, general form of the LDE. We have x by y equals to e power y. Your p value is 1 by y and your q value is e power y. E power y. Integrating factor now. So you'll have this as, please check, integrating factor will be e power integration of 1 by y dy. So e power ln y. What is the answer? Simply y. Simply y. Okay. Answer here, x is the dependent variable, so x into y equals to integration of y into e power y dy. We just solved this question, if you remember, e power t into t. Answer will be what? E power y minus 1 plus c. 1 second. Here we can write this xy e power y minus 1 plus c. I'll show you how to do this. ILET means your algebra has the preference, so y as it is. Integration of e power y is e power y minus integration of derivative of y will be 1 and e power y. Check this out. We have here dy. This will become ey only. You can take ey common. This is your answer. So x becomes what? E power y into 1 minus 1 by y plus c by y. I've divided everything by y, no? So I can take it over here. Y by y is 1 and 1 by y is just 1 by y. C by y is again, that's there. This is your solution and end of the session on your PYQs of differential equation chapter. Okay, I hope you learned from it. Have a look one more time. Okay.
So I've discussed all type of questions from this chapter which can be expected in this year's examination. So let's solve these questions one more time from your side as well, and then only we can say that we have prepared this particular unit from our side completely. That's it for this particular lecture. Vector algebra. So the best thing about this chapter is that if you know the formulas very well, then you can get out marks in this particular chapter. Okay, weightage. What is the weightage for this chapter? Here it is. So total of 5 questions will come. 3 will be your 1 marker, and 1 and 1 will be your 2 marker and 3 marker. So basically the total becomes 8 marks. In the 3 1 marker, there can be a fill in the blanks also. So 3 questions from 1 mark, 3 marks there. 1 2 mark becomes 3 plus 2, which is 5, plus 1 3 mark question, total is 8 marks. Okay, now what I have planned for all of you, we'll have a question based approach. So we have question 1 to 15 as MCQs. Okay, first 15 questions are MCQs, then 16 to 23 is 2 marker, next 8 questions, and another question which is going to be, excuse me, this is incorrect, 15 plus 8 is 23 plus 5. Actually I made a mistake over here. This should be 5, no? Yeah, 28 total number of questions. This will be 28 questions if you see, remove the 1 over here. Most important topics, and of course you also have homework over here. Since the chapter is very easy, I have given many homeworks today, so you'll see all of that at the end of the session. Starting with the section number 1, which is MCQ. Question number 1. If the given two vectors are equal, what happens? It means the x component should be equal to the corresponding x component should be equal. So we go here, x should be 2, y should be 2, and z should be here, compare these two, 1. Option you check, 2 to 1, 2 to 1, 2 to 1 is option C. 2 to 1 is option C. Your question number 1 is done. Question number 2 now. The vector joining the points 2, 3, 0 and this directed from P to Q. Vector PQ. It will subtract from this to this in that case, right? From P to Q it is given means minus 1, minus 2. So minus 3 I cap, minus 2, minus 3. So minus 5 J cap, and minus 4, minus 0. Excuse me. So minus 1, okay, minus 3, minus 5 and minus 4 only, minus 4 K cap. Okay, minus 3, minus 5 and minus 4 K cap. Option is option B. Fair enough, clear. Question number 2 is also very easy. So I hope you can see the type of questions that we have still yet to solve, but the questions are very easy if you know the concepts, if you know the formulas very well. For that you can refer to any summary of the NCERT. You have all the formulas and concepts listed at the end. Follow it strictly and you can solve the questions very easily in the chapter vector algebra. Okay, the value of lambda for which the vectors are collinear. Alright, for that we know this property is A equals to lambda B. So basically A by B will be equal to a constant lambda. So write the ratio 2 by minus 4, minus 3 by lambda, and 4 by minus 8. Check here, 2, this also is 2. It means basically I'm getting the ratio to be equal to minus 1 by 2. Compare these two now. So minus 3 by lambda equals to minus 1 by 2. Cross multiply, you get the lambda value as 6. Option B is the correct answer. 3B, 6 is the right choice. Okay, next question number 4. A dot B is equals to minus A into B modulus. How do we solve this? A dot B, we have a formula is important. A into B into cos theta. Now they're saying this is equals to this value over here, minus A mod into B mod. Same thing you write over here. We have cos theta, cancel. We're getting here minus 1 equals to cos theta. Theta is pi, sir. Option C. Question number 4, option C is the right choice. Getting it? Yes. Now next question. A dot A is 0. What is the expansion of A dot A? Sir, this is nothing but A square cos 0. What is cos 0 going to be? Cos 0 is, sir, 1. So it means that A has to be equal to 0. Because cos 0 is 1, means A square is equal to 0. It means A magnitude has to be equal to 0. If A itself, vector A is a 0 vector, it means that whatever you take with A, doesn't matter whatever it is, it will always be 0. Hence B can be any vector. Option C is correct. B can be any vector. Okay. Next, question number 6. Getting it right? Yeah. Now projection of vector A on B. Of A on B. There's a formula for this. A dot B upon mod of B. Option B is the answer. How do we get it? We write like this. A times, the result is A dot B cap, right? A dot B cap. That's what it comes from. So answer is option B. Question number 6 is also complete, sir. So far, so good. All is okay. Any problem in the comment section? I will read them, I'll resolve them, and I'll help you, I'll motivate you, I'll energize you to get to the top score or to the best score that you can get for your PU2 examination. Okay, so let me know in the comment. The unit vector in the direction of the vector A I plus j plus 2k. Unit vector I'm looking for. So I have unit vector formula is vector A upon mod of vector A. So basically this will remain as it is. Mod of A will be what? Root of 1 plus 1 plus 4. So same thing, I plus j plus 2k by root 6. Option A. I plus j plus 2k upon root 6. Question number 7 over. Question number 8 is from your question bank. Okay, it looks like question available, but it is actually question number 8 only. Okay, the direction cosines of the vector DC they are asking. Can you find dr first? Yes. So basically if you check here, we have 1 and we have 2, we have 3, and we have to divide all of these by what? The modulus of the vector A. Excuse me. What is the modulus of A? Check. Root of 1 plus 4 plus 9. So root of 14. Since root is there, means both plus minus will come. So answer will be what? Plus minus root 14 plus minus 2 by root 14 plus minus 3 by root 14. So if it is 1, 2, 3 positive, all positive. If it is negative, means all negative. So we don't have that over here. We have minus 2 missing. If it was minus 2, then option B can also be correct. But here we have only one such correct option, which is option D. 1, 2, 3. All 3 is correct. Yeah. Sign has to be the same, because we can have both plus minus. Plus 1 by A mod of A, which is root 14, and so on. Plus 1 by root 14, plus 2 by same, plus 3 by same. All minus 1, minus 2, and minus 3 by the root 14 is the direction cosines. Yes. Next, the value of x for which is a unit vector. How can you get the unit vector of this part? This will be what? Same thing will repeat. Divided by root of modulus of this 1 plus 1 plus 1. So we get this as I plus j plus k. This is the unit vector. This is the, if I call this to be vector, let's say A, then vector A cap is given by this. So I get here 1 by root 3 with this condition. Compare this with this, you're getting x value as 1 by root 3. Compare this with this thing, this bracket is same. I plus j plus k. X is 1 by root 3. Option C is correct. This is question number 9, I guess, right? Question number 8, question number 9. Now question number 10. Question number 10. I, j, k are unit vectors. Then which of the following is incorrect? We are looking for a long option. We have I dot I is 1, j dot j is 1, k dot k is 1. This is correct. I dot j is 0 because I j cos 90. So 0. J dot k is also 0, k dot k I is also 0. So this is also correct. So both of these are true. I cross I is 0 because I sin 0, right? I cross I means I. When you do cross product, I hope you know that. If you have A cross B, this is nothing but mod of A, mod of B, sin theta. So I cross I means I, and the angle between I and I will be 0 only. So sin 0. This whole thing will be 0. J cross J also 0. K cross K also 0. Here you check cross product of I, J, J, K. Okay. For that we'll write this cross product nature. Check here. I, J and K. If you go I to J, you will reach K. You go K to I, you will reach J. If you go I to J, you will reach K. You will go J to K, you will reach I, and so on. And this is going to be positive. Means I cross J is positive K. K cross I is positive J. J cross K is positive I. But if you go ulta, means I to K, then you will reach J. If you go J to I, then you will reach I. But with what sign? Minus sign. This will be a minus sign. Getting it? So if you go anti-clockwise,
sign is negative. If you go clockwise, sign is positive. So in this you check I cross j. This will be what? Positive k. I cross j is positive k. Here you're gonna check what is this, sir? J cross k. Yes, j cross k would be, sir, j cross k, no? Yeah, j cross k is again going to be positive I, and k cross I. K cross I will be, sir, k cross I, j cross k and k cross I. Okay, that will be j only, but they're not equal. No, they're not equal to 1. So your incorrect option is D. You can check from here, they're not equal, they're different. So your incorrect statement and the correct choice is option D. Clear? This you focus on. This is your understanding, this concept over here of I cross j cross k. Next, question number 11. This is question number 11. Okay. Question number 11. The projection of vector of AB on the directed line L. So projection of AB on the line L, angle is theta. So I'll have what? AB cos pi only, no? It will become what? It will become AB into minus 1. So there will be what? BA. Correct now? If you have minus AB, it will become simply BA. So answer will be what? Option C. Option C. 11th one is option C. I'm looking for projection, right? So cos pi will come. Yes. Okay. 22 is done. 11th is C. 12th now. Question number 12. Check. Projection of the vector I plus j across I minus j. Projection of this, no? So what is the formula? So whatever is the vector given over here, ij dot with ij divided by modulus of I minus j. Okay. This will come as I dot I is 1, j dot j is minus 1. Whatever it is over here, answer is 0 because 1 minus 1 is 0. I dot I is 1, j dot j is again 1, but there is a minus sign. I dot j is 0 and j dot I is 0, so we don't have to worry about that. Answer is 0, hence option C. Getting it right? I dot I is 1, I dot j is 0, j dot I is 0, and j dot j is again 1 with a minus sign, so the whole thing is 0. Question number 13 now. Angle between two vectors AB with the magnitude is given. So A dot B is given by 1. Here you check. So I have mod of A, mod of B, cos theta equals to 1. A is given as 1. This is 2. Cos theta is 1. It means cos theta is 1 by 2. It means theta is cos inverse of 1 by 2. So pi by 3. Pi by 3. Simple question. Very simple. Okay. As I said, the concept of this chapter is very easy, and you can easily solve it if you have if you have all the formulas in your mind. So formulas are very important in this chapter. Next, 30th. The magnitude of the vector, 29 is done, no? 13 is done. Question number 14. Magnitude of two vector A, B having the same magnitude and such that angle between them is pi by 3. Okay. So A dot B cos theta is 1 by 2. The same magnitude means let's write it as A into A. Same magnitude. Cos theta means cos of pi by 3. So cos of pi by 3 is equals to 1 by 2. Cos pi by 3 is how much, sir? It is 1 by 2 only. So 1 by 2 and 1 by 2 cancels. What I have? A square equals to 1. It means A value is plus minus 1. The value of A is plus minus 1, but it is talking about the magnitude. They are asking us the magnitude. Okay. Magnitude is always what? A positive value. So you have to take a positive value. Plus 1, option C is right. Plus 1, option C is right. Yes, we do get two values of A, which is plus minus A, but we are looking for only magnitude. So it will become simply plus 1, the positive value. Question 15. The value of I dot j cross k. Same approach. I, j, k from here, and here it is positive. So what is it? J cross k, no? J cross k will be positive I. So plus I. Correct, no? J cross k is positive I. Okay. So I dot with plus I. Here you get j dot with I cross k. So you're gonna go this way, no? I cross k. I cross k will be, sir, minus j. This will be, sir, minus j cap. And this one, k cap as it is, I cross j will be
plus k. Check over here. Okay, I cross j is plus k, but I cross k is minus j. The second one. I dot I is sir 1. J dot j is sir again minus 1. Over here plus 1. Cancels. Answer is sir 1. So option C. Option C. This is your end of all the MCQs. Can you see the variety that I brought today? From the dot product, cross product, angle between them. So different type of question I've taken. If you follow these properly, if you solve these questions, and after this, if you want, if you have time, you can solve more questions from question bank or NCRT. But this is a must. Do not forget to solve these questions first. It's very, very important. Okay. So this first 15 MCQs are dealt with. Now we are moving to the 2-marker category. The next question set of is 2-mark category. Okay. So 3 questions will come from MCQ. 2-marker will be 1 question. 3-marker will be 1 question. Find the unit vector of the direction in the direction of this vector. They are asking us a cap. So vector a upon mod of a. 2i cap, 3j cap, k cap divided by root of 4, 9, 1. So 14. So 2i cap, 3j cap, k cap by root 14. This is your a cap, the unit vector. Check. Easy question. Okay, 2-marker. Next, find the projection of the vector A on the vector B. Projection means if I'm going to find it like this, A dot B cap. So A dot B upon mod of B. Do it. A dot B means 2 into 1 is 2. 3 into 2 is 6. 2 into 1 is again 2. And the modulus of B. B is here. Check it out. We get here 1 plus 4 plus 1. 1 plus 4 plus 1. Right now? 1 plus 2 square is 4 and again 1. So this is going to be what? 10. 6 plus 4 is 10 upon root 6. 10 upon root 6 is the projection of the vector A on B. This is your answer. Okay. If you want to write like, you can write it as 10 root 6 by 10 root 6 by 6. So it will become 5 here, 3 here. So 5 root 6 by 3. Your choice. If you want to rationalize it, that's your answer. Clear? Okay. Question 18 can be solved now? Yes. 2 markers are very easy. Okay, very, very easy. We'll see. Projection of the vector A as given over here. Again, same approach. This you can solve. This and this one is exactly same, right? This question, both of them are PYQs. Check here. Same here, PYQ. This is annual examination. This is supplementary examination. Okay. So 17, 18 is same. This is your homework. Solve it. Okay. Question number 19 now. Question number 19. Find the angle between two vectors. Okay. For that you're gonna do what? A dot B equals to cos theta upon mod of A into mod of B. How comes, sir? The formula of dot product, or simply the formula of the angle cos theta. Okay. What is A dot B? Sir, we have here root 3. A dot B is given root 6. Pardon me. Forgive me. They've given A dot B as root 6 over here. You check. So root 6 upon root 3 into 2 over here. This is cos theta. So we can cancel these two. We'll get what? Root 2 over here. So I have root 2 by 2 as cos theta. Cancel these two. We'll have root 2 over here. I'm getting the value of cos theta at, means theta will be what? Cos inverse of 1 by root 2. Answer is pi by 4. 2 marker. That easy. Question pi by 4. Question number 19. 20 now. This question 20. 18 from the question bank actually, but this is a question number 20. Angle between these two vectors. Same approach. Cos theta is given by A dot B divided by mod of A into mod of B. Do the dot product. 3 into 1 is 3. Minus 2 into minus 2 is plus 4. 1 into 3 is 3. Check here. 1 into 3, 3. Minus 2 into minus 2 plus 4. 3 into 1 is 3. Okay. Now mod of these. We'll have 4 plus, check here, 1 plus 4 plus 9. Other one, 9 plus 4 plus 1 again. 9 plus 4 plus 1 again. Okay. So we have over here 3 plus 4 is 7 plus 3 is 10 plus 3 is 10 divided by root 14. So simply 14. I get the answer as 5 by 7. So this is nothing but your cos theta.
theta will become equal to cos inverse of 5 by 7. Cos inverse of 5 by 7. Another 2 marker is dealt with. Next is your question number 20 is done. 21 now. What do we have? So that a minus b vector cross a plus b vector is this given vector 2 times of a cross b. Start from LHS. Take here a minus b and cross is there. We have the cross product only in this particular question. So a dot with a. So we're gonna get, so not dot, cross, sorry. Cross. A cross with a cross with a. Now a with b, so we'll have plus sign. A cross with b. Next, minus b cross a. So minus b cross a. What I'm doing over here? Applying the distributive property. Okay, so minus b cross a, and last one is minus b cross b. Now all of you know very well the vector product of the vector to itself is always 0, because if you multiply vector x vector to itself, okay, it will become x into x sine of 0. Answer is 0. Sine 0 is 0. So a cross a is 0 and b cross b is 0. So what I'm left with is a cross b, and we have minus b cross a. Now we all know b cross a is also a vector. If I use the minus sign over here, I'll end up with what? A cross b. If I take the minus sign inside this, it'll become what? Plus a cross b. Correct, no? The vector will be reversed. So I get a cross b plus a cross b. Answer is twice of a cross b. This is nothing but your check RHS. Check RHS. Proved or not? Simple enough. Simply apply the distributive property, you get the result. A cross a and b cross b will be 0. Change the sign of the b cross a. Answer is RHS 2 times of a cross b. 3-step question. Question number 22. So that the vector this is equally inclined to the OX, OY and OZ. Basically X, Y and Z axis. So cos of the angle. So cos of the first x-axis angle is cos alpha. Second will be given as cos beta. And the last will be given as cos gamma. Right, no? The angle with x, y, z is given as cos alpha, cos beta, cos gamma should be equal. Okay. How do you find that? Let's find the DCs. What do you get for this? So if you have IJK, no? If we have IJK, you'll get the angles like here, the components. You'll get the angle cos alpha as what? 1 upon root of 1 plus 1 plus 1. How come 1, sir? Because the coefficient of I is what? 1. The coefficient of I is 1 means 1 upon square of each of the coefficients. So 1 upon 1 plus 1 plus 1 is 1 upon root 3. Same way, this will be equal to your cos beta and also equal to your cos gamma, because all the coefficient here, if you check, if I write here as AI cap, BJ cap and CK cap, A is equals to B is equals to C equal to 1. The coefficient is 1. So if you find the value of cos alpha, okay, then you get cos alpha is 1 by this and 1 by this, which is nothing but 1 by root 3. They are all equal, hence they are equally inclined to the axis OX, OY and OZ. OX, OY and OZ. Because alpha will be what? Cos inverse of 1 by root 3. Check here. Alpha will be beta, will be gamma, will be equal to cos inverse of 1 by root 3. So that's why they are equally inclined to all the axes OX, OY and OZ. Fair enough. Okay, next. Question number 23 over here. Question number 23. If A plus B mod is equal to A minus B mod, prove that A and B are perpendicular. Can we do this? Take the whole square. Take the whole square. How can we say that, sir? Please check. I'm looking to make a relation between them based upon the angle. Perpendicular means angle concept comes. Means, it has to be 90 degrees. Okay. So cos 90 is 0. That will come only if I have a square. I'll get dot products. Please check. Over here I'll have expansion of this as square plus 2. Excuse me. Not 2. Yeah. 2 only. Sorry. Correct. 2 into A dot B. LHS side. What is RHS? Same thing. Square and this will be minus 2 A dot B. Check here. a square, b square is cancelled. Now bring this on this side. You'll end up with 4a dot b is equal to what? What is left on this side? Nothing, means 0. So you're getting that a dot b is equal to what? 0. It means that cos theta has to be what? 0. So cos theta is 0 when theta is 90 degrees. Theta is 90 degrees. Okay, getting it? Theta is 90 degree. That's why a and b are perpendicular. So a vector is perpendicular to the vector b. Clear? Question number 23 is also over. Check this out. Next, 24 will be a 3 marker. Question 24 is 3 marker. So far we have dealt with our 2 marker and MCQs. 24 now. Find the area of the parallelogram whose adjacent sides are. Okay. Area is given as sides this, the magnitude. Sides, cross product, and the magnitude of that. Let's find this. So we're gonna find this part first, a cross b. For that we have to find the determinant of first row, I, j and k. The values of I, the coefficients 1, -1 and 3 here, 2, -7 and 1. With I cap we get -1 plus 21, right? So 20 -1 minus 21 will become plus 21, so plus 20. And for minus j cap what we have, this is cancelled. 1 minus 6, 1, and we have over here minus 6, so minus 5, correct? No, 1, 3 into 2 is 6, so minus 5. Now with k cap what we have? With k cap we have, this is cancelled, so minus 7 plus 2, so minus 5, minus 7 plus 2, which is minus 5. So I have the answer as 20 I cap plus 5 j cap minus 5 k cap. Okay. Now area of parallelogram is given by modulus of a cross b. So find this. What are you gonna have? Square of this. So 400 plus square of 5. So 25 plus 25. What do we get for this? We get here 450. So we can write this as what is it? 15 into 3. No, 9 into 50. Okay. So 9 into 25 into 2. Please check. This is 50 and 50 times 9 5s are 45. So correct only. Root of this will be what? 3, 5 and 2. What is the answer? 15 root 2 is the area of parallelogram. Of course, square units will be there. Cross check the calculation once. Cross check the calculation one. Answer is 15 root 2. Yes. Let's move on. Next question. 25. So that the position vector of the point P which divides the line joining the points A and B. Okay. Line A is here, point A is here, point B is here, point P is over here. With the ratio internally m to n. This is m to n. This is the derivation of your section formula. Okay. Let's take a reference point as point O, and the position vector of the point A from O is, let's say, vector A. Okay. Let's understand the figure first, then we'll see what the question actually talks about. So basically they have given the 2 points AB. The line joining that will be AB line, and on that if you put a point P with the ratio division of m to n internally, they're asking you to find the position vector of, what do you call? Yeah, position vector of your point P actually. Okay. So this is your position vector of the point P. Let's call this to be vector R. Okay. And this is your position vector of the point B. So vector B over here, this is the vector AP and vector PB. Alright, so they are asking us to prove that vector R is equals to MB vector N A vector upon M plus N. This is what they are asking us to prove. This is our to prove statement. These are to prove statement. Getting it? Alright, sir. Then please check here. If I take only the ratio first, AP to PB, I can write this as m to n, right? The ratio of AP to PB is what? M is to n. Okay. Now if I take this same in the vector form, I can do that. Then I'll have this cross multiplication as NAP equals to M PB. MPB. Now next step is to apply, triangle law of addition. Triangle law of addition. Check. For AP vector. Check here. This is the vector A, this is the vector AP, and this is the resulting vector R. So vector AP is nothing but R minus A. From triangle of addition, vector AP is R minus A. So write that n times of vector R minus vector A. Is it clear? Okay, next, same way, same fashion. M times of vector PB now. Vector PB is here, R is here. So I can write vector PB as B minus R, because here resulting will be what? If you apply a triangle law in OPB, you will have vector B equals to R plus PB. Vector R plus vector PB will be what? Vector B. So PB will become B minus R. Vector B minus R. Not clear? It's okay. So vector R plus vector PB is equals to vector B in this triangle. And in this triangle we have, what do we have? Vector A plus vector AP equals to vector R. Triangle law of addition. Triangle going like this and this, head to tail. Okay. So we use this and get AP as R minus A, and use this to get PB as B minus R. Expansion over here. NR minus NA MB minus MR. Positives on one side, negatives on one side. You check here. You're going to move MR over here. So you'll have NR plus MR equals to MB will go on that side, NA. Take whatever is common. Here we have R vector common. So we'll get here M plus N equals to MB plus NA. The last step. The vector R, the resulting vector R is given by MB plus NA upon M plus N. M plus N. This is the result. MB plus NA upon M plus N is the result of the final resulting vector, which is going to be the position vector of the point P, which creates a section of M to N from the point reference point O. Okay. 25th also is done. Very good question. Will come for 3 marks. This is a PYQ as well. Not only this year, this has been asked at many occasions. Okay, at many occasions. 26. 3 vectors A, B, C satisfying the condition A plus B plus C equal to 0. I'm looking to find the value of this mu value. Value of mu when mod of A is 1, mod of B is 4, and mod of C is 2. Please check carefully. A dot B, B dot C, C dot A is there. If you remember the one of the identity of A plus B plus C the whole square, you'll know in that this comes A, B, B, C, C, A. I'll show you. If I write like this, A plus B plus C whole square, I'll end up with mod of A square, mod of B square, and mod of C square. After this I get twice of A dot B, B dot C, and C dot A, and C dot A. Okay, now we have the value. This is nothing but 0. So square of 0 will be what? Check here. 0 square is simply 0 only. We get the square of A as 1, square of B as 16, square of C as 4, and plus 2 times of what is this? Check here carefully. Mu. So 2 mu. 16 plus 4 is 20, plus 1 is 21. Move on this side. We get minus 21 equals to 2 mu. So value of mu is nothing but minus 21 by 2 minus 10.5. The value of A dot B plus B dot C plus C dot A is what? Minus 10.5, and that's your answer. Easy? Very easy, sir. 27. A plus B dot with A minus B is 8, and A is given as 8 times of B. Find the B value. Expansion from here, we're going to apply what? We're going to apply our distributive property. A dot with A. A dot with A first. A dot with B. So minus A dot B plus B dot with A. And last one, minus B dot with B. This is equals to 8 they have given us. This is cancelled. A dot B and B dot A is same. A dot B and B dot A is same. Plus and minus means cancelled. A dot A is nothing but A square, and this is nothing but B square equals to 8. They've given A as 8b. So right here 8 vector b square, sorry, my bad, yes, whole square, no, 8b the square, because A is 8b, so 8b the square minus b square is nothing but 8. Am I right? Correct? Okay, check here, 64, and we have can we take b square common? Mod of b square common. 64 is left over here, minus 1 is 8. So answer will be what? Mod of b square is nothing but 8 upon 63. So basically from here I'm getting mod of b is equals to root of 8 by 63. So in both we have something which is common. We have over here common as 4 into 2 and 9 into 7. Okay, so I get this as 2 by 3, 2 by 7. Now multiply this with root 7 over here and over here. Check this out. You will get what? 2 into root 14. Root 7 into root 2 is root 14. And over here you'll have 3 into root 7 into root 7 will be simply 7, sir. So I have the answer as mod of b is nothing but 2 root 14 upon 21. 2 root 14 upon 21. Check this out. 2 root 14 upon 21. Clear? 2 root 14 upon 21 is the answer for mod of b. Cross check your answer calculations as well. The last question of the day. Find a unit vector perpendicular to each of these vectors, a plus b and a minus b. I'm looking for, let's say I call the vector p to be a plus b, and vector q to be a minus b, and let's draw it. P is here and somewhere q is here. So p cross q, a vector which is perpendicular to p and q will be either outside or inside. So I'm looking for what? Basically I'm looking for p cross q or q cross p, your choice, because we're looking for unit vector in that direction, so it doesn't matter. Okay, so p cross q I'm looking for. Okay, so first thing we're gonna do what? Find vector p first. Find vector p first. Let's find that. Vector p will be sum of these two. So 1 plus 1 is 2i cap, 1 plus 2 will be 3j cap, and we have over here 1 plus 3, so again 4k cap. And next we have vector q. Vector q is the difference. 1 minus 1 is 0, j and minus 2j will be minus j cap, and minus k minus 3k. Sorry, 1 minus 3k minus 2k cap. Let me check once again. Correct. I and I is 0, j minus 2j is minus j, and k minus 3k is minus 2k. Correct, sir. Okay, so p and q we have now. P and q we do have now. Next I'm going to move on to find what? P cross q. Let's find out. So the vector, let's call the vector x to be vector p cross q. And what are they asking basically to us? They are asking us value of x cap. They are asking us unit vector in the direction of perpendicular to both p and q. What is p and q? A plus b, and q is a minus b. So let's find p cross q first. Start with I, j, k, and over here, excuse me, check the vectors value 2, 3, 4, and we have over here 0, minus 1 and minus 2. With I cap you check, cancel, minus 6 plus 4, minus 6 plus 4. With minus j cap you check, cancel, so this is minus 4, this is 0. Then plus k cap you check, you will have this cancelled, so minus 2. Minus 2. So what I have? Minus 2 I cap, and over here we have plus 4 j cap, and over here we have minus 2 k cap. This is my vector x actually. P cross q is nothing but x. I'm looking for what? I'm looking for x cap. Same thing, vector x upon mod of x. What is mod of x going to be? Please check here. Mod of x will be, sir, 4 plus 16 plus 4. 2 square is 4 plus 16 plus 4. How much is that? 24. Correct now? 24. So that's going to be what? 24 means we can write 12 into 2 or 6 into 4. I think 6 into 4 is correct. So this is nothing but 2 root 6.
2 will go inside, 4 root 6 means 24. So 2 root 6 is the value of modulus. So my answer will be what? Check here. I'm looking for this, no? So minus 2i cap plus 4j cap and minus 2k cap divided by 2 root 6 is the value of your a vector, a unit vector perpendicular to the vector given as a plus b and a minus b. What is this value given as x cap? This is a unit vector. This is a unit vector perpendicular to what? A plus b and a minus b. Both of these vectors perpendicular will be this vectors in the direction of the resulting a cross b or p cross q in this case, not a cross b. Okay, so clear? The answer is minus 2 plus 4 minus 2 upon 2 root 6. If you want, we can cancel this also. Okay, we can cancel this. So we can actually simplify this. Forgive me. So this will be cancelled, no? 2 this will have the answer as just a rough work here, minus I cap plus 2j cap and minus k cap upon root 6, guys. This is my final answer. This right here is my final answer. Please check. I've cancelled this 2, okay? So this will be having 2 over here. So minus I plus 2j minus k cap upon root 6 is the answer. Okay, moving on. Now the time for homework. Here it is. The 5 questions I've given you for homework today is 1, 2, 3, 4, 5. 1 on the vector, unit vector of this result. Okay. If A is a unit vector, then find the value of x mod of x actually, and then we have find the angle between the vectors A and B, the angle between the vectors. Next we have if two vectors A and B are such that A is given, B is given, find the value of mod of A minus B, a question on dot product. Then comes find the area of parallelogram when the two vectors are given over here, A cross B. If you have area of triangle, you will write it as A cross B by 2. Okay. If A is this, B is this, C is this, as that A plus lambda B is perpendicular to C, then find the value of lambda. So find the A plus lambda B actually. Find the value of A plus lambda B over here. This plus lambda times of this. Dot with C will be 0 because A plus lambda B is perpendicular to the C. So A plus lambda B dot C will be 0. From there you can get the value of lambda. So let me know the answers. Okay. So these are the 5 questions as homework. So with this, last thing is what? Your most important topics. First of all, very important, position vector and unit vector. Okay, position vector and unit vector. From here question will come either in the MCQs or even in the 2 marker. Addition, multiplication of vectors, basically triangle law of addition. Multiplication means you have to deal with your cross product, dot product, both kinds, cos theta and sin theta. Projection of vectors, very very important, and parallel and perpendicular vectors are also equally important. For the most important topics of the chapter, your 3D geometry going to be a very important chapter. Reason is very simple. Very simple formulas are there, and if you apply them directly, you get the result. Okay. Next, the content index. What we have on offer for all of you today in this session is very simple. 1 to 8 is your MCQs, total of 8 questions there. Then you have 9 to 14 2 marker, 6 questions there, and 15 to 21 3 marker, 7 questions there. Okay, next, check here. Let's start the question number 1 from MCQs. So what we have over here, question number 1, what is the answer, sir? Please check. If a line makes an angle 90 degree, 60 degree and 30 degree, so your alpha is 90, beta is 60 and gamma is 30. Alpha, beta, gamma is given like this with positive x-axis. Okay. What is the value of DCs? They're asking us value of DCs. So basically L, M, N, N. That's what they're asking us. L value is cos alpha, M value is cos beta, N value is cos gamma. When you do that, cos of 90 is 0, cos of 60 going to be what? 1 by 2, and cos 30 will be what? Root 3 by 2. This is your value of L, M, N. Answer will be, what is it? Answer will be option D, I think. Yeah. Okay, option D only. Yes. The first question, option D is the right answer. This is a PYQ of the 2023 years. Alpha, beta, gamma are the direction angle of the directed line OP. So let's say this is point O and this is the x-axis, and with OP, let's say I'm talking about only one of the angle. Okay, only one of the angle. Let's say alpha. Okay. Now we are trying to find the angles for PO. The action angles for PO. So how do you write PO, bacha? So PO will be like this. OX is here
this is P, but the arrow will change like this. And we all know that to measure an angle in vectors, okay, we need to have a contact of tail to tail. This is going to be head over here. This is head to tail, right? This is going to be head over here. This is going to be tail. To measure the angle, we need to make what? The contact of tail to tail, right? Yes, sir. So we have to draw it like this. Translate or propagate this vector PO in this fashion, and then this angle will be, if this is alpha, this will become pi minus alpha. So same goes with other angles as well. So answer will be option A. Okay, super. Question number 2 is done. Question number 3 now. Let ABC the direction ratios are given, LM and R the direction cosines, such that the relation between them is given. Okay, L is KA, M is KB, and N is KC. They are asking what is the value of K. We know the relation of L square plus M square plus N square equals to 1, right? We know the relation between L, M, N, okay? Now in this we'll put the values of this as K square, A square, K square, B square, and K square C equals to 1. We'll take K square common. I have here A square, B square plus C square equals to 1. Check. So I'll get K square equals to 1 upon A square plus B square plus C square. So K value is what? Plus minus 1 upon this root, right? Please check. Okay. So answer is option A. Answer is option A. Yeah, yes sir. 1 upon A square, B square, C square in the root with the plus minus sign because of the root presence over here. Next, a line makes an angle pi by 2, pi by 3 and pi by 6. Okay, x, y, z axis respectively. DCs they are asking, same thing. So cos of 90, 60 and 30. So 0, 1 by 2 and root 3 by 2. Same question. Okay. So basically this has also been a P by Q. I wanted to show that this is a question from your question bank and also has been a P by Q. Okay. So answer is option B. Next. This also, again you can see this is also P by Q and your question bank question. So answer is option C over here. Have a look. Okay, so even in the latest question bank, the question has been mentioned, means it becomes very much important. They might repeat a question like this. That's why I've taken over here to make a point about these questions. Okay, next, find the directional cosines of the line this. Okay, DCs they're asking. So we have the values of A as 3, B as 2, and C actually as minus 8. Okay, ABC if you check, the denominators over here 3, 2 and minus 8. What does this represent? This represents your vector about which this given line is parallel to. Okay, means this is the line parallel to this given vectors x, y, z component which is given over here. This is nothing but your drs. Okay, this represents your dr of that vector to which this line is parallel to. Okay, the given line is in Cartesian form that is parallel to this given vector. Okay, now all right, sir, this is clear. I'm looking for DCs now. No problem. For DCs, we know that we have to divide this whole thing by the modulus of this vector. If I call this to be, let's say, vector B, 3i cap plus 2j cap and minus 8k cap, then I have to find the modulus of vector B. And this will be what? 9 plus 4 plus 64. 9 plus 4 plus 64. That's 68 plus 9, 77. So I'll get this value as root 77. Of course, plus minus will come. So we'll have the value as 3 by root 77 and 2 by root 77 and minus 8 by root 77. Okay, 3, 2 and minus 8. Option B looks right? Yeah. Option B is correct. Okay, moving on. Find the angle between the lines whose direction ratios are ABC, B minus C, C minus A and A minus B. Take the product here. You'll have A times of B minus C. Okay, because we know that if you take the product of your direction ratios, this formula A1, A2, B1, B2, C1, C2 will be 0. So I'm doing this that. Okay, A into B minus C plus B into C minus A plus C into A minus B. If this is coming as 0 means it will be perpendicular, okay, or 0. Basically, yeah, in this case theta will be what? 90 degrees. So we'll check that. AB minus AC, BC minus BA, CA minus CB. Check here, CB and BC cancel, BA and AB cancel, AC and CA cancel. This is 0 means theta is equals to 90 degrees. That's my answer. Option D, a very easy question. Option D, a very easy question. All right. Next, the angle between the two diagonals of a cube. This is your last of the PYQ, sorry, of the what do you call, MCQs. Okay, so we'll check the angle between the two diagonals of a cube. Let's draw a diagonal first. Sorry, of a cube first. This is the cube right here. Okay, sir. All right, sir. Let's make the axis right now. So we can make the axis like this. This is my x-axis. This is my y-axis, and this right here is my z-axis. Okay. Diagonals means this point will be one of the ends 0, 0, 0, and other end will be this over here. If I take this to be, let's say, unit, let's say the side of the diagonal of any cube, I can take. I'm gonna take this as unit value 1, 1, 1. I can do that, no? 1, 1, 1. I'm taking the length or the edge to be 1 unit. Okay, sir. Now if I go on z-axis, I'll have x, y and 0. So I'll have 0, 0 and minus 1, sorry, plus 1. Okay, and if I go in the x-plane, this opposite of this diagonal, I'll have this as 1, 1 and 0. I hope this is clear, right? Check these points. So if I take this as, let's say, origin, and this as point A, now I have over here as P and Q. So my diagonals are OA and PQ. Diagonals are very simple, OA and PQ. OA and PQ. Okay. So can we find the diagonal OA vector? Okay. So OA vector we can find 1 minus 0, 1 minus 0, 1 minus 0. So means I cap, J cap and K cap. Now same way we can find PQ vector also. PQ, P to Q means 1 minus 0, 1 minus 0 and 0 minus 1. So we'll have I cap, J cap minus K cap. So now we have the vectors of the diagonal form OA and PQ. Now once we have this, I can find the angle, right? Cos theta will be OA dot with PQ divided by OA modulus into PQ modulus. Please check. OA will be what, bacha? Dot product if you take 1 into 1 is 1, 1 into 1 is again 1, and 1 into minus 1 is minus 1. The whole thing is in the modulus. Okay, I hope you know that, right? If you have to take the modulus over here, 1 second. No need to write this, right? Yeah. Let's continue. Let us continue. Okay. OA and PQ, if you take the modulus, we'll have the value as root 3 in the first one. And this also will be root 3. Square of 1 plus 1 plus 1 is root 3. Square of 1 plus 1 plus 1 again will become root 3. Okay. We'll have the answer as 1 and 1 cancel. We'll get this as 1 upon 3. So 1 second. Your cos theta is 1 by 3. Theta is cos inverse of 1 by 3. Since there is no special angles for this, your answer will be this directly, option A. Okay, so this is the end of your MCQ set. Next, 2 marker. Yes, 2 marker. Write the direction cosines of z-axis. Z-axis, okay. So if I'm talking about z-axis here, x, y and z. Angle of z with x will be what, bacha? 90. Angle of z with y will be what, bacha? Again 90. And angle of z with z will be what, bacha? 0. All of you agree? Angle of z with x is this angle 90 degree. Angle of z with y will be this angle 90 degree. And what is the angle of z with z? 0 degrees. So what is going to be the value of this? So your L, M, N is given by cos alpha, cos beta and cos gamma. Cos 90 is 0, cos 90 is again 0 and cos 0 is 1. So this right here is the value of your direction cosines. Direction cosines. Okay, sir. It's a PYQ. Next, direction cosines of y-axis. Same fashion. Y-axis means this is your y axis, this is x axis and z axis. So with y will be what? The angle will be 90. This beta will be 0 and gamma will again be 90. Apply this, you'll get L, M, n in this case as 0, 1 and 0. Same question, again a P by Q. You can see the question repeats like this. That's why the trend I've shown over here. So you can expect the type of questions in each of the categories. If a line makes an angle 90, 135 and 40, what is the direction cosines? So L is cos of 90, because this is saying that 90 with x-axis. M is cos of 135 with y-axis. N cos of 45 with z-axis. So it will be what? 0. It will be in second quadrant, so minus 1 by root 2. And this will be in the first quadrant, so 1 by root 2. This right is the value of your direction cosines. Please check. Yeah, 0 minus 1 by root 2 and 1 by root 2. Next, find the direction cosines of a line which makes an equal angles. Okay, equal angles they're saying, means they're saying that alpha is equals to beta equals to gamma, right? So basically think about it, your cos of alpha will be equal to cos of beta will be equal to cos of gamma equals to a constant, I can say, in this case k. It means L equals to M equals to N equals to a constant k. The property, if you remember, L square plus M square plus N square equals to check here, 1. So I get here 3k square equals to 1. It means k square equals to 1 by 3. It means k equals to plus minus 1 by root 3. So this value of your direction cosines L, M, N will be given by plus minus 1 by root 3, plus minus 1 by root 3 and plus minus 1 by root 3. This is again a 2-marker question. Have a look. It's a PYQ, March 2017. Yes. If a line has direction ratios 2, minus 1 and minus 2, then determine the direction cosines. Okay, so if this is direction drs, means I can form a vector using this drs. I'll have 2i cap minus j cap minus 2k cap. Now can you find the modulus of this vector b? Yes sir, 4 plus 1 plus 4, that is how much? 8 plus 1 is 9, so 3 is the modulus. Plus minus 3 actually. So you'll have the values as, please check, what are they asking? Direction cosines, no? So DCs will be like this, plus minus 2 by root 3. Now this, since this term is negative over here, you'll get minus and plus 1 by, I made a mistake, this will be just 3, no? Yeah, 1 by 3. Again this term is also negative, right? So I'll have here also as minus plus 2 by 3. What's the meaning of this minus plus, sir? It means that the first set will be plus, here minus and here minus. This is the first set. Okay, this is the first set, and second set will be what, bacha? Minus, plus and plus, which makes sense, right? Which makes sense, because if you take the positive sign of the root, which is 3, you'll get all the values as plus, minus, plus, the same format which is given over here. If you take the negative, there will be sign change, so minus, plus, plus. Okay, there will be 2 combinations, right, for the direction cosines. That's what it is mentioned over here. That's also a P by Q for 2-marker. Next, the Cartesian equation of a line here in the vector form. Okay, so in this question you have to first check your coefficient of x, y, z as 1. If it is there, yes, yes and yes, no problem there. Now you're gonna find your vector, the parallel vector. So vector b, we all know, will be 3i cap, 7 j cap and 2 k cap. We get that from here. Now you need to find the vector a. What is vector a? So vector b represents the vector to which the given line is parallel to. So if let's say this is the vector b, and this is your vector, this is the vector a, let's say, okay, the required vector, then this will be parallel to this. It will be lambda vector b. Okay, that's what it is parallel to, and this point represents your point where it is passing from. So this will be your OA vector or vector a. Okay, check here, vector a will be your 5i cap, 4 j cap from here and 6 k cap. because the form is x minus x1, y minus y1 and z minus z1. This is x1, y1 and z1. Now the required answer, general form, check, lambda times this one, 3i cap, 7j cap and 2k cap. Sir, this is the vector form of the given equation in the Cartesian form. Okay, superb. Next, now we are moving to the 3-mark category. Now we're moving to the 3-marker questions. So what happens in 3-marker? Similar concept. Basically over here you'll have derivations applicable, you might have questions on shortest distance and so on. We'll see that, no problem. Now what we have, find the angle between, see, angle between questions also comes. So angle between the pair of lines given by vector r. So check, this is the vector which represents this vector. Let's say if I call this to be line L1, okay, and this is my line L2, then line L1 is parallel to vector B1. This is your vector B1, and L2 is parallel to vector B2. This is your vector B2. Clear na? So basically angle between the line L1 and L2, angle between L1 and L2 is same as angle between B1 and B2, because L1 is parallel to B1 and L2 is parallel to B2. So if you can find the angle between B1 and B2, that will be the answer. Yes, so find that. So cos theta is given as B1 dot with B2 divided by mod of B1 times mod of B2. Let's try. B1 dot with B2 will be what, bacha? 3 into 1 is 3, 2 into 2 is 4, right? 3 into 1 is 3, 2 into 2 is 4 and 6 into 2 is 12. And their modulus, if you check, we'll have over here, this modulus will be 9 plus 4 plus 36. 9 plus 4 plus 36. And this will be what? 1 plus 4 plus 4. How come, sir? Square of this. 1, 2 square is 4 and this 2 square is again 4. Here 9 plus 4 plus 36. Continue. Over here, cos theta, you check. Numerator is 16 plus 3 is 19. Denominator is what? 36 plus 4 is 40 plus 9 is 49. Root will be 7. And here 4 plus 4 is 8 plus 1 is 9. The root will be 3. I'm looking for theta. So cos inverse of 19 by 21. That's my angle. That's my angle right here. Please check. Okay, that's the required answer. 3-marker. P by Q. Next, question number 16. Find the distance between the lines given by distance between them. So check here. This is the same vector, vector B, and this also is same vector, vector B. Okay, so it means they are the same parallel set of lines. Okay, but because the lambda is different, lambda mu is different, it means these two are parallel lines. Correct? No, if it was also lambda means they'll become same line, right? But it is the parallel lines. Check here, lambda is a different constant, mu is a different constant, right? So they are different lines, means these lines are parallel. I'm looking for the perpendicular distance between these two parallel lines. So this is your first line L1 and this is the line 2, like this. I'm looking for this distance D. Works? Yes, sir. Okay, 2i, 3j and 6k. So in this case we're gonna do what? We'll do B cross A2 minus A1. B cross A2 minus A1. Let's find A2 minus A1 first. So this is going to be your A2, let's say, and it's going to be your A1. Let's find A2 minus A1 first. So we'll have a difference, 3 minus 1 is 2i cap. With j cap, 3j minus 2 is going to be again just j cap, and minus 5 and minus of minus 4 will become plus 4, so minus k cap. The cross product will be what? This result, B cross with A2 minus A1 will be a determinant, right? With I, j, k as my first row and the other vectors as it is, 2, 3, 6. And this one will be what, bacha? 2, 1, 1. 2, 1 minus 1, sorry. 2, 1 minus 1. Let's find this value. Let's find this value. So if with I cap, I'll get what? I'll get minus 3 and minus 6. So minus 9, correct? Minus 3 and, excuse me, minus 3 and minus 6 is minus 9. Now with minus j cap, I'll get what? Minus 2, minus 12. Minus 2 and minus 12, right? Minus 3 and minus 6 is minus 9. With j cap, I'll get minus 2 and minus 12, which is minus 14. Am I right? Minus 2 and minus 12. Now plus k cap. Be sure about the calculations, because easy question, only calculation mistake you can do. 2 minus 6, so minus 4. 2 minus 6, so minus 4. Okay, check here. I'll have minus 9 I cap plus 14 j cap and minus 4 k cap. Okay, now we have the formula for distance. So it will be the modulus of this value. Yeah, yes, modulus of this value. So b cross a2 minus a1 divided by mod of b. Check here. This will be how much, bacha? This will be 81 and plus 14 square is 196. No, excuse me, 14 square is 196. I can write it below better. Sorry, it's not d vector, my bad. This is the shortest distance. No, it's a length, not a vector, just d. So we'll have here 81, then we'll have here 196, and the last is 4, so 16 divided by modulus of the vector b. Vector b is given over there. So we have 4 plus 9 plus 36, right? 4 plus 9 plus 36. That's going to be what? 49 only. So take the sum. 6 plus 6 is 12 plus 1 is 13, carries 1, right? Then we have 1 plus 9 is 10 plus 8 is 18, 1 is 19, carries again 1, 1 plus 1 is 2. 293 upon 7 is the distance. Let me just cross check the calculation. 96 plus 4 will be 212, correct? No, 212, and plus 8 will become 292 plus 193. 293 by 7 is the shortest distance. It will be a distance means units. Please check. This is correct. This is your right answer. Okay, moving on. Question number 17. Find the angle between the pair of lines given by, okay, angle between the pair of lines given by, what is it? Angle of this. We can use this now directly. 3, 2 and 6, 1, 2 and this. So cos theta will be what? Dot of these two. 1, 3 will be 3, 2 into 2 will be again 4, 6 into 2 will be 12. Okay, it's the same question actually. Root of this will become what, bacha? 9. Here again 36 and 4, 40 plus 9, 49. Same problem exactly. So we'll have here 16 plus 3 is 19 by 21. 3 and 7. So this is cos theta. Theta value is cos inverse of 19 by 21. 1 second. Yes. 19 over here. 19 by 21. Okay. So you want to see, this was actually a question over here, no? We just did right now. This one, I hope you got this one, right? This question you got, no? Everything is, yeah, this is the answer. No, this is not the answer. Sorry. This is the answer. It's a modulus, right? You'll have a root over here. Excuse me. This is a modulus, means you'll have a root of this thing, no? Same thing I did over here as well, root. We have to use the root here as well. Correct now? Yeah. Root here. Since the length is only positive. So this was the answer. Yeah, same question. 15th and 17th is exact same question. So see, they have repeated this question. March 23 and March 22. Same question has been repeated in different format. It's not the same question because the values of this is different. 2i minus 5 plus 7. And this is not the same, yeah. 3i, 2j minus 4k. So question is different, but the answer is same for both the problems. Means question repetition is there in the exam. Okay. So this answer you please check. This is 293 by 7. 17th is done. 18th now. Find the angle between the pair of lines x plus 3 by 3. Angle between them. First thing is to check the coefficient of x, y, z. Whenever you have Cartesian form, no, check the coefficient of x, y, z. Should be always 1. It's always 1. X, y, z. Here also x, y, z. Now I'm looking for angle between them. So cos theta, multiply the angles 3 into 1. 3, 5 into 1. 4 into 2 is 8. Okay. Divide by root of this 9 plus 25 plus 16. Here we have 1 plus 1 plus 4. I get 8 plus 8 is 16 by this is root 50. This is nothing but 6, right? So 16 by 300, no? Yeah. So it will become 16 by 10 root 3, 2 8s are 2 5s are. So I'm getting here this value of cos theta as 8 by 5 root 3. Rationalize it. Root 3 by root 3. I'll end up with cos theta as 8 root 3 by 15. So theta will be what? Cos inverse of 8 root 3 by 15. Please check. This is your answer. 8 root 3 by 15. A simple question. As a PYQ of July 2019 paper. Next. Question number 19 now. Yeah. Find the shortest distance between the lines. Again, same approach. D is given. This is your B1 here. I think this is not same in this case. So this is B2. So to find here first the line which is perpendicular to both of these lines. Then only we can find the result with the dot product. And this is your A2. And here we have A1. Okay. We have A1. Okay. Let's find A2 minus A1 first. We'll get 2 minus 1 as 1, so I, j minus j is 0, so gone, and minus k is nothing, so minus k cap. J and j will cancel, right? And there is no k cap in the A1 vector. A1 doesn't have any k cap in it. Now let's find B1 cross B2. Let's find this B1 cross B2. Same determinant I, j and k will have. B1 is 2 minus 1 and 1, and B2 is 3 minus 5 and 2. 3 minus 5 and 2, am I right? 3 minus 5 and 2, correct. Check here with I cap. What are you getting with I cap? Minus 2 plus 5, so going to be 7. Minus 2 plus 5, no, so 3. Excuse me, my bad. Minus 2 plus 5, so will be 3 bacha. And we'll have with minus j cap, close look, 4 and minus 3. So 1, 2 into 2 is 4, and 3 into 1 is 3, so the difference will be 1. And with k cap, what do we have? We have minus 10 plus 3. Minus 10 over here and plus 3 means minus 7. Okay. This is my B1 cross B2. So I get B1 cross B2 as 3i cap minus j cap and minus 7 k cap. Now this is given as d equals to, not d vector, d modulus. It's going to be a length, no? So d will be equal to dot of these two. So A2 minus A1, excuse me, not B1, A2 minus A1, this vector's dot with B1 cross B2 by mod of B1 cross B2. Check. Dot of these two will give me I and I, so simply 3, and minus k into minus 7. So plus 7, correct, no? I into 3i is 3, minus k into minus 7k will become plus 7, and since there is no j, this will be ignored or simply 0. 3 plus 7, this will be modulus because we want a positive value. Modulus of this, check. This is dot, no, dot will be a scalar quantity. The modulus of this, I'll have over here as 9 plus 1 plus 49, right? So 59, I guess, correct, no? 9 plus 1, is it 1 correct? With j, let me check here. 4, 2 into 2 is 4. 1 second, sir. IJK, no? 2 minus 1 and 1, and 3 minus 5 and 2. That is correct. So we have this j is cancelled. 2 2s are 4 and minus 3. That's correct as 1. So if I take minus j, check here. 9 plus 1 as 10. 10 plus 49, correct. So my answer is coming as 10 upon root 59 is the answer, or 10 root 59 by 59, your choice. Yeah, this is the final answer. Question number 19, please check. Yeah. Question number 20 now. Derive the equation of a line in space through a given point. Okay. So let's say this is the point given over here. This point is A. The coordinate is given as x1, y1 and z1. From this point a line passes. So line is passing like this, let's say, and this line is parallel to a given vector b. vector B, and this vector B's component is what? Let's say we have A I cap, B j cap, and C k cap. Okay, this is the vector form of the vector B, and this is parallel to this vector. I take a point on this with the coordinate, of course, x, y, and z, any arbitrary point, okay, then this is your origin, and this becomes your position vector of the point A. So will be, let's say, vector A. Okay, I'm looking for derivation, right? And this is your resulting vector, vector R. Am I correct? Yeah. So can we write the vector OA over here quickly? OA will be same as the position vector A. OA is the position vector of the point A, right? So x1 minus 0, this, what is the coordinate of the point 0, origin? 0, 0, 0. So x1 minus 0 is going to be x1 I cap, y1 minus 0, same way, y1 j cap, and z1 k cap. So this is my vector A. Okay, same way we can find vector R also. So OP or vector R will be given as, check here, x minus 0. So x I cap, y j cap, and z k cap. Okay, z k cap. Good. So we have x I cap, y1 j cap, and z k cap. So I have the vector A and R now. So now I'm looking for your yeah, we also know that since AP is parallel to the vector B, so vector AP will be nothing but lambda times of vector B. Okay, so how would you write this? Now in the triangle OAP, check, I can apply triangle law of addition, okay, and I'll get what? Please check. Now in this time I'll get OA plus AP is equals to OP. What is OA, bacha? OA is vector A. So I can write here OP equals to OA plus AP, right? So I can replace this as OP as vector R. Check here, OP is vector R, OA is vector A, and AP is nothing but lambda times of B. Now this is your vector form. This is your vector form. We can put the values of OA and OP from there. Put the values of OA and basically A and R from there, and B from this. This is your vector B. Got it? The vector form is clear, but they're asking us for both vector and Cartesian form. This is a common question, repeats almost every year. Check. So how to write the vector form, bacha? So for this, no, I'll use this space. Vector R is given as vector A plus lambda vector B. We have the vector R now, x I cap, y j cap. I can write this in some better space because I need the space. Yeah, right from here. Vector R is x I cap, y j cap, and z k cap is a vector R. Vector A is x1 I cap, y1 j cap, and z1 k cap. Lambda is just lambda, and B is what? A I cap, B j cap, and C k cap. Cross check once. A is here, R is here, and B is up there. Okay. So there are two messy statements. I'll just say rewrite that. This one. Okay. 1 second. This is j cap, and this is, what is it? Z1. Okay. Now can I move this vector over here? So I'll get this x minus x1 I cap plus y minus y1 j cap and plus z minus z1 k cap. Okay. Now this is equals to this side, lambda a I cap, lambda b j cap, and lambda c k cap. Now can you compare the x, y, z component on both sides? Yes, sir. So we'll get here, bacha, x minus x1 equals to lambda a, y minus y1 equals to lambda b, and z minus z1 equals to lambda c. From here we get what? X minus x1 upon a as lambda, y minus y1 upon b as lambda, and z minus z1 upon c as lambda. Now since they are all equal to lambda, I can eliminate the parameter lambda and write this directly as x minus x1 by a equals y minus y1 by b equals z minus z1 by c. Now this here is your Cartesian form. Cartesian form. Here was the vector form and this is the Cartesian form, one of the important question as per your syllabus. One more time. Yes. Next, the last question for this particular session. So that the line given like this are perpendicular to each other. For perpendicular line, what happens? This is the property. Perpendicular line, the property is A1, A2, B1, B2, C1 should be 0. What is A1, B1, A2? What is A1, A2, B1, B2 and like that? This is your A1, B1, C1. And this will be your again same thing, A2, B2 and C2, provided that x, y, z coefficient is 1. If it is not 1, then you have to make the change. Okay, so please check that x, y, z is always 1, then only you can say that it is A1, B1 and C1 like this. This is your B1, okay? Alright, so if you find the value 7 into 1 minus 5 into 2 and 1 into 3, check here. 7 minus 10 plus 3, how much is this coming as? 0. It means therefore the given lines L1 is perpendicular to L2. This is my line L1 and this is the line L2, they are perpendicular. Okay, so proven. This is the end of your questions from this session on your 3D geometry. What I'm going to do today is I'm going to give you a set of questions which will help you directly score that one question, getting that one question right in the examination from the chapter linear programming. Okay, so first thing first is understanding our weightage. Weightage is very simple, sir. We have one question in total 6 marker, but I have brought some MCQs as well. Why MCQs? Because definitions are important to understand and I want to explain those definitions with the help of MCQs over here, with the help of questions over here. So I have brought a total of 10 questions, 3 PYQs, which is going to be highly relevant for your preparation. Solve these PYQs means your preparation will be complete from the chapter LPP. 6 marker question comes. I've taken 3 6-mark question and help you solve it with the different varieties which is possible. MCQs, let's try solving the number 1 from here. First MCQ. Every point of feasible region is called as what? These are definitions, bacha. As I said, I've taken MCQs to help you learn the definitions right. So first definition, every point of a feasible region is called as feasible solution. Answer is option C. Move on. Next, the feasible region in LPP is always what? Always convex in nature. Not bounded, unbounded. They can be both, right? They can be unbounded at the same time. For example, if I have a condition like this, where this is my, let's say, curve, I can have an area in this fashion. Okay, I can have this as my feasible region. This will not be bounded anymore, but it will always be a convex shape. It will always be a convex shape. Okay, next. Okay, question number 2 is done. 1 was C, 2 was also C. Next. Third one, a coordinate points of feasible region determined by the following system of linear inequalities. So they have given this as inequalities, first one, second one, and you have, what is this called as? Non-negative constraints. X more than 0 and y more than 0 is called as non-negative constraint to keep the whole graph in the quadrant number 1. Okay, they are already given the coordinate point 0, 0, 5, 0, 3, 4 and 0, 5, and this is your objective function, will always be a linear function where P and Q are 2 values which is more than 0, a positive value or non-negative value. Condition on P and Q, so that we are looking to find a condition for P and Q so that maxima of Z occurs at 2 points 3, 4 and 0, 5. Okay, so means Z max will be occurring at 2 points 3, 4. What is Z? Px plus Qy means 3x plus 4y, and we get one more time Z max as using the point 0, 5. So 0x plus 5q, my bad. It is px, no? So 3p and 4q. 3p and 4q, because x value is 3 and 4 and 0 and 5. They should be equal. So I get here 3p plus 4q is 5q. Move on this side, you get 3p equals q. Equals q. 3p equals q means option is
D. So they were asking us to find the relation between P and Q, provided that in the corner points given to us, the maxima occurs at these 2 points. Maximum is there will be equal value, so I have taken that and get the answer as option number D. Clear? Okay, sir. Fourth one. A corner points of a feasible region is again given. Z is also given, Px plus Qy. They are asking us to find the condition of P and Q. Again, similar question. We have the 2 corner points where the maxima occurs. So right here, 15P, 15Q equals to 0 and 20Q. On this side we get, okay, same result also. 15P equals to 5Q, 5 3s are, I get 3P equals Q. 3P equals Q. Same question, different kind of values. That's it. 3P equals to Q. Corner points of feasible region for LPP are 0, 2. Again, this is a very important concept. Please bear with me. We have corner points given. We have the function also given. They are saying that the minimum value of Z occurs at which point? So we have to find the minimum value. So right here, corner point and Z value. The corner points are given as, so we have many corner points, but if you check the options, we are considering only 2, 0, 2 and 3, 0. So we'll take only these 2. Because others are not considered in any of the options, so we'll not go and check them out. Okay, 0, 2 and 3, 0. Sorry, 3, 0, not 3, 2. 0, 2 and 3, 0. Check the options. That's right. At 0, 2, what is the Z value? I'll get this as 0 into 4, 6 into 2 is 12. 3 into 0, I get again 12 plus 0, 12. So you're getting the same value, right? It is the minimum value. They're saying it is already a minimum value, but they are same value you can check. Okay, so basically Z minimum is coming as 12, and at both the points, it means at all the points joining, that's a property, joining all the points on the line joining the point, what? The coordinate 0, 2 and 3, 0. So a line will join these points, and on that line every point will be Z minimum equal to 12. So any point on the line segment joining the points 0, 2 and 3, 0. Option is D. Extremely important question. Moving on to next one, 6th one. The corner points of the feasible region is given. The maximum value of the function is what? Same reason. We have the corner points right here, CP 0, 0, 0, 50, 30, 0 and 20, 30. Z you write over here. Substitute the values of X and Y. For the first one, 0. 0, 50 means simply 15 to, we'll put Y, no? So Y is 50. 120 over here. 120 into 30 into 4 is 120. Last one, 20 into 4, 80 and plus 30. Answer is 110. What are they asking? Maximum value. Answer is what? Option D, 120. So write the corner points, check the value of the objective function at each of the corner point, whichever is maximum, that is your answer. Very simple. It's a PYQ, you can check over here. That's why I've taken here. It's relevant as well. Less likely to get a PYQ from here, sorry, MCQ from here, but since it is there, no, you can see there are PYQs, no, both the previous questions. That's why I did not want to ignore this. Okay, and also helps us build the definition and understanding of the chapter. In a linear programming problem, the objective function is always linear in nature. The question is what? Linear programming. Answer will be linear in nature. So option is C. You can see, no? What is this? Linear equation in 2 variable. What is this? Linear equation in 2 variable. This also here. Linear equation in 2 variable. So every equation is linear equation in 2 variable. That's why the answer for 7th one becomes linear function. Okay, done. Next, now it's time to move on to your 6 markers. 6 mark questions. Okay, let's look at the first one. So be careful. I'm going to explain everything in detail for this question first, and then we'll try to explain everything in detail for the other 2 as well. I've taken total of 3 questions. All the 3 are PYQs. Let's look at the level of these problems and understand everything which is there in the questions one by one. Z is 3x plus 2y. That is my objective function. I have to maximize it. Subject to the constraint which is given over there. I've taken the axes. I've taken the axis x and y over here. I'll talk about only plus side because we are having x more than 0, y more than 0 means, what is it? Non-negative constants are given, so only first quadrant. Okay. Now, we have two inequalities here, first and second. So, we'll write, first step is to write what? Your inequality without the inequality basically. So, write the equation like this. When put x as 0, you're going to get y as 5. Put x as 0, y will be 5. Next, put y as 0, you'll get x as 10. With this, you've got what? You have got 2 points, okay, coordinate of 2 points. x0, y is 5, x10, y is 0. So plot this line, x0, y is 5, something like this is there. This is the point 0, 5, and this is the point 10, 0. The line is what? X plus 2y equal to 10, right? Equal to 10. Now second one, 3x plus y is 15, right here. 3x plus y equal to, we'll write, put x as 0, we'll get y as 15, and this time put y as 0, you'll get x as 5. Check here, 0, 15 is somewhere over here. We don't have to be accurate, 0, 15, and 5, 0 somewhere over here. Okay, this is your curve, 5, 0. All right, now let's look for the inequalities. After plotting the lines, let's look for the inequalities first. Okay, check here. So first inequality is less than sign, means below this line. Below this line. Other inequality also is less than. So below both the lines basically. This also below, this also below. What is the answer? This particular reason is my, this is called as your feasible solution. This is called as feasible reason basically, first of all. Feasible region or solution. Okay, now write the corners. This is your origin, so 0, 0. We are missing this point. Let's call this to be point O, this to be point A, this to be point B, and this to be point C. Okay, point C. Now how do you find the coordinate of point B? By taking intersection of the lines which is given to you. Take here, we have x plus 2y as, what is it? 10. Another one is 3x plus y. So make this as into 2. Okay, just a second. 3x plus y is there, no? Equals to 15 is there. Multiply this with 2. Check, this will become what? 6x plus 2y equals to 30. Now write this equation again. X plus 2y equal to 10. Subtract, you have minus sign here. This is cancelled. You get 5x equals to 20. It means x value is what? 4. X value is 4. If you put here x as 4, it will become x plus 4 plus 2y is 10, means y has to be 3. If this is 4, sir, I'll get 4 on this side. It will become minus 4, 6. 2 into 3 is 6. My point is nothing but 4, 3. Point is nothing but 4, 3. Check carefully. I have all the 4 coordinate points now for my feasible reason. O, A, B, C. Write the coordinate points. What is it? O, A, B, C. This is origin, so 0, 0. A is 5, 0. B is 4, 3. And C is what? I think 0, 5. Let me check. 5, 0, 4, 3, 0, 5. My coordinate points are mentioned now. Next step to write what? Next step to write z. What is z value given as? 3x plus 2y. 3x plus 2y. This is the 6-mark question and very simple one. So do not make silly mistakes and do not make any mistakes in the steps. Very, very important. Put here, this is going to be 0. 3 into 5 is 15. And this is 0 going to be 4 into 3 is 12. Plus 3 into 3 is 9. So that's going to be 21, right? So 3 into 2 is 6, no? My bad. Yeah, see, silly mistakes. 4 into 3 is 12, 3 into 2 is 6. Okay, that's 18 and 10. I'm looking for what? I'm looking for maxima. Maximize. Okay, so I can write here Z max is 18 and occurs at what point? Occurs at the point B, 4, 3. This is your final answer. Please check one more time from the beginning. First you draw plotting the number line, plotting the graph on the curve on the graph over here like this, getting x and y values. When you do that, get the intersection point and check the inequality to know the which area, which downward or upward to take the arrow sign. Draw the arrow sign in the graph and just try to draw a neat curve, not up to the graph only, okay, and then plot the corner point to get the values of the coordinate of the corner points and simply find the z values. They're asking maxima, so look for maximum value, get which point this is occurring at. So your maxima occurs at 4, 3 as 18. This is clear, sir. Question number 9. Let's move on to now. Question number 9. Again, March 2023 paper. Please check. It's a PYQ. Minus 3x plus 4y is there. I want to minimize it. Subject to the constraints over there. We have in this case again two constraints, x plus 2y and 3x plus 2y. Okay. So let's try the first one. X plus 2y equal to 8. Put x as 0. You'll get y value as 4. Put y as 0, you'll get x value as 8. So 0, 4 and 8, 0. This is the curve. The curve equation is x plus 2y equals to 8. Right? Next, the other one, what do we have? 3x plus 2y equals to 12. When x is 0, y is 6. When y is 0, x is 4, right? X is 4. 2 into 6 is 12. 3 into 4 is 12. So we have 4, 0. This point was what? This point was, I forgot to write, 8, 0. And we have one more point, 4, 0, right? So somewhere over here, 4, 0. And the other one is what? 0, 6. So this was 0, 4, I guess. Yeah, 0, 4. Somewhere over here, 0, 6. So my line is this one. Okay, the curve is 3x plus 2y equal to 12. Now check the arrow sign before I start finding the intersection point. For the first one I have less than this equation. Less than means somewhere like this. And for the other one I have again less than. So I again go in this format only. Okay. So my required region becomes again this is the feasible region or feasible solution. Feasible region or solution. The points are 0, 0 origin. This is the point A, and this is the point B, which is an unknown point, and this is the point C again. Let's find B now. We're gonna solve the two equations that we have. Let's try. So we have here 3x plus 2y equals to 12. X plus 2y equals to 8. Difference you check. You'll be having here 2x equals to 4 actually. This is cancelled. X is 2. Put in the first equation. We have x plus 2y equals to 8 and x is 2 plus 2y is 8. It means y will be what? 3. 6 plus 2 is 8, right? So point is what? 2, 3. Simple calculations. Do not make any silly mistakes over here. Now we have the corner points and z. What is the corner point? So point O is again 0, 0. Point A is 4, 0. Point B is 2, 3. And point C is what? 0, 4, I guess. Please check. 0, 4. Yeah. Now, what is the objective function? Minus 3x plus 4y. We have to minimize it. Minus 3x plus 4y, we have to minimize it. Yes. Put the values back. This is going to be 0 here, minus 12, and 0. We have here minus 6 plus 12, which is nothing but 6. Have a look. Minus 6 plus 12, yeah, correct. Over here we'll have 16, right? So I'm looking for minimum. This is my answer. So Z minimum is minus 12 and occurs at x equals to or the point A, which is 4, 0. This is my answer. A very similar question. So that's what you can see. The trends are like this only. The questions will be, so maximum they can give you a trouble giving you a, what do you call, a linear equation format from word problems. It can be any question, right? Means you have to use the words to form the equations, means assume two variables x and y. Have you done that question? Of course, in grade 10. Remember the chapter pair of linear equations? You're going to use that to make the constraints. That's the most difficult question they can ask, okay? Otherwise the questions will be solved like this fashion only. Let's move on to solve the last question of the day in this chapter, okay? Minimize z equal to 5x plus 10y subject to the constraint. We have 3 in this case, okay? The 3 constraints. Again, this is the PYQ of March 2019. All right, sir. X-axis, y-axis. What is the first step? Steps remain same. Take the inequality one by one and write in the equation form. First one is x plus 2y equals to 120. When x is 0, one second, y will be 60, and when y is 0, sorry, my bad, when y is 0, I'll have x as 60, sorry, 120, no? When x is 0, y is 60, when y is 0, x is 120, okay? So, x is 0, y is 60 somewhere over here. Do you have bigger value than that? No. Like this. This is going to be 0, 60, and over here you'll have something like this. Please check. 120, 0, and the curve's name, I hope you remember, x plus 2y equals 120. Equals 120. Clear, right? Yes, sir. First one is clear. Great. We just extend it on this side as well. Yeah. Second constraint, x plus y equals to 60. This is easy. X is 0, y is 0, okay? And when x is minus 60, y will be again plus 60, right? So this is a equal constraint, basically equally inclined, equal intercept form. So we have 60 over here, and this is my line. This point is 60, 0. This point is x plus y equals to, how much is it? 60, right? Okay, when x is 0, y is 60, and when y is 0, x is 60. Correct. All right. And the last one, x equals to 2y from here. X equals to 2y from here. It means this is a line. X equals to 2y. Got it? Check from here and draw the arrows. First one, less than, means below this. Below this one, the first one. Second one, above this, means above this one. And the last one, y is more, right? Sorry, y will be, less. If I move on this side, I'll get y less, means over here, below. Correct, na? If you move on this side, you'll get 2y less than, you get what? X is more than 2y, or 2y is less than x. So y is less means we're going to go downwards. Always look for the y side, okay? So this is my feasible reason in that case. And my coordinate points are A over here, B over here, C is this, and D is this. We have 2 unknown coordinate points over here, and this right here is my feasible reason. Feasible reason. Okay, let's start solving it. First we'll solve this equation x plus 2y with this one. What do we have over here? Let's solve this equation to get the points. X minus 2y equals to 0. And over here x plus 2y equal to 120. Am I right? Add it. Cancels, we get 2x as 120. It means x value is 60. If x is 60 means y will be 30, right? 60 minus 30 will be, 30 into 2 will be 0, right? So I have this point as, this point C will be, 1 second. This point C coordinate will be what? 60, 30. X is 2 times of y. What about this point D? What about this point D? In this case, we have to solve the equation x 2y and x plus y. So x plus y as 60 and x minus 2y as 0. Subtract these, you get minus sign plus sign over here. This cancelled. Check over here, you'll get 3y equals to, it is coming as x plus y as 60, right? Not 6, yeah. So 60, I get y value is 20. If y is 20, x is double of that, means 40, 20. 40, 20. Y is double of that, means 40, 20. So now we have all the 4 corner points. Okay, continue. Corner points and Z. So point A I have, B, C, D. Point A is, if you remember, 60, 0. Point B is 120, 0. C is 60, 30. And D is 40, 20. Am I right? 60, 0, 120, 0. Check here. 60, 0, 120, 0, 60, 30 and 40, 20. Correct. Z is what? 5x plus 10y. Z is what? 5x plus 10y. This value right here. Let's find the Z for each of these, and we are looking to do what? We are looking to do what? Excuse me. Here. 1 second. We are looking to find the minimized value. Check. Moving on. 5, 6 is 30, so 300. Y is 0. 120 into 5, so 600 plus, okay, that is gone. 10 into 0 is 0. 60 into 5, 300 plus 3 into again 300, right? So 600, right? 300 and 300 is 600, not 60, 600. Next, 40 into 5 is going to be 200, right? Plus again another 200. 10 into 20 will be 200. Answer is 400. I'm looking to minimize it. This is the smallest value. So Z minimum is 300 occurring at X. So occurring at the point A, which is nothing but 60, 0. Now this is my final answer. Z minimum is 300 at the coordinate 60, 0 over here. And this marked region is my feasible region. I hope this is clear for all of you. This is my feasible region. Got it? Yes. Please have a look from beginning with the chapter probability. An important session. Reason, simple concepts are there. We have independent events, we have conditional probability and Bayes theorem. Calculations are also very simple. Only challenge that we have to face here is every question is unique. Means every question that comes to you will be a word problem. You have to break it down in simple way and then apply your learnings. So first we'll learn about the weightage. Check. The weightage is like this. We have 3 questions from 1 marker. Okay, this can be a fill in the blanks and MCQs. Then for 2 marker we have 1 question for 2 marks. 3 marker again we have 1 question. Total of 5 questions carries 8 marks. Yes, the most the weird part or something which is difficult in nature, even though the questions are MCQs or 1 marker, the question will be of a category that can be asked in the 2 marker and 3 marker also. Confusing? What I'm trying to say here is very simple. The question that comes for MCQs that can also be asked, same question can be asked for 3 marker also, 2 marker also. That's how the level of questions are even in the 1 marker side. That's unfair for us because if it is 1 marker, the questions would be easy. It's not in the case of probability. You have to solve the big problems to get the 1 mark also in MCQs. Let's start solving the questions now. So check, in the session today I have brought for all of you 12 MCQs. As I said, MCQs are not just MCQs, they are equivalent to 2 mark and 3 mark questions. That's how the level is designed by your boards. And 13 to 20, your last 8 questions are 2 marker and 3 marker. So if you solve these many, you can clear all the concepts, all different types of concepts in your syllabus, and certainly you can score 8 out of 8 marks in your boards. Question number 1, that is MCQ. Let's solve this. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Okay, means if I am getting a 6, let's call the event to be E. I get 1 by 6. If you throw a die, total number of occurrences or event will be 1, 2, 3, 4, 5, 6. So total will be 6. And getting a 6 is 1 event, so 1 out of 6. Okay, not getting a 6 will be 5 by 6. Okay, and when he reports, what are they asking? That he reports it is 6. He reports it is 6 and he reports something and it is what? 6 only, right? He reports something and it is 6 only. So what will that be? Let me check. He throws a dice and reports that it is a 6. Okay, he reports something and it is a 6. Correct, that's what they're asking us. So let's say he reports and he's saying the truth. Means he reports and he gets the 6. He's telling the truth, means 3 by 4. He reports and telling the truth means 3 by 4. Okay, and he reports and lying. Reports and lies, so not getting a 6. He reports it is a 6. Listen to me. He reports that it is a 6 but doesn't get a 6. That will be a lie. So you get 1 out of 4 times. So confused here. So confused here. Don't worry.
I'll just take a moment to explain you again, because this question can be asked in 3 marker as well. So I will explain one more time, so listen to me carefully. He reports something and tells a truth, means whatever it says is a true, okay, it's a truth statement, means he is reporting that you are getting a 6 and he's speaking truth, means 3/4 is the chances of that. Now whatever he speaks is a lie, what is the chance of that? 1 minus 3/4, which is 1/4. Okay, I'm looking for this statement. We can apply the Bayes theorem now. Remember Bayes theorem, very simple. Same thing is there, means we're gonna go with PRE into PE. What is this part, bacha? This part represents your conditional probability. Okay, you get here PR intersection E. Okay, this is nothing but PRE into PE. Okay, and the total probability will come over here. This will be total probability in the denominator, so we'll get both conditions of getting and not getting, means when it lies and when it speaks the truth. So PRE PE, same thing, and when it lies, so PRE dash and PE dash. Calculations, simple ones, check. So when he reports and gets it right, check here bacha, what we have, PRE is 3/4 into getting the event right, 1/6. Same thing will come over here, right? Very important question, can be asked for 3 mark as well. And when he reports and he lies, so 1/4 and 5/6, right? 5/6, P dash is 5/6. Check here, 4, 6, 24, so we can cancel 4, 6, 4, 6, 4, 6. You can take 24 common, right, in the denominator side, and we get 4, 6 cancels. We have numerator as only 3 into 1, which is 3. Here we have 3 in the first term and 5 in second term. We have the answer as 3/8. Option C is correct. If you are confused how did I do the calculation, don't worry, stop the video right now and go and try your own calculation. You'll get the same result as 3/8. Answer is 3/8. Good question. Can be asked for 3 marks as well. A Bayes theorem. Let E and F be the event of a sample space S of an experiment. Okay. Sample space S, event E, event F. Event E, event F. Okay, they're asking us this value. We can apply what? Our conditional probability. Check. PE intersection F divided by PF plus PE dash intersection with F divided by PF. Take LCM. Okay, what we have over here? P intersection of E with F plus P intersection of E dash with F. Okay, got it? Think about it. E intersection with F is this one. This is your P of intersection of E with F. Clear? First part. So think about it. What is E intersection? E dash with F. What is E dash, bacha? So the E dash will be, E dash is everything but E, right? So this is my E dash. Everything but E, sir. Everything but E is this part, right? This is the condition of E dash. Everything but E. Intersection of that with F. Intersection of that with F. What is the answer? E. Okay, F in it, there's no E. Okay, there's no E. Intersection, if you take the intersection of that with F, you'll get this strip, this F part, and that you combine or add with the intersection of E and F, you get the whole F. So PF by PF is 1, and that is nothing but probability of the sample space. I know I took time to solve this question, to explain this question, because I know even though many of you will get it right at once, but there are many students, thousands of students that will not understand this question that easily, and I'm here to help them as well, right? So it's okay if you don't understand in the first go, please watch it again. I've tried my best to explain you this problem. It is very, very good question. Number 3. PA equals to half of PB, which is 0. Okay, what is the value of, okay, PA is, excuse me, not wrong, I'm wrong, I read it wrong. P of A is bacha 1/2, P of B is 0, that was given in the question. They're asking us P of A slash B will be what? PA intersection B upon PB. Since PB is 0, this whole thing becomes infinity, so not defined. This is an easy question. This is an easy question. So that also comes, right? Let's move on. 4th. 2 balls are drawn at random with replacement. With replacement means the total will remain same. If you take something out and put it back, replaced, the total will remain same.
from a box containing 10 black and 8 red balls, then the probability that first ball is black, okay, and second is red. So two chances, two draws are there. Two draws. First is black and second is red. Black total is what? Check here. 10 black. So 10 out of 18. That is my first draw. If I have to pick the black, right? Black is given as 10 and the red ball is given as 8. I have to pick the black, means I'll pick from 10 out of the total 18. And the red is what? 8 out of 18. Simplify these. You'll get here 5, 9, 4, 9, 5 4s are 20, 9 9s are 81. Why multiplication, sir? Because I want both at the same time, right? It's an AND condition. It is AND condition, that's why multiplication. Answer is option A. Simple question. A very, very simple problem. Next. Fifth one. Two cards are drawn at random without replacement. Without replacement means this time the numbers will decrease from a pack of 52 cards. Two cards are drawn means we'll draw two boxes. First we'll have what? Total of 52. Next we'll have what? 51, right? Because you've taken one of the card out and there are only two draws. First draw, second draw. What is this, sir? First draw means you're taking one of the card out. Okay, this is the second draw. When you draw the second card, it will be already reduced by 1. Total will be reduced by 1. Both cards are of the same color. Okay, so this will be what? Same color means I can have either red cards or black cards, right? Red is 26 and black is what? 26. So if I get black, I'll have what? I'll have 26 over here. If I get, let's say, one less, now I'll become 25. Any problem? No, sir. This is going to be what? 2. Multiply them. We have only 1 over here. 25 into 1 is 25. 51 into 2 is what? 102. Check. Check, please. Simple question. Okay, next. Sixth one. 3 cards drawn successively without replacement. Superb. So, 3 boxes without replacement, sir. Okay, and it will be all what? Multiplication, because they are all drawn at the same time, means AND condition. Okay, shuffle deck. First 2 cards are king. So first I'll have 52 cards here, then I'll have here 51 cards, I'll have here 50 cards. What is happening? First draw there were total cards, second draw 1 card is reduced, third draw 2 cards is reduced because we have without replacement case. Yeah, 52. Okay, 52. Check. I'm getting the first 2 cards are king and third card is an ace. So king. How many kings I have, bacha? Total of 4 kings. And ace, how many I have? 4. So I get here 4 by 52. First one. Next, I have already taken 1 king out. I'll have what? Only 3 kings left. I'm not putting the card back. Okay, so 4 kings were in the beginning. Once you took the king out, you get only 1 king. Okay, 1 less king left, that is 3. And aces. How many aces are there? 4 aces. So write there 4. Simplify. You get 1 by 13. And you get 17, right? So 1 by 17, and you get here 2 by 25. So answer will be 2 upon 13, 17, 25. We can multiply. 13 into 17 is what? 13 sevens are 91, so carry is 9. 13 into 1 plus 9 is 22. 2 to 1 into 25. Okay, this value will be more than 500, I guess. Yeah, 5000 actually. So answer will be what? 2 upon. We have only 2 options of 2. This one and this one. Option A. How come, sir? Think about it. The last digit will be what? 5. 5 into 1, right? The unit digit is 5. So means I cannot cancel the 2 with the number because it is an odd number in the denominator. First clue. Second clue. 25 into 200. 5000. So of course it will be more than 5000. Hence the answer is option A. Second option has less than 5000. Getting it? Don't multiply, just get the result. Next, 7th one. A die is tossed thrice. Okay, a probability of getting an odd number at least once. So I want odd number at least once, right? Odd number at least once. It means what is it? 1 odd, or I want 2 odds, or I want 3 odds. We have 3 spaces over here. Please check 3 boxes. Box 1, box 2, box 3. box 1, box 2, box 3. In one of the setup, what is the chance of getting, how many are there, bacha? We have total odd will be, odds are 1, 3 and 5. And total is what? Total is what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Means getting the odd is what? Probability of getting the odd is 1 by 2. Probability of getting the even is also 1 by 2. This is clear, right? Basic understanding of how the die is tossed to get odd and even is clear. Okay. I want at least one means more than one. 1 and more than 1. So 1, 2 and 3. But not 0. Means probability of getting at least one one odd. At least one, right? At least one odd will be equal to 1 minus probability of getting what? 0 odds. Correct, no? Means probability of getting 0 odd will be a case, right? We'll have a case where it is probability of what? 0 odd. Think about it. What is that going to be? Only one case like that. 0 odd means what? All is even. 0 odd means all is even. Means it can be 2, 2, 2 like that. Yes or no? Yes. So probability of getting all odd. Sorry, or 0 odd. Probability of getting 0 odd means what? All even. 1 minus probability of getting all even. I'll explain this step again. I'm looking for probability of at least one odd. At least one odd. Okay. At least one odd means 1 odd, 2 odd and 3 odd. This basically means that probability of getting at least one odd means that 1 minus, total probability is 1 minus getting the, remove the basically 0 odd case. Remove the basically, see here, 1 odd, 2 odd, 3 odd. What is the remaining case? The 0 odd, right? No, we have 3 boxes. I can get 1 odd, 2 odd or 3 odd numbers, or I can get none of them as odd number, all evens, right? So 0 odd means, what is it? All even. I can change some spellings over here. This is 1 and this is 0. Okay, I can rewrite this. Check here. This is at least 1 odd. Okay, and this here is 0 odd. To have less confusion about this. Okay, so probability of getting 0 odd you can remove. 0 odd means what? All even. 0 odd means all even. What is the answer for all even? Check here. Means I want the spaces that we have to get even numbers only. For the first one, 3 by 6, 3 by 6, 3 by 6. What is it? 1 by 2, 1 by 2, 1 by 2. What is the answer? 1 by 8. What is the answer over here? 1 minus 1 by 8. Answer is 7 by 8. Option B. Sir, you took too much time to explain this question. As I said, can be asked in 2 marker also. Can be asked in 3 marker also. Okay, that's why I took some time over here. So I hope you got the concept behind it, because I understand many of you I've seen students, I've taken a lot of classes, and many of you struggle in the concept side, problem side of your chapter probability, and it has 8 marks with simple calculations. So I'm here to help you in that. Question number 8 now. If A and B are any 2 events such that PA plus PB minus PA intersection B, they have given that PA plus PB minus P of A intersection B is PA. PA cancels, so I'm getting this as PB equals to P of A intersection B, right? Check here. So I'll get what? P of A intersection B upon PB equals to 1. This is the formula of conditional probability of A slash B. Yes or no? What did I do? Simplified this, cancelled, moved on the other side, divided by PB is 1. Here we get PA conditional B with, okay, is 1. So option B. Yeah. Question number 9 now. Question number 9 now. If A and B are 2 events such that PA is non-zero, PBA is 1. PBA means B intersection with A upon PA equals to 1. Cross multiply, PB intersection A equals to PA. Listen to me. Draw the Venn diagram. Here is B and here is A. How come, sir? Intersection of A and B is A. Listen to me. Intersection of A and B is A. Intersection of A
this small one and the B is A. It's true, sir. This is correct. This is right, sir. It means actually A is the subset of B. A is contained in B or subset of B. Answer is option A. Didn't I tell you that I will cover up everything which is there in your syllabus with these questions that I've taken today? These are the PYQs and the most expected questions for your preparation of chapter probability. Next, 10th one. The probability of solving a specific problem independently by A and B are 1 by 2, 1 by 3 respectively. If both try to solve the problem independently and the problem already is solved, okay? Anything else is given? They're saying they're both trying to solve the question and it is solved. So A union B, right? So PA plus PB minus P of A intersection B. Listen to me. What are they saying? They both try and they are ending up solving the question, okay? What is the probability of that? Check here. This answer will be 1 by 2, 1 by 3 and minus independent events, right? They are independent events. It means product of those two. 1 by 2 into 1 by 3. LCM will be 6 here. 2 3s are, so 3. 3 2s are, so 2 and minus 1. 3 plus 2 is 4. 5 minus 1 is 4. Answer becomes 2 by 3. Option B. Option is B. Listen to me. They're saying both try to solve it together, okay, and they get the result done. Okay, what is the union? Independent means union. Okay, union we take PA plus PB minus PA intersection B. Remove that statement. Since they are independent events, I can multiply to get the result. PA into PB, 1 by 2 into 1 by 3 is 1 by 6. Take the LCM of all of that, you get the answer as 4 by 6. Hence 2 by 3. Option B is correct. Same question. In this case, exactly one of them solves it. What it means? A solves, B does not solve, plus A does not solve and B solves it. Right? Okay. Good, sir. Think about it. A, B. A solves but B does not solve. Listen to me. A solves but B does not solve. Only this, sir. This is your first condition. And how do we write this? So from P of A, remove P of A intersection B. Please check. Please check. A solves, B does not solve is this shaded part. That is nothing but from P of A, remove the intersection part. What about this, sir? What about this right here? A does not solve and B solves. A does not solve, only B solves. What is it? Nothing but, check here. From B, remove the intersection. From B, remove the intersection, you get only B. Okay, this is only A, this is only A, and this is what? Only B. Your way of writing it. Okay, take here, you get P of A plus P of B minus twice of P of A intersection B. This and this becomes 2 times. P of A is what? 1 by 2. P of B is what? 1 by 3 minus 2 times of product of those two is 1 by 6. They are independent events. Question was same. They are independent events. Cancel this. 1 by 3. So 1 by 2 plus 1 by 3 minus 1 by 3. What is the answer? 1 by 2. Answer is 1 by 2 D. Good question or not? So the question that I've taken can be asked in 2 marker and 3 marker. So be ready for that. Every question is important in this session. Next one. This is your partition of sample space. E1, E2, En. Okay. Partition sample space. I hope you remember this. How we create partition? First partition, second partition, third partition, and so on. And so on. So, and so on. What is the understanding of this? That if you add all of these, you'll end up with what? If you add all of this, you'll end up with the whole union. Okay, the whole union or 1. Okay, if you add E1, E2, E3, you'll end up with union, or basically in this case probability of the union, which is 1. Okay, confusing, sir. Let's not have any of those. if I'm adding, okay, if I'm adding like this, let's say I'm adding E1, E2, so on all the way till En, I get union only. And if I take probability, it will be 1. What it means? It means exhaustive in nature. Exhaustive. If you take all together means collectively exhaustive in nature. Collectively exhaustive. All the events are, all the partitions are collectively exhaustive in nature. Means when you add up, it becomes union, or take probability, it becomes 1. And they're also mutually exclusive. What it means, it's mutually exclusive, means there's no intersection. Intersection of E1 with E2 is what? 0 or null set. We have two conditions to define a partition. First condition was this one. Second condition is over here. Collectively exhaustive means when you add all the events, it becomes the whole, and mutually exclusive means nothing in common. So E1 intersection with E2, or any case you take, will be phi. Check the question now. They are asking what? EI intersection with EJ is equal to phi. It means the I has to be not equal to J. Check here, this is 1 and 2. This will be 0 only when the event, the partition will be different, okay? So whenever the I and J are different means the partition is different. The partition is different, okay? In that case, what will happen? It will be a null result, okay? Nothing in common. So answer is, excuse me, option B. Answer is option B. So this is the end of your 12 MCQs, or 12 very good questions in the chapter probability. Next, 2-3 markers. 2-3 markers. PYQ from 2023 paper. If A and B are two events such that PA is 1 by 4, PB is 1 by 2, and PA intersection B is 1 by 8, they are asking us not A means A dash intersection with B dash. Okay? Whenever you see dash, no, use this. Whenever you see dash, use this. This is A and this is B. Not A dash means what, bacha? Not A dash means everything over here. Everything is not A dash. Not A dash basically means only B, right? And the whole. Check here. This is not A dash. This is not A dash. And not B dash is what? Sorry, not B is, not A is this red one, not B. Not B. Okay, not B dash actually, not B. Not B will be everything what? Everything but, what do you call? This one. So we'll have everything over here. I can draw it, okay? I can draw it separately. So we'll have this, and this is your A and B. I'm looking for B dash. It becomes all of this and only A. They're saying intersection of those two. Intersection of those two. Check. You'll have the result as intersection of those two will be what? Only. So only the outside part. There's nothing over here. Only the outside part. What it means? It means 1 minus P A union. Sorry. 1 minus P A union B. Makes sense or not? Please check. Right? This means 1 minus P A union B. This is A union B. So from whole is what? PU. What is PU? 1. So from PU remove the union of A and B. Check here. P of A 1 by 4. P of B 1 by 2 minus 1 by 8. Change the signs. You will have LCM is 8. Here you will have 8 minus 2 minus 4 plus 1. Correct, no? Check here. This is minus, this is minus, this will be plus. So 4 2s are means 2, 2 4s are means again 2 4s are right. So 1 4s is 4, correct? And 8 1s are means 1 1. So 9 minus 6. So 3. This is your answer. 3 by 8 is your final answer. Please check. 2 marker. Question number 14. You want to check one more time? Question number 14 now. Bayes theorem question. Very simple. Of the student, how do you solve this question? So first you see what they have given. This is the first two statement, and then you check the last statement. Then you check the last statement. Okay.
of the students in the college, it is known that 60% of them reside in a hostel. Means probability of picking a student and his hostler will be what? 60 by 100. So 6 by 10. Wait. Probability of picking a student and he is a hostler is what? 60%. So 60 by 100. So 6 by 10. And a day scholar is what? Day scholar will be what is it? 40%. So 4 by 10. Okay. Now forget about everything else. What are they asking? One student is chosen at random from the college and he has A grade. Means you have already chosen a student. He has the grade A. He has the grade A. Excuse me. Very important. Now they're saying that you want the student to be a hostler. So H. You're looking for this statement. Looking for this statement. Find what they're asking. And then you can just simply find the later remaining values. A, H, A. This is I've taken as S, right? I've taken as S. No problem. Check here. A student who is a hostler and what do you call? Getting that A grade. What is that? Hostler and A grade? 30%. So 3 by 10. 30%, so 3 by 10. And who's a day scholar and gets 20% as A grade will be your 2 by 10. Applies the base theorem now. We're looking for PHA. This is nothing but PAH into PH. What is it? A student who's a hostler and gets a A grade and divide by total probability. So this is nothing. What is this, bacha? This is nothing but. What is this? The numerator comes from the conditional probability. Okay. PAH into PH comes from this one. Okay. Now what is this? Divided by total probability. So you'll have here, please check. Excuse me. PAH into PH. The first one repeats. And PAS into PS. You have the values. So write it down. Right. Check here. So we have AH as 3 by 10 into getting the hostler 6 by 10 divided by same thing 3 by 10 6 by 10 plus here we have PAS 2 by 10 and this we have 4 by 10. Check. So I can cancel over here something. Yes, 10 10 10 10 10 10 is cancelled. Take 100 common and cancel in both sides. Okay, I get 18 in the numerator. Over here I get 18 plus 202. So 8. 18 plus what is this? 8 plus 8 is 16. So 26. Simplify. 9 by 13 is the final answer. 9 by 13 is the final answer. Can a question get easier than this? This is the word problem. Students get scared of this kind of question, base theorem. What did I tell you? Simply find the first two statements, values, and check what are they asking. From there everything becomes reversed and easy. Next. Have a look one more time. Question number 15 now. The probability of obtaining no head appears when two coins are tossed. No head means both tails. So 1 by 4. When two coins are tossed, we have total of will be what? 4 chances or 4 outcomes. How do we know that, sir? The formula is M to N. What does M represents? Number of outcomes in one event. And what does N represents? Number of events. Check here. You're tossing a coin means you have 2 chances. And what? How many coins you're tossing? You're tossing 2 coins. So 2. Answer is what? 4. So total is 4. And you want a case with no heads. Means both tails. So this is the case. Hence the required probability is what? 1 by 4. This is your answer. 2 marker. Can be asked in. This is the simplest question in all of the questions that we have solved so far. Can be asked in 2 marker or in MCQs. Okay. It's a PYQ. 16. Another question I think on the base theorem. Have a look. Bag 1 contains 3 red, 4 black balls. So B1 has 3 red, 4 blacks, and B2 has 5 reds and 6 blacks. The probability of picking the bag 1 and bag 2, since they are not rigged, will be 1 by 2. There are 2 bags. Chances of me picking one will be what? Half a chance. There are 2 bags. Chances of me picking one of them will be what? Half a chance. So 1 by 2. Okay. Now let's look at the question statement. What are they asking? One ball is drawn at random from one of the bags and it is found to be red. We have got the ball to be red first of all. Okay. Now I want the red ball from bag 2. Question statement. That's what they're asking. So find the other cases. Red from the bag 1 will be what? Red from bag 1. 3 by 7. Probability of getting a red. Excuse me. Probability of getting a red from bag 2. What is that? 5 by 11. This is 5, right? So 5 by 11. Got it? Now let's apply the Bayes theorem. I'm looking for, what is it? Red from the bag 2. What I'll have? P, same thing, R B2 into P B2. This we get from the conditional probability. And we have same thing, PR B2 P B2 plus probability of, one second, PR B1 into P B1. Check the values now. 5 by 11 into 1 by 2 divided by, same thing, 5 by 11, 1 by 2 plus 3 by 7 and 1 by 2, because PB1 and PB2 is both 1 by 2 only. Okay, calculations now. 1 by 2, 1 by 2, 1 by 2 is cancelled. What I have left? 5 by 11 divided by 5 by 11 plus 3 by 7. Add them. 5 by 11 in the numerator. Take the LCM over here, we get 77. And we get here 5 into 7, so 35. And 3 into 11 is 33. I'm getting here 5 by 11 divided by 68 by 77. Looks difficult? It is not. Check here. 11 times 7 is 77. I get what? 5 upon 68 by 7. 7 goes up. So we have 35 by 68. That's the final answer, please. Be careful and check. Okay, sir. Bayes theorem question. So I have taken all the different types of questions that will that are from the syllabus. Okay. PA is this, PB is this. This is very easy. PA intersection B by PB. 0.2, right? By 0.3. Answer is what? 2 by 3. That's it. 2 marker. Right? Correct? Yeah. Next. A fair coin and an unbiased die. Tossed. Coin can give me head or tail. Die can give me 1 to 6. Head appears on the coin. Okay, head appears. Probability of getting the head will be what? 1 by 2. Probability of getting what? 3 on this will be what? 1 by 6. Correct? No. The total of how many occurrences when you throw a die? You get 6 occurrences. 1, 2, 3, 4, 5, 6. You're getting a 3 means chances are 1 by 6. Okay. They're looking for independent. Try this out. What is the meaning of A intersection B? It means I should get H and 3. Right? H and 1, H and 2 like that. H and 1 till H and 6. 1 occurrences. H and 1, T1 till T6. Correct, na? Check here. We have H1, H2. Excuse me. Let me write it better. So we can have here H1, H2 till H6, and we have here T1 till T6. Total of 12 probabilities are there. And we want only H3, which is only one case. So what is the answer? 1 by 12. I should not have repeated this. Not required. Yeah. What is the answer? 1 by 12. Multiply these two. P of H into P of 3. So 1 by 2 into 1 by 6. What is the answer? 1 by 12, which is nothing but P of A intersection B. Hence, A and B are independent events. Independent events. Got it? Okay, last two questions. 19th. A bag contains 4 red and 4 blacks. Okay, bag 2 is also there. So bag 1 is 4 red and 4 black. Bag 2 is also there. Okay, 2 reds and 6 blacks. Picking the bag will be what? Random. So PB1 equals to PB2 equals to 1 by 2. Picking the first bag or second bag will be what? Half chances. So 1 by 2. Okay. And a ball is drawn from the bag which is found to be red. Okay. Means we have got a red ball. We want it to be from the first bag. So B1. This is the question statement. Okay. Let's try. R B1 will be what? Red of the bag 1. 4 by 4. So 1 by 2. 4 by 4. 4 by 8. No. 4 reds, 4 blacks. So 1 by 2. P of red on the bag B2. What is that? 2 by 6. How much is that? 1 by 3. Bayes theorem. So PB1 R will be PR B1 into PB1 divided by PR B1 into PB1 plus PR B2 into PB2, the total probability. RB1 is what? 1 by 2 and PB1 is again 1 by 2. So 1 by 2 into 1 by 2. Over here we have same thing 1 by 4 plus, I can do better, 1 by 2, 1 by 2 plus PRB2 1 by 3 and 1 by 2. Please cross check. 1 by 2, 1 by 2, 1 by 2 is cancelled. So I have here only 1 by 2 left in the numerator. And over here we have 1 by 2 plus 1 by 3. 1 by 2 is over there. LCM you take. We'll have LCM is 6. And we have here 3 plus 2. Okay. 2 and this will cancel with 3. I have 1 upon 5 upon 3. Answer is what? 3 upon 5. This is what? Pick the red ball from the bag 1. Pick the red ball from the bag 1. Check. Okay. Next. PAB, they ask us to find this simple question, 2 marker. PA intersection B upon PB. There's no challenge over here. 0.32 by 0.5. 1, 2. Cancel. 32 upon 5 into 10. 5 6 is 5 6 is what is it? 30. 0.54 to 20 by 10. So 0.64 is the answer. Okay, that's your answer. This is the end of your session. The questions on your probability chapter, the most expected and the PYQs. Okay.